If you want to learn AI fundamentals in one short video which will literally hold your hand and will teach you everything from scratch, then this video is made for you, because in this video you will learn literally everything, including how to work with large language models using clients, language model architecture, embeddings and vectors, vector databases, end-to-end RAG solution, tool calling and tool binding, schema validation with Pydantic, semantic chunking, and you know what? You will literally build an end-to-end React agent using Langchain, which will literally be able to perform anything you want to do. Wow. But why I have added so much in this particular masterclass? The answer is simple. Now, organizations want you to build the data solutions which are reliable with AI solutions. And not just this. Now, you have to wear multiple hats in your organization. You cannot say that,
hey, I was hired as XYZ, why should I just work on this particular project?
No, you are already seeing the layoffs around you, bro. In short, you just need to upgrade your profile and portfolio, because those days are gone when people are working with strict boundaries across their titles. And the good news is this is the only masterclass video you need to watch if you are a beginner, because you will learn all of the concepts with the help of amazing hand-drawn doodles, and you will do hands-on as well using code files and code examples. Plus you will get all of the resources that you'll be using throughout this video. So that means this is a complete package. The intent behind making this video is very simple, just to help you, all of my data family members who want to grow in their domain in this AI era and want to make their career AI proof, and that's it. And I just need one support from your side, because it takes a lot of time and effort to create these masterclasses and providing it for free. So if you genuinely want to support my hard work, and if you want me to continue with these kinds of masterclasses, simply hit the subscribe button, share this video with your friends, drop a lovely comment, like the video, and let's get started with this amazing masterclass. So what's up my fam? Happy Sunday on your special request. Finally, Ansh Lamba is here with another video, and this is an amazing video, bro. Amazing video, because AI masterclass. Every single domain, finance, HR, accounting, whatever, has already started implementing, integrating, using AI. And you in the data domain still thinking, we will learn when it will be just required, when someone will force us, only then we will learn. Bro, you are in 2026, okay? And do not just wait much, because now it's the high time to learn AI. That's why obviously you have clicked on this video, because you know the importance of learning AI in today's era. So let me just quickly tell you the agenda of this video plus the prerequisites of this video, so that you have a clear understanding and you would know that you should just go with this. Okay, so let me just expand this, and we have total 3 sections under this particular masterclass: prerequisites, beginner and practitioner. So let me just quickly go to prerequisites, and I know you are waiting for this one. So you need to know Python and SQL, and that's it. Because this video, this masterclass is built in such a way, as I just mentioned in the introduction as well, that this particular video is for beginners as well. You do not need any kind of AI knowledge, nothing, but you need Python and SQL knowledge, because Python and SQL are non-negotiable for data domain. Forget about AI. It is like non-negotiable for data domain as well. So go and learn Python and SQL. And if you already know Python and SQL, I would simply say just you are good to go. Simple. Okay, so prerequisites are done. So very well done. Congratulations. Then we can go to our next thing called beginner. This is the stage where we are going to learn all of the non-negotiable for the AI. Okay, simple. Let's see what do we have inside this and what you will be learning. So here we have major 3 sections: LLM, prompt engineering and RAG. The major time we will spend on LLM and RAG, not much on prompt engineering, because see, you are a data analyst, you know how to write SQL. The person who can write SQL can easily write better prompts, but do not worry, I will still give you some like high level overview, like how you should write prompts, but this is like a very common sense thing. Even school students are writing prompts, talking to ChatGPT, so this is not directly related to us, but it's some types like React prompts are very crucial when you're building agents. So it is like indirectly important, so that is why I have included this section as well. Simple. So we will learn about LLM, we will learn about prompt engineering little, and then detailed about like RAG is our thing. Okay, RAG is our thing. If let's say software engineer is building RAG, okay, then you should think about it, because RAG means you want to retrieve basically some data. Who retrieves the data? We data professionals. Okay, so I don't know, like, what are you waiting for to build RAGs for your organization? And then you say, bro, what is going on in the industry? So this is the beginner stage. Once you learn these three major areas, then we gonna go to the practitioner level. Practitioner level means when we actually apply all of this knowledge to build something. So here we'll be building AI agents. Yes, and here we'll be learning about a very popular framework called Langchain, because Langchain is one of the open source frameworks. So I do not want you to spend any amount on cloud hosted AI agentic frameworks. You can simply go with Langchain. It is open source and it is very well integrated with Python. So if you know already Python, you can easily work with Langchain as well. Basically, Langchain is a like kind of Pythonic library. It has some support with TypeScript as well, obviously, because TypeScript and JavaScript is everywhere. But yeah, it is very well integrated with Python. So very well done. So these are the things that we are going to learn under this video, and you already know the prerequisites as well. And we have a clear agenda what we are going to achieve. We are going to learn everything, and we will become someone in the data domain who knows about AI, who know about how AI is working, how to build relevant solutions for the data domain. Simple, very good. So let's get started. And before that, my favorite part, I want to congratulate my data fam who have recently cracked offers, and I would just add more, but by this time I have just skipped some DMs and all. So yeah, we have some more people as well, but these are the latest ones that have cracked offers, and I'm very proud of my data fam. So let's try to congratulate to all of these people together. So say a big congratulations, because there are so many people. Congratulations. Very well done. And do you know what? These are all of the offers that we have got in the past few months, like overall, and the recent ones are in the beginning. So I am very happy. I am very happy. Why? Because you are actually representing our data family. Okay. So that means, and that gives a very strong message that, okay, this is the family that you should join in order to just achieve or crack your dream offers. Very well done. So if you have not subscribed to this channel, just hit the subscribe button to become the part of this lovely data family. And this is me, Ansh Lamba, your only Ansh Lamba. So yeah, this is about the introduction of this video. So let's get started with our hands-on, and just take out your notes, like notebook and pen, whatever notepad. If you are like very rich, you will have your iPad. So just take it out. We will take a lot of notes together. Okay, let's see. So in this AI masterclass, first of all, let me just ask you a simple question. AI has been around since so long. Why are you learning AI right now? Because it is currently booming. And do you know what? It actually started booming, or basically the triggering point was around late 2020 when ChatGPT went live, right? If you were the early adopter of ChatGPT, you would know that back in the days, it was totally a kind of black box. Like, we just ask a question and we get something. Obviously the answers were not very accurate, and like everyone made a fun whenever you used to ask any mathematical question. It was not able to solve anything if you were the early adopter of AI. Okay, then they started fine-tuning their models, they added some tools, they did a lot of things, and now AI is at such a level. LLM models are like such a great level. They have actually achieved something which is like actually something that we should just obviously praise, right? So now let's get started with the very first concept, because I just took a name, LLM, right? What is LLM? Okay, let's start talking about it, because this is the very first question that I should ask you. Simple. Okay, very good. So let's create that question, LLM. Okay, simple. What is LLM? And trust me, this is that particular question that will open so many doors to your concepts, to your all of these things, right? To a lot of things. Okay, first of all, what is LLM? Everyone knows the full form. Everyone, even if the person doesn't know what is LLM, they would know the full form, large language model. Okay, that's actually correct, large language model. But when I say large language model, what do I mean? Some of you would say, it is a language model which is large. It is a language model which is trained on large data. See, it is 100% accurate. it is partially correct. First of all, okay, it is correct, you are right, clapping, but it is partially correct. So now you will really understand the meaning of LLM, okay, because only then you will be able to work with LLM better. First of all, okay, so just keep your eyes open and just understand this concept. First of all, yes, large language model is actually a language model which is trained on the large corpus of data. This is true, but partially true. Let me just tell you why. Because if you do not know the meaning of language model, then this definition is partially correct, right? Because if you say LLM is also a language model, let's say I will write it. LLM is a language model trained on large corpus of data. Simple. This is your definition, and this is the definition that you have memorized, right? So this is actually right, and this is the black box. Language model. Language model. What is this particular language model here? What is this thing? This is the black box. Okay. So now just tell me, what is a language model? This is the whole thing. So now let me just tell you that what is a language model. This is fine, large corpus of data, and we know, we data professional knows like what large corpus of data means, that we have so many data frames, we have so many, you can say, pre-trained data, we have data in the form of PDFs, text file, whatever. We know large corpus of data. What does it mean? Simple. We know that we can just get the data from cloud, from APIs, everywhere. But what is this language model? Let's try to understand it. Language model is nothing but a kind of application, because model is what? A kind of application, right? The code that you have written. Language model is a kind of application that predicts the next word, and that's it. Okay, so language model is actually, and this is a definition that I'm just using to explain you. Okay, if you want to just memorize the definitions, go to Wikipedia, memorize it. Okay, good for you. But if you want to understand the meaning, this is a definition that you should always refer to. So language model is actually an application or computer application, computer code application that predicts the next word or next token. You will understand word or token, but for now we will write word. Simple. Next word. Ansh, Lamba, how can someone predict the next thing? How? Obviously based on the data. So here the definition becomes, language model is actually an application that predicts the next word, but taking or basically considering the existing data. Okay, so let's say I have a statement, cat will sit on something. Okay, something. So now language model will predict this particular blank. This is the thing, this one. Okay, language model will predict this thing, and language model will use everything. What is everything here? This is the thing, cat will sit on all of these things. Simple. Everything. So this is your language model. Language model will take the context from whatever you have provided. Simple. Make sense? So in simpler terms, it just answers one question. What question? This is the context. Okay, what is the next word? Again, we will use the word token. Okay, if you are a technical person, do not feel like, hey, it is token, it is not a word. Wait, hold on. I know you know everything, but hold on. Okay, so now it predicts the next word taking the context. This is the context, this is the next token. It can be, let's say, mat, because mat is a very popular example. Cat sat on mat in the AI engineering field. Okay, cat sat on mat. Okay, but in our case, let's say it sat on sofa. Let's say we have provided some privileges. Let's say sofa. Okay, so cat will sit on sofa. So we can say this thing. It's our example. Okay, so this is the common simple definition. This is the context, predict the next token, and that's it, or next word, that's it. So do you know what you will say? Like, Ansh, this is like not a magic. What is the actually the technical thing behind this particular final product that we are seeing? So basically, if you are coming from the mathematics background, and what is mathematics background? Obviously you would not have done bachelor's in mathematics like me, but you would have studied mathematics in your school, right? And by the way, I do not remember anything that the mathematics that I studied in the university. I do not remember anything. But yeah, you would know anything related to mathematics that you studied in your school, because school is school. Like, you remember everything in school, right? So in school, you would have read something about probabilities, right? So here, the probability will look like, if you have studied about Bayes theorem. Okay, Ansh, Lamba, do not flex your mathematics. Okay, so you would have studied like Bayes theorem and all, and it was in school as well. Okay, just go to class 11th book NCRT chapter 15 or 16. I hope so it is like that chapter, or 14, I guess, I don't know. So now you just need to use the formula of Bayes theorem, and Bayes theorem basically means the conditional probability. Conditional probability means you want to define the probability, you want to predict something on the basis of something. So here we want to predict our next word, and on what context? Previous context, or whatever context I have provided. Simple. This is your formula. This is the statistics behind this particular entire thing. Obviously, this is like complex statistics, but this is like, you can say, backbone of everything that we are doing. At the end of the day, we just need to find the conditional probability, and that's it. Simple. So just need to remember this thing, or do not even need to remember, just understand the thing that we are just trying to discuss here. Simple. Okay, makes sense. Now this is your language model. Now when this language model was trained on large corpus of data, it become LLM. Yes, it is exactly true. I'm not denying it is exactly true, but here is the catch. Do you know what? Language model, like LLM, not language, LLM, large language model, is new. But Ansh, Lamba, obviously there would be some models that we were using before LLM. LLM was like very popular after 2022. But before that, what were these strategies we were using? That's a very good question. So language model is not just tied to large language model. There were some techniques. Okay, what techniques? First of all, the very popular technique was statistical techniques, such as n-grams. N-grams means like bigrams, trigrams. So let me just explain you that thing. That is very simple. So I think Gmail still uses that thing in maybe in the legacy systems, or maybe in the current one, I don't know. So what it will do, it will create the bigrams. Bigrams means cat will sit on sofa. Bigrams, coupling. Bi means two, right? Bigrams. So it will be trained on the data with the bigrams. Cat will sit on something. So if it is trained on the data where on is linked to a word, let's say sofa, so it will say sofa, because it is trained on that particular bigram. Obviously considering the entire corpus of data it is trained on, but still. Make sense? So it is like a very popular technique, bigrams. Okay. Then after that, we were introduced with something RNN, neural networks, and this become very, very complex because only machine learning engineers were able to work with this, obviously, because it was not very easy thing to debug or to understand or to create your neural networks. Again, it's not impossible, but it required a dedicated domain in itself. Simple. But then this new era is actually called LLM era, the third iteration. Statistical era, neural era, and then LLM era. LLM era means we work with transformers. What did I say? Transformers. Okay. Transformers architecture. We keep transformers as the basis, as the, you can say, backbone of LLM. LLM is nothing without transformer, or basically I would say LLM is just a fancy word for transformers architecture. Simple. Make sense? What is transformers? You do not need to worry about that thing for now. Just try to understand that this is the kind of backbone of LLM, and this is the new era. Here in the transformers era, the beautiful thing that happened is companies, organizations, dedicated organizations, the big organizations started building their LLM. What are the popular names? Okay, let's talk about that before discussing transformers. So the popular names are obviously ChatGPT, right? Or let's say OpenAI more specifically, because OpenAI is a parent company, ChatGPT is just a product. So OpenAI. Then we have Gemini, or basically Google. But let's use Gemini because Google is a very diverse company. Gemini, or let's say for Anthropic. These are the big names. We have other names as well like Grok and all, but it's fine. So these are the major players in the market. Correct? Simple. Okay, very good. Now what they did, they created the LLMs for you. What does it mean? So let's say you do not need to create any kind of LLM from scratch. You just need to use those LLMs. That's it. Okay. And this didn't happen in the neural era. Why? Because all the companies were creating their own customized neural networks for their small use cases. These big organizations at the same time were working on something big. They were building something that can work on all of the use cases. Are you getting my point? So they created LLM and it took over all of those small neural networks, and now almost everywhere large language model is being used. I am not saying that it has totally replaced neural networks, not at all, first of all, because you still need to do a lot of fine tunings, lot of LoRa fine tuning if you have done it. But I'm just saying that it has traditionally replaced those like small neural networks that you need to build from scratch every time in every organization. You do not need to build this thing in every organization. Simple. I think the intent is very clear now. What is LLM and how it came into the market and why it is big, why it has become such a big thing. So now if anyone asks you, are you a data person? Yes. Okay. Can you please tell me what is LLM? Now you should have a crystal clear answer what is LLM, and not just theoretical definitions written on Wikipedia. Definition plus concept plus architecture plus why behind LLM. Why did we introduce LLM? Make sense? Make sense? Okay, I hope it makes sense now, and we just covered this thing in such a detail because it was required. Now we need to talk about transformers. Now what are these transformers? Because remember, in LLM, let me just share that particular structure guide that we are going to discuss here. So here, this is our lovely roadmap that we are just going to cover. So in the LLM section, we have the very first thing, API call. Okay. Then we need to learn about how LLM generates. Okay. And within this, we have architecture. We have what? LLM architecture, or basically transformers. So this is the area that is linked to that particular thing. Okay, makes sense. But before that, you still need to cover this thing. So just relax. But I want to still give you some hint that you are prepared for the transformers, because transformers are very important and you cannot skip it. No one is asking you to create a transformer or basically LLM from scratch, but you should know how transformer is working. Simple. Okay. So now we will just discuss transformers as well. Do not worry at all, because we are not just scratching the surface. We are going deeper and deeper and with hands-on. So now I want to just practically show you this LLM step, and you will love this a lot, because when you see the things with your eyes, when you just actually do the things with your hands, you actually learn better. Okay. So now what we are going to do, we will simply create our own, not LLM from scratch, not at all. We will write our code to use these LLMs. You will say, Ansh, Lamba, do you know what? I have a special software called ChatGPT and I can use that ChatGPT. So now I know this is ChatGPT. This is a kind of product that is built on top of LLM. We can talk to LLM from here. Let's say, hey bro, what is LLM? It can also tell me, right? So it will just give me blah blah statement and definitions. Okay. Now this is the way to talk to LLM. Okay. But this is the product. This is the final product that is built for the user. But you are a developer. Let's say you need to build something for an organization that involves LLM in the use case. Because this is a Q&A. Maybe you are not building a Q&A. Or maybe let's say you are building a Q&A for your own organization. You are building Q&A for your own data. Let's say. So there you need to use LLM, right? You cannot just put everything on ChatGPT. It is not like a recommended option. Now, here you cannot ask question like this. Now you need to talk to LLM directly, face to face, without any kind of product. So here, whenever you want to talk to any LLM, it can be ChatGPT, it can be Gemini, it can be your Claude desktop application, anything. you need to directly make the API calls to the agents, or basically LLM, not agents. Okay, so now let's try to cover that thing. So transformers, okay, we will cover it, don't worry. So now what will happen, let's say you are a user, you are this user and you want to talk to an LLM. Let's bring any LLM. Let's say this is an LLM, just imagine. Okay, and this is an LLM by OpenAI. So OpenAI has GPT series of models. GPT 5.4 I think is the latest one. So let's say you want to use this LLM and you want to talk to it. You want to, let's say, send something that I want to fetch data. Simple. Now this LLM will respond back. Really? Yes, directly. But using what? Using API. Using API. Without API, it cannot work. Simple. Simple. And this is, I think, common sense. Whenever you just need to get anything from any software or any data or any model, you need to just use the API. So now here this person can talk to this LLM and this LLM will respond back, let's say some some information, some response back, and that's it. So this is a very basic architecture that it works. Simple. You just send the request, you get the response back, and here you just simply set the API, and you also create the client, which is a common sense. Whenever you just want to talk to any application, you create the client. Simple. Okay, so now Ansh, Lamba, how can we just write the code for this? Like which language? So the good thing is every LLM, almost every LLM, not almost, I think every LLM provides Python client. Yes, provides Python client. You can create a client using Python and then you can just make an API call. You will get the response back. Ansh, Lamba, see, we have clicked on this video so that we can also see the practical. Okay, just show us how to do it. Okay, let me just show you. For the practical sessions that we are just going to follow, you would need some tools, or you can say applications on your system. The very first application you would need is VS Code editor or any code editor of your choice. I would say VS Code. You can just go with VS Code. Then one more thing that you would need, let's say, Python, because obviously you need to use Python, and I hope you will have Python installed on your PC or on your system. If it is not installed, I will just show you, don't worry. So VS Code and Python, what else? If anything else is required, I will just tell you, but this is fine, this is enough. You can also download Git, but let's forget about Git, because you will say, hey, how to set up Git and blah, blah, blah. But if you just want to learn Git, I have a dedicated course on Git as well, so do not worry at all. So VS Code and Python is good to go. So now let me show you how you can just download VS Code and Python. Simply go to your favorite browser, type download VS Code and click on the link and download on this machine, whatever machine you have. Go to new tab, search download Python and click on this thing. Do not click here because it will just download the latest version, which is 3.14, which is not very stable, and it is in the bug fix zone. So just download maybe 3.12 and 3.11. Both are good and both are in the yellow zone in the security, so both are good. So you can just search. So we have 3.11, simply click on download and that's it. I have 3.11, 3.12, 3.13 as well, but I didn't try 3.14. There are some good changes and there are some good, I would say, additions in 3.14. These are amazing. I haven't tried it extensively, but they are very, very good. They have introduced, I think, some f-strings advancements, but I haven't tried it in detail. So yeah, just go with 3.11, 3.12, 3.13, whatever. 3.13 is also good. So just that's it, these two things, and you are good to go. Let me just take you to my VS Code. Okay, so this is my VS Code editor. Your VS Code would look a little bit different because of some themes and some color palette. Okay, but do not worry at all, VS Code is VS Code. It is just a code editor. Okay, so simply create an empty folder. In my case, I have created AI fundamentals. If you do not know how to create it, don't worry, I will just tell you. Go to file, click on open folder and create a new empty folder like this. It should have nothing inside it, and that's it. Now simply open a terminal, and I will just open my terminal. You can also click on these three dots, click on this terminal, new terminal, and open it. Simple. Very good. So let me just ask you a simple question. What is the first thing we always do within any project? Bro, come on. We create a virtual environment if you are in the Python environment or basically working with Python. If you are working with Node or basically JavaScript, we do not create virtual environment, but with Python, we create virtual environment. Simple. So how to create Python virtual environment? You simply create it with pip. Pip when and then dot venv. I do not like creating virtual environment like this because I use UV. UV is a modern Python package manager which is very, very fast. It is built on top of Rust. You should also use it. And it is becoming new industry standard. So yeah. So now you can also download UV. It's very simple. Simply say pip install UV. In my case, it is already there. So in your case, it will download it. Then you can simply say UV version. Simple. In my case, it is 0.9. In your case, it will be something else. Simple. So now I can simply initiate my project with just one command. I will say UV init and hit enter. That's it. Boom. It will create these files automatically. Why? Because whenever you create any project in any other language, you would see that you get some demo files, some Python version to package your project. Simple. But you do not need to worry at all. Simple. Simply take care of one thing. If you just go to Python version, whatever version you will write here, it will automatically pick it. But just make sure that that Python version is available on your system. In my system, I have 3.11, 3.12, 3.13, so I can just put it anything. Okay, but in your case, if you have 3.11, by default, it will pick the same version. But let's say you want to use something else, because in your system, you can install multiple Python versions, right? So just a pro tip. Simple. We will just discuss a lot of pro tips for your development standards, because you are trusting this channel. So this channel will give you a lot of extra things as well, which are good for your development career. Simple. So now UV init is there. Now Ansh Lamba, I cannot see any virtual environment. Yeah, because I need to run one more command, UV sync. So what it will do, it will sync all of the dependencies and it will create a virtual environment for me. Sync dependencies. So simply go to toml file. So whatever dependencies I will write here, it will simply add all of those particular libraries. If I add it, it will add those. If I remove it, it will remove those. So it will simply sync my whole project with this toml file. Toml file is the brain of our project. Simple. But you do not need to do anything with this toml file. This is just for the packaging. Simple. Close it and simple. So here we are inside UV and we have installed everything. Now you need to create one special file. It is called .env file. Again, industry standard. We always create an environment file because we are working with APIs. Whenever you want to use API keys, we should never hard code those API keys and we should never store those API keys in Python file, text file, never. Always store those things in a .env file. Okay. So now here we need to create one API key. What API key? Let me just show you. So you simply need to create an API key. Let's say, so we have these options: OpenAI, Gemini, Anthropic. Actually, you can use Grok as well. So many, but let's say you have not started working with any kind of LLM. You are totally new. Then what you can do, you can simply go to OpenAI, because OpenAI is the most best, I would say, option for you to get started with your LLM journey. Okay, it's very simple. Dashboard is very easy to follow and you will get the API key like this. Simple. But if you are someone who is working with some other LLM, I will still recommend you to just create an API key with OpenAI, because I will just use some code within this. I can also show you with Gemini as well, but the intent is we need to work with LLM. So let's try to do one thing. Let's use OpenAI and Gemini both, so that you will know how to just do all of these things. Simple. So now what I will do, I will simply go to my OpenAI. So you can also search OpenAI API. Do not search ChatGPT, because ChatGPT is different thing. OpenAI is actually the parent company. So go to API platform, and this is the platform that you should just go. Click on start building and click on API dashboard. Simple. Click here. And here you just need to put your email address. If you are new, you can just go with any account. If you already have an account, simply choose that account and then you will land on the, you can say, your dashboard. Simple. So here is my, you can say, kind of dashboard for OpenAI. In your case, if you just want to reach here, simply go to settings button and simply click on the API keys, okay? And you will reach on this particular page. Here you need to create an API key. So I can just create it in front of you. So I will simply say create a new secret key. I can say AI tutorial, simple, select a project, default project, and create a secret key, and that's it. So it has created this particular API key. I can just copy it because after that it will not be allowed to copy this particular thing. So I will simply say done. Okay, simple, and I can just save it here just for now. Now what will happen? You can use this API key. Oh wow, it is so simple. Yes, it is simple, but OpenAI, do you know Sam Altman? Like, is he your friend or like brother or cousin? No, obviously, right? So you need to pay to him like whatever API you are using. So now here what you need to do, you simply need to add some amount that you will be just using to make the API calls. Simple. So simply go to billing, and here I have some amount left, 9.99. You can also add maybe 10 bucks, 5 bucks. I think the minimum amount is 5 bucks. You can simply recharge it and go to add to credit balance, and it will simply add that amount in your dashboard, in your basically account. When you have the amount, you can use the API key to make the API calls. Simple. And then you will be able to use the LLM. Will 5 bucks be enough for this particular video? More than enough, like more into 100 times enough. So you do not need to worry about that thing. But yeah, you just need to put some amount so that you can just make some API calls, because I will still show you the pricing, because the models that we will be using are not very expensive in terms of text generation, because LLM models are becoming more and more cheaper with the course of time. And now we can just work with high level APIs, high level LLMs with such a low cost. Simple. Because obviously you are not generating a lot of data from LLMs. We are simply getting data, like very few data back from LLM. So it will not charge you much, but again, it depends upon you, how you just make the API calls. So do not worry at all. I will just guide you. So simply put some amount and that's it. So it is not like a pay as you go. That is the best thing about OpenAI. If you go to Gemini, it is pay as you go. So you need to be very cautious, because you will get the bill. But here it is just like top up. You simply recharge and you just make the calls. That's it. There's no, you can say, pay as you go. So here you can also go to Google AI Studio. So this is my Gemini dashboard for this particular video, and how to reach there. Just simply go to Google and search Google AI Studio. Let me show you. Simply search Google AI Studio. Click here and you will land on this page, and simply just do whatever you want to do. Okay, simple, very good. So that's it. So here you can just go to dashboard, and it will just take you to the dashboard, and that's it. You can just create an API key here as well. Create API key like this, simple. And by default you also get some, like one, you can say API key default. You can create multiple ones, but here you need to just set up the billing. And in the Google AI APIs, you need to set up your Google Cloud account with the Google AI Studio. So it is like just unified account. So here you have to just connect your Google Cloud account with this particular thing, and then you can just access the API key. Simple. So if you just want to go with this particular thing, like where you can just connect a Google Cloud account, okay, then this is the way, create API key. OpenAI is like much simpler. So I have just showed you both the ways. I will also show you the practical session for both the ways. So not a big deal at all. Simple. As you can see, currently I am seeing setup billing. So this is just a free tier. Okay. But in my paid account, I have just set up a kind of, you can say billing for this one as well. So it is fine. But if you just want to go with OpenAI only, it's more than enough. It's more than enough. It's just like showing you multiple ways to do the work, to talk to LLM or multiple LLMs. Simple. Very well done. And this is kind of my paid account where I have just set up the billing. Simple, very good. So let me just quickly create a new API key for this particular thing. Name your key, it will be like AI tutorial again for Gemini, and create key. Let's copy our key, and obviously I will just remove it, so do not need to worry at all. So this is my key. Where is that? What is my key name? Oh, okay, so there are like two keys. So I think this is the one for my AI tutorial. Yeah, so I will simply copy this one, and I can just save it, and I can just keep it along with that particular thing. So directly go to VS Code. Okay, so this is my VS Code. So now what I will do, I will create one environment variable first of all for my Gemini, or basically Google API key. Okay, Gemini API key. If you are not using Gemini model, simply skip it, do not need to worry at all. So I am just using it, so I'm simply putting it here. Simple. So let me just put it, and then I will just hide it. So I have created one .env.example file. So this is the file that we share with the other, like with the repositories, with the GitHub, on the GitHub, so that you can also see what are the environment variables that you need to create. Simple. So here we do not like put the real values, but we simply simulate it. So let's say Gemini API key, simple. And let's say your Gemini API key like this. Okay, simple. So this is the way. So that is why it is called .env.example. Simple. So this is the first key. If you are not using Gemini model, it's totally fine. Simply skip it. So now the second model, I can just put it, and you would be using this particular thing, right? Let me just put this one. So this is my OpenAI API key, and most of you would just put this particular environment variable. Simple. And here your OpenAI API key, and I will just put the real value inside .env. So you need to just create a .env file. Your variable name should be the same, but your values, these values should be the real values. Simple. I hope you got the concept. So I have done the both the things. Okay, so now let's do one thing. Let's create a new folder here. Let me just close all the files. Simple. So I will simply create a new folder, and I will simply say LLMs. Simple. And here let's create our first notebook, and it will be like API calls .ipynb, because you'll be just working with notebook. So here I can select the kernel, first of all, Python environments, and here I'm not seeing my virtual environment. Why? Because these are all of my global environments. I think this is a VS Code issue. Simply click on refresh. Yeah, this is my virtual environment now. I have selected this thing. So make sure this is the environment selected, because we need to install a lot of packages as well, right? So this is my environment, which is this one, and then I can create the cell. So now what I need to do, I need to first of all make the API call with the LLM, right? So for that, I will just show you that how we can just create the connection. So for that, you simply need to go to OpenAI documentation and simply say OpenAI API call, because every LLM has its own code, like Python code, to create the client. But I will also show you the way that you should use. But for that, you first need to understand the basics. So this is the code. I think it has just given to me on the basis of the documentation. So I can simply copy and paste this thing, because this would be available in the documentation as well. So you can also go it. Function calling OpenAI. Yeah, this one. So I can just scroll it down. It will just show me function calling. We are not learning function calling, so that is fine. So they are just showing us the tools. We can simply go to quick start. So this is the very simple Python code that we can just use to make the client, and that's what we want to do. Simple. So I will simply copy this code and put it here, and just change the type from Markdown to Python. Simple. So what I have done, I have first of all imported the OpenAI class. But Ansh Lamba, where is that class? You first need to install it. So you will simply go to terminal. You will say uv add OpenAI. Simple. It will add OpenAI package in your virtual environment. It will take some time because it is a big package, but nothing to worry. It is done. Simple. So OpenAI and OpenAI, and then we are creating a client with this OpenAI object. See, and once we have the client, I want to send a kind of question to my model, and I will get the response back. This is the simple concept that we have discussed, right? Now what I will do, I will use this object, client object, and then responses, and then dot create. This is a function that we have inside OpenAI SDK. We do not use OpenAI SDK directly. We use Langchain for that, but do not worry. Langchain's chapter will be coming very, very soon. But for now, you need to look at the raw code. Simple. Just see how LLMs are sending you the responses. Simple. Then we just need to pick the model. Now if I just go to the model section, I have a long list of models. So if I just go to in their model sections, OpenAI models, yeah, here models. So here 5.4, I told you this is the latest model, but we do not need to use 5.4. Okay, we can go with, I think, GPT 4.1. It is also fine. I think 5.1 nano or mini is also good. So let me just search view more, and GPT 5.4 compare models, view all. So here we will see GPT 5. Yeah, GPT 5 mini is, I think, cheap plus very good. Let me click here. So this is the one, GPT 5 mini. You can use it and you can see the cost for this particular model. So $0.25 is not per request. No, not at all. It is not that expensive. $0.25 per 1 million tokens. 1 million token means, let me just tell you. So let's say we want to write this question. So most probably there will be like, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 15, 16 tokens maximum. How do I know? Because just for now, we will just discuss this thing in the transformers. But for now, you can treat one word as one token. Okay. But sometimes one word is broken into multiple tokens. So that's why I just told you 15, 16 tokens and that's it. For 1 million tokens, you only pay $0.25. Can you imagine? 1 million tokens. So this is the input and the output is $2. Whatever tokens LLM will be generating will be $2 per 1 million tokens. Okay. And this is like batch API price. If you just go to like, this is like streaming API price. If you just go to batch API is like even more cheaper. So here it is like 0.125 and it is like almost half. Simple. What is the difference? You do not get the response in real time. Real time means not like the moment it generated the token, but it is still very fast. It is not like it will be very slow, not at all. Okay, so you will not be able to see the difference. So let's try to use this model and let me just copy the model name. So let me just copy this and let me just put it in my VS Code. I want to use this model. Simple. And I can just remove the date because they just put the date that when it was last updated. Okay, but we are good. So I will say write a one sentence bedtime. Bro, let me just change the question. Tell me a fun fact about data domain. Let's say, okay, and let's try to run this code and let's see what do we get. And yes, install, because it needs to install the IPy kernel. So let's wait. We will get the response directly from the LLM. No chat GPT is involved in this particular process. Simple. And now let's wait the moment it is running, because it is now currently downloading IPy kernel. It will take some time in the beginning. So now it is running. See. So now let's see what do we get here. And print. For the initial command, it can take a little bit longer, first of all. And now here's the response. Do you mean EMC's data domain, backup appliances, or the general notion of data domain? Quick fun facts. So it also just gave you some of the different angles of the question that I have picked. So EMC data domain, different answer. Data domain normally that we have. And a variable's domain is just the set of value it's allowed to take. Only changing the domain can completely change a problem solution. That's true. Example, equations can have different roots over integers versus reals. Yes, that's really true. So I have got two different fun fact about data domain. One is EMC data domain and generic data domain. So that's how you get response directly from the LLM. I didn't use ChatGPT. I didn't do anything. I directly make an API call to LLM. I got the response back and that's it. That is it. That's how you just create the client. So what did I use? OpenAI Python SDK. SDK means software development kit. Okay, simple, very good. So let me just write it. OpenAI SDK, simple. So if you're using OpenAI SDK, that's how you get the responses. Simple. Now let's discuss if you are using Gemini. Obviously, we should also see like how Gemini works. So let me just bring that screen here. And if I just go to documentation, let me just click here. Yeah, so this is the documentation. I just click on the left icon. And here I should just go to quick start. And here is the Gemini API, Python. So I just need to install Google GenAI. So this is the package that we use for the SDK. Simple. So I will simply say UV add in the terminal. UV add Google GenAI. So now it will download the GenAI SDK. Simple. Very good. And now let me just grab the client code, how I can just create the client. So this is the code for it. See, it is not very much different, but now because there are so many SDKs, so now they're just trying their best to keep their SDKs almost similar. But when only OpenAI was like dominating this industry and Google was like much behind and Grok was much behind and all of these like Claude were much behind, everyone had their different code. But now if I just paste the code, you will see it's much same. From Google, import GenAI, from OpenAI, import OpenAI, client, and here see, here we write client.models.generate content. Okay, generate content. And here we use client.responses.create. Why? Because there we have different functions. Here we have different functions, simple. But usually in the real industry, we do not use different SDKs at all. That's why I'm simply copy and pasting the code from the web. We write our own SDKs, kind of own SDKs, where we create these connections on our own, and we use the wrappers above on top of that. Make sense? And do not worry, you will learn that as well. That's why this video is for you. That's why. So this is your client, and now let's use Gemini 3 Flash Preview, because this is, I think, a good model, not very expensive, and this is the content that I want to ask. Let's ask the same question. Let's see what do we get. So here, let me just paste it, and here I can just put the markdown. Gemini SDK, simple. So if you're using OpenAI SDK, you need to run this code. If you're using Gemini SDK or like OpenAI SDK, then just use this code, simple. Simply run this and let's see what do we get. Let's see. And one more thing I forgot to add, but I will just add it right now. Don't worry at all. Because this is the beauty of like VS Code. It automatically does a lot of work for us, but I think this didn't do at all. The model is currently experiencing high demand. So, okay. So we also see some of these things. So we can just use other models if we have. Which model should we use? Because this is like in preview model. We should never use preview model in production, but I just used their, you can say, model that they were marketing. So we can just pick like any stable model, not a big deal. Just go to all models, and I can just pick this one, Gemini 2.5 Flash, and this is the model code, simple. Because the preview models, like as the name suggests, they are in preview, they are not in production, simple. And one more thing I want to do before running this code, because I know VS Code has done that work for me, but I want to just tell you. So whenever we just save any API key in the .env file, we need to make that environment variable available for our notebook. So here, if you just go to the documentation, here you will see that in the OpenAI API call as well, you will see, if I go to quick start or overview, simple, they are saying that I need to export this particular variable called OpenAI API key, but I didn't do that. Because VS Code automatically created environment variable for me, which are there in the .env file, but you should always manually create that as well. For that, we use a special package called .env. So simply add uv add .env, simple, very good. Now I can use this package from Python, perfect. From .env, import load.env. This is a function that we run, and I can simply run this function, load.env. What this function will do, this will create environment variables for me, which are there in this .env file. This is a kind of Python module that we use. And this is the way we should always work with the sensitive API keys or any kind of secrets or anything, simple. Then I can use import OS. Why? Because I need to import it just to check that my environment variables are there, because I know they are there, but still just to confirm. So I can simply say if os dot environ is the function .get. So just print OpenAI key set, and also say if Google API key is there, API key set. Just let's run this. So see, OpenAI API key is set, but Google API key is not set because the name is Gemini API key. Very good. See, this is the thing that we should add in our, to just add guardrails. Now we should see OpenAI API key set, Gemini API key set. Now, good. Now, in case of Google, in case of Gemini, do you know what? Let me just show you one thing. Here, if you just go to quick start, you will see that the basically variable name is this one, Gemini API key. But earlier it was like Google API key, or in some other frameworks it will be like Google API key. So you need to follow which environment variable they are asking you to create. Simple. But in our case, we created the nice, correct environment variable. So let me just rerun this. Let's see, what do we get? Now I hope we will get the response, because obviously everything is fine on our end. Nothing is wrong on our end. And let's wait. And I think this model is also like good model, not a very good model, because now we work with Gemini 3.1 Pro, the best model. So here are a few fun facts about data domain. They ignited a 2.1 billion bidding war in 2009. Data domain was a subject of dramatic bidding and blah 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 blah. See, so this is the thing that we have got from Gemini, and this is the thing that we have got from the OpenAI model. Now you know how to work with LLMs, at least like very basic example. Now you have a clear picture like how we can talk to LLMs directly without using ChatGPT or Claude desktop application or your Gemini application, nothing. Directly talk to the models. Simple. And that's how you do in the real world to build something, to develop something. Simple. So your LLM section is very well covered. Now let's talk about how you are getting the response back from this model, how it is able to understand this thing. This is written in pure English. Machine cannot understand English. How it is able to just give you the answer on this particular question, and it is also generating the answer in English. Wow. Why and how it is able to understand the intent, how it is able to understand the context behind this particular language. The power is, the beauty is transformers architecture. Now it's time to actually see behind the scenes to get a very strong understanding. Do not worry, we are not going much in deep for transformers because I have already created a very well in-depth video for LLM. It's I think 4 hours long course where we have discussed everything. But being in the data domain, when you do not need to know everything in LLM, but you still need to understand how architecture is working, or you can say you want to just get a high level overview how architecture is built, then we will be just covering everything in this particular section. But if you are interested to know how LLM actually works, the statistics behind it, not like entire statistics, but you can say the conceptual statistics like softmax, n-grams, and not n-grams, like LM head, all of these things, encoder only, decoder only, bidirectional, all of these things. If you have that particular interest, simply go on that particular video. I have created a detailed video on this, but here we are understanding the fundamentals for development, or for you can say developers. Simple. We just need to work with AI. Simple. But everything is there for you. If you want in-depth knowledge, it is there. If you want high level overview, it is there. So let's actually see it. So here is Ansh Lamba from Future. So I will just take a few seconds, and I just want to remind you that please hit the subscribe button for me, because recording and creating these videos actually take a lot of efforts and time. If you please want me to support my hard work, then please hit the subscribe button for me so that I can just bring more and more tutorials and masterclasses for you, and you can grow in your career. And that's it. Simply hit the subscribe button and that's it. Okay. So now let's talk about finally the transformers, because now you are ready to understand this concept. Because I personally feel when you actually make your hands dirty, okay, because when you just perform something, when you just play around something, you can actually relate with that technology better instead of directly understanding deeper and deeper concepts in a particular technology. So I just made you aware about these concepts, like how to make API calls. Now I think it would be your natural call to understand like how things are working behind the scenes. I personally feel this thing. I do not know exactly who you are, but I know you are my data family member. So you would be like very, very excited to learn actually how it is working behind the scenes. First of all, it is a kind of black box for you now. Okay. So you are this user. Okay. And you just make this call like this. Let's take this same example. This is you, and for you now this particular thing, this response, let's say you are asking a very simple question, and let's pick the very popular example. Let's create our own example. I want to eat. That's it. You just send this thing, I want to eat. Okay. And you didn't tell anything. Or let's say you get this thing in return. I want to eat chocolate or something. Okay. Simple. Okay. So you get something like this in response. Now for you, this thing is actually a kind of black box. Why? Because you are sending this data. Let me just make this arrow shortened. Okay. Okay. You are just sending this data like this. Let's say. Okay. I think this is stuck. Okay, now it's good. Perfect. So now you will say, I want to eat this chocolate, and you will get this response back. Simple. But here or let's say this returns the response here, so that I can just use the space to explain the exact architecture. Perfect. So this generates the output, right? This is a kind of output. This is the output. Simple. Now, currently this is a kind of black box. You actually do not know what is actually going on here. You simply send a query and you get something back. Simple. This is a kind of black box for now. Makes sense. Makes sense, because you do not know what is like this magical thing, but you are getting responses back. Okay, simple. Now let me just tell you what exactly will happen, or what exactly happen whenever you are asking something from GPT or any LLM, because all of the LLM models are most of the GPT styles, generative, pre-trained, transformer, something like that. Okay, but I will just explain you the concept. Simple. Full forms are not very important, concepts are more important. So now what will happen? First of all, there are multiple stages. Okay, the stage one is called, just take notes, because this concept is very important. So there'll be like multiple stages. Let's discuss the stage one. Stage one says tokenization. Okay, tokenization. This is the stage one, or you can say step one. Simple. Let me just add one dot tokenization. So now what will happen in this tokenization? First of all, this will, or let's say whatever you are using here, whatever LLM you're using, it will take your input and it will create tokens. Remember, we were using token every time in the beginning, but I said just for now you can imagine that token is equivalent to a word. In most of the cases, yes, it is still true, but sometimes we break some words into different tokens. Let's say this is token number one, this is token number one. Okay, and then we have another token for this one, I want. Then we have this token 2, and then we have one more token. Simple. When we have bigger words, let's say I am eating, so eat will have a different token, ing will have a different token. If I have some words which have hyphens in the middle, okay, let's say hands on, so I will just add hyphen. So hand will get a different token, s will get a different token, hyphen will get a different token, on will get a different token. And this totally depends, and this varies as per the model you use. And I want to show this practically as well. So let me just open a very popular library. It's called OpenAI Tokenizer, because we are using OpenAI model. So let's use their tokenizer. By the way, there is another very popular website, Tick Tokenizer, that is like very good if you want to visually see, but OpenAI Tokenizer is also good. Let's open it. OpenAI platform. Perfect. So now I can pick any model. Let's say I want to use GPT-4. I am not using GPT-5, so that is fine. Let's say I am writing something. I am eating. I hope this text is very visible. Let me expand it. Perfect. So I am eating chocolate. Perfect. So this is my text. So currently I am getting 4 tokens. Currently I am getting 4 tokens. 1 for I, second for I, like am, then 3 for eating, 4 for chocolate. And Lamba, you were saying that you will get 2 tokens for eating, 1 for eat, another for ing. See, bro, with the course of time, large language models are becoming more and more efficient. So they do not create granular tokens. They can understand the concept as whole. So if I just switch to any previous model, I am so sure that they will just create multiple tokens. Okay, GPT-3 is also good. I think GPT-2 will create multiple models, or I can also show you some complex example. I'm eating chocolate and playing, let's say, cricket and doing hands-on, something like that. Okay, perfect. I got the thing. So here you can see there are total 12 tokens. Okay, I am eating chocolate and playing cricket and doing, so far each word is actually 1 token. But here hands-on, hands got the 1 token, hyphen got the another token, and on got the another token, because each token is actually a independent stuff. And this is called LLM vocabulary. This is called what? LLM vocabulary. So in LLM, in OpenAI platform, the LLM that they have built, for example, your GPT model, GPT 5.4, whatever, they have created a dictionary or basically a vocabulary. So there they have created tokens. Yes, each LLM has its own dictionary, own, you can say your vocabulary. So if I pick any other model, this thing might behave differently. If I pick Claude models, then it will just show you something else because each token is different. And actually, each token is linked with something called as token ID. So this is a kind of dictionary. Let me show you. So this will be like this. So this is a kind of dictionary. I is mapped with, let's say, token ID 1 or let's say 0. For now, let's say am is linked with token ID, let's say 102. Okay, random ID, but it is fixed in the OpenAI vocabulary. Then eating will have its token, let's say 3001, whatever. Okay, so I can actually see the token IDs. I can click here, and these are the actual token IDs: 40 for I, 716 for am, 6600 for eating, 11311 for chocolate, and so on. So these are the fixed static token IDs which are created inside OpenAI. This is just for OpenAI and specifically for that particular model, for this GPT-3. If I go to GPT-4, you will see it will change. See, all the numbers changed. Why? Because this is a different model. For every LLM, we have a kind of vocabulary, tokens, and token ID. Simple. Very good. So this is step number 1, tokenization and token ID. But I just call it as tokenization. That covers your breaking down your input into tokens and assigning the ID. Simple. This is step number 1. The second step is, it's called creating embeddings. Okay. Not just embeddings, static embeddings. Static embeddings. Simple. So now what will happen? This is step number 2. Now this your tokens, this token ID. Where is the token ID? Okay, 40, 1097, 12459, whatever. This token ID is meaningless. Doesn't have any information. Yes. But this 40 actually has a meaning in LLM created by OpenAI. That means OpenAI knows that I means a subject. Why? Because 40 has a static embedding linked to it. For example, another kind of dictionary. That is why I say Python is very important. Your fundamentals are very important. So let's say dictionary. So here dictionary will say 40 is mapped with a kind of embedding. For now, you do not need to worry about embedding. Just for now, you can say embedding, or basically static embedding, means a kind of vector. Now you will say, what is vector? Okay, no worries. Let me show you vector. Have you studied physics? Not even physics. Have you studied mathematics in class 11th or 12th? Right? So that is the same vector. Vector means when you have a number with direction. When you do not have direction, it becomes scalar. When you have a direction, it becomes vector. Remember XYZ plane, whenever we used to just draw those things. Bro, you have just passed out from your school just 20 years back. How can you forget the things? Okay, let me show you. Don't worry. Vector example. Vector. Let me just go to images. That is a very good example. So do not worry. You do not need to understand this thing. Sin theta, tan theta. Okay. Tan theta, I was like P divided by B. P divided by B. Physics stuff, math stuff. So this is a kind of vector. So what it is saying? It is saying that it is going there. This is, you can say, your magnitude, the value with this direction. That means it is going there. Bro, let me just close it. I know you will be like lost. Let me just explain you. So let's say you are in this plane. You are in this plane. Let's create a plane. Okay. So here, what this will do, let's say this has a kind of meaning. What did I say? It understands the meaning. Why? Because of vector. So in 40, ID 40 means I means a subject. So now what will happen? In the vector space, vector space means it has directions. For the simplicity, I am taking X and Y, only 2 coordinates, only 2. Okay. So I will draw one value here. This is my I. Simple. This is my I. That means 40. That means 40. Remember? This is this thing. Okay. So this is pointing to this thing in the vector space. Okay. That means it has some value. See, this point has some value. Let's say here 10 is written, here 20 is written. This is a graph, simple, space, vector space. Just 2D for now. So now this I has a meaning and its value is this one. Okay. Its value is this one. This is called static embedding. So this way, all of the keys that we have, all of the tokens that we have will have their static embedding. So let's say your next token will be like this and it will be far away from here, or I will say, let's say eating. Eating is mapped to something, okay, XYZ or what 110, just for the example. So this is a kind of your second value. So this value is this one, right? So this way we have all of the tokens and all of the static embeddings created by OpenAI. You do not need to do anything. This is a kind of, you can say, information or meaning of English alphabet, or basically English token, not alphabet, basically token. So whenever I'm saying eating, you are human. You can say you can actually understand the meaning of eating. That means like you are eating something. Machine, whenever hears eating, it simply refers to this value. Wow. And this is an example of 2D vector space. In reality, we have 1536 dimensions. Wow. Such a high vector, high dimensions vector space. 1536. That is a standard. You can also decrease it, I think 786 or 768, I think, and increase it as well to 3000 something. But 1536 is a standard. Simple. Wow. So this is, let me just show you as well, vector size of OpenAI. 1536. See, 1536. This is a small model, but this is like widely used in the industry. So 1536 is the one that we can also use. So this is a kind of dimension, the size of dimension. If I just go to images, they might have some good images. Wow, very, very good images of vectors. See, bro, just add some stuff. What are you doing, man? So let me just explain, don't need to worry. So this is a kind of vector. So this is all about static embedding. Here, OpenAI created static embeddings for each token. I want to eat. Simple. Very good. Very good. Now third step is the main thing. The main thing. And this is the beauty of transformers, or you can say the power of transformers. Transformer will convert this static embedding into contextual embeddings. Wow. Hold on. I will just explain this. Don't worry. This is the beauty. Let's say I have this thing. Okay. Oops. I have this thing. Simple. Let's say I have this information and I'm just sending this information to my LLM. Just tell me one thing. Just tell me one thing. If I send this, and there's a very good example for like conveying this thought, do not worry, I will just continuing this example, but just to explain the concept of context, I'm taking a different example. Okay, so do not need to worry. Let's say I take an example like this. Cat sat on mat. Okay, this is a very popular example in the AI engineering era, or basically AI engineering new things. So, and this was the example that everyone used when transformers were new in the year 2018. Okay, so cat sat on mat. Just tell me one thing. Cat sat on mat is one statement. Okay. And now if I say mat sat on cat, totally different sentence. Obviously, common sense, Ansh Lamba. Are you dumb? I am not dumb. Your LLM is dumb. Now listen. Cat sat on mat, mat sat on cat. Or cat sat on mat. Or whatever. Okay. All of these sentences are different, but words are exactly the same. Number of words are exactly the same, and everything is exactly the same. So just tell me one thing. These things will go to LLM. Okay. These things will go to, let's say, machine learning model. Can it actually make a difference between these two statements? No. Obviously no. Why? Because cat will have the same embedding. Static embedding. Static means static. Simple. Fixed. No one can change it. Cat will have the embedding sat on mat. In this case as well, mat sat on cat will have the exact same embedding. So how machine learning model will know that this sentence is different from this one? Here comes the concept of context. Wow. Yes. Here comes the concept of context. One more example. Let's say, please turn on the fan. And someone says, I am your fan. Fan has the exact static embedding because fan is a token. Fan is a token. Simple. Fan is a token. And fan will have the same embedding. So here the fan means fan on the ceiling. Okay. And here fan means like an emotion, basically a kind of relation, right? But machine learning model treats these two fans in the exact same way. Bro, this is a problem. We need to fix it. Bro, we do not need to fix it. We already have a solution ready. So here comes the concept of contextual embedding. Now what will happen? This is called bidirectional context. Bidirectional context. What do I mean? So now what will happen? If let's use a previous example so that you can just relate it. Cat sat on mat and mat sat on cat. Here what will happen? It will not just find the static embeddings. Obviously, this will find it as step 2. But after that, what it will do? It will now try to find the context. It will try to relate this particular cat, okay, this particular cat with all of these words. With all of these words. Let me just write it like this. All of these words. Let's say cat. And then it will just try to create a relationship with... Bro, what are you doing? Okay, here. Cat sat, then on, then mat. Wow. Yes. Like this. Then the same thing will take place with cat, like with sat, like this. And now it will create the relationship, or basically try to find the relationship with all the other things. Like this. Like this. Then it will move on to on, then it will move on to mat. So this way it tries to find the context of each token with respect to its neighbors. Wow. This way LLM knows that what is the context of each token. This is the heart of transformers, the step number 3, contextual embeddings. Amazing. Amazing. Now, let me just tell you one more thing in brief. Okay. This particular part, contextual embedding, like creating contextual embedding, we are discussing this briefly. If you want to learn this particular thing in detail, the 4 hours long course that I have on LLM is just built on this particular thing. Like we have some other stuff as well, but 90% of the content is just on this thing, because this particular thing is actually making you understand the transformers behind the scenes. But here you do not need to build a transformer. You do not need to understand the statistics behind it. You are just understanding the concept, like how it is working. And it is more than enough for you to get you started. Simple. Make sense? Good. Now you know that static embedding will be compared, will be building relation along with its your neighboring tokens. So it will know which token is contributing how much to my query. By this thing, it would know like exactly what I need to focus on. This is called embeddings, contextual embeddings. Simple, very good. This is the whole intent. Now, here comes the very important concept, and you do not need to be confused here because this is a little bit confusing, but do not worry. Now, whenever I say contextual embeddings, simple. Now, your token, this token, let's say SAT. Okay, let's say SAT. SAT will talk to cat. SAT will talk means like it will talk to that token. SAT will talk to on, and SAT will talk to mat as well. All of the neighboring tokens, everything. This is the concept that we use inside BERT models. Simple, BERT models. BERT models basically are bidirectional embedding representational transformer models. Okay, BERT full form, let's check. I think it is this one, so let me just check. BERT full form, yeah, bidirectional encoder representations from transformers. Simple. So this is a kind of model called BERT. Okay, BERT models. BERT models are those models which are just built to create the embeddings. Wow. So let's say I want to find the embedding, contextual embedding for this statement, cat sat on mat. I can literally use OpenAI BERT model. I will just show you as well how we can just create it. It doesn't say BERT model, but it is a kind of BERT style model. OpenAI will have its own different name, obviously, but it is a kind of BERT style model, BERT architectural model, bidirectional. That means it will go to previous direction. It will go to, you can say, forward direction as well, in both the directions. Then there is one more model. It's called GPT models, generative pre-trained transformer models, and all of the modern LLMs are built on top of GPT style models. Wow, really? Yes, all of the modern models. But that means whenever we are using LLM to get the response, but when we just need to create an embedding out of it, we do not need to worry about anything. Simple. So we sometimes create our own embeddings as well, but here in our case, in our example, GPT will automatically create this contextual embedding as well for us. Wow. You will say how it is doing everything, because I am literally writing 1 to 2 lines of code and sending everything to my LLM and I'm getting back. How it is doing everything? See, you are using package SDK, right? You are creating client. So client is actually doing all of these things manually behind the scenes. So Ansh, Lamba, that means we do not need to actually perform these things. No, you are wrong. We have to do it. Why? Because now in the further sections, we need to build a RAG. And whenever we build RAG, we create contextual embeddings manually. Yes. Okay. So yes, we need to know how to create embeddings, but whenever you are creating a client with this LLM, it does that hard work for you because GPT is taking everything. Simple. But whenever you are simply sending this response, this will not directly take your response. This will first convert everything into the form of tokens like this. Tokenization step will take place, and then it will create the static embeddings. So you will get the static embeddings, and then it will be converted into contextual embeddings, and then you will get a very big vector like this. Let's say like this. Let me just create it for you. Like this vector 0.1 minus 0.999, like this, like very big vector of 1536 dimensions. I told you. So this will be your final vector. Wow, this will be your final vector. Do not worry at all, bro. I will just show you every single thing practically. So do not need to worry about anything about the practical stuff, because on this channel we learn by doing everything. But here we are simply focusing more on concepts because it is important. Simple. Okay, so now this is my final embedding vector. Okay, contextual embedding. Now whenever LLM will take this particular embedding or basically vector, LLM will know how to answer. Why? Because it has the context as well. Wow, it has the context as well now. This is amazing. Yes, this is actually amazing. So this is your 3-step overview how transformers are working. Now, do you know what? This information is more than enough. Now we will be just doing the practical stuff. But again, if you are curious to know and learn everything about transformers, like how to do each and every step, okay, then obviously you have a dedicated course about LLM. Simply go on YouTube. It's on YouTube. Simply go on YouTube and search LLM full course Ansh Lamba. You will get the dedicated course. But if you're simply trying to learn the fundamentals, and if you're simply trying to focus more on the development side of AI, this information is enough because you simply create the clients and you just do all of the stuff. And yes, this part we are doing contextual embedding. I will just show you how to do it. Simple. So are you ready to perform this particular stuff? So let's do it. So let me just show you the documentation as well. It's very simple to create embeddings. Again, we will use OpenAI SDK to create these contextual embeddings. But whenever we will be just working with agents very soon, we use high-level wrappers, which are very good. But still, I want to show you how to work with that particular thing, because you will get the raw knowledge as well. So I will simply write OpenAI Embeddings. Let's see. Embeddings model. Boom. Vector embeddings. Yes, vector embeddings. I want to create vector embeddings. Perfect. I have got this particular thing. So see, this is just the code. So it will take care of everything. Are you serious? Yes. I will simply provide my text. Okay. It will automatically create the tokens. It will automatically apply the static embeddings that it has. It means OpenAI. And then it will just pass those things in the embedding models, bird style models. Now you already know. And it will give me the response back. And I will get the response like this. See? And I will get the embeddings. Wow. Wow. So I will get embeddings like this, console.log. Basically, if you're just getting the response in the log, but you can also get the data in the output. Simple. Let's do it. It will be fun. Okay. And we'll be using 1536 model. It's very popular and it's called text embedding 3 model, 3 small model. This is the name that I want especially. And now let me just open my VS Code. Just hold a second. Let me just open my file, open folder. Okay, and you should also prepare your API key if you have not, because you'll be using OpenAI API. We are not using Gemini because we just need to stick with one, right? So here I can simply say perfect. So here's my VS Code. I hope you can see it. Wow, perfect. So this is my OpenAI VS Code. OpenAI VS Code. So let's create new file, new script. Basically, I will just say second embeddings. Simple, very good. And let me just say it one so that you can just navigate it. I just want to give you a perfect guide, so I'm just simply creating a chapters for you. So I can also say chapter 1 just for your notes. I know you will create notes. I know you are really hardworking, but still I want to give you a guide which would be very handy whenever you just want to learn something new, revise something, and just taking notes as well. So just being nice towards you. So let me just quickly copy this boilerplate code just to import my APIs and all. Let me select my kernel and I want to select python.venv. Perfect. Let me just check if my API is set. Yes, it is set. Now I simply need to bring that particular code and that is it. So now, oh, this is your JavaScript. I was like, wait, when do we use constant? So let me just bring the Python one. JavaScript, Python. Yes, this is our lovely code. Python is such a beautiful language. So this is my code and that's it. See, I just need to define client.embeddings.create, and this is my text. I will simply say I am a test string. Wow. So then I want to use this model. This is a kind of bird style model. This is the same model that we have just discussed. Bidirectional. Okay. Bidirectional. What did we just check? Bidirectional encoder representation from transformers. Yeah, just remember this thing. You don't need to remember, but if you remember it, it's good, bro. You are a technical person, so just a tip. Okay, are you ready to run this thing? First of all, are you ready? So let me just show you by running this thing. Now your text, this text is actually a vector. Wow, Ansh Lamba. See, this is your vector. Wow, this is such a huge vector. I know. Let me just show you the size as well. Vector equals to this. Okay, and len of vector. Perfect. It should be 1536. Perfect. It is 1536. See, because we have picked this model. If I say large, then it will be 3072, I guess. Let's see. See, yeah. What is the difference? Difference is very simple. When you are using lesser dimensions, you will get lesser context. If you are using bigger models, you will get richer context. Obviously, very simple. But in the industry, 1536 is fine. But see, I cannot generalize something. It's totally dependent upon the requirements. See, okay. So just for the simplicity, I will simply say small. Simple. Very good. So this is my 1536. And if you just look at the vector, you have already looked at it. So let's look at it again. So see, this is the size. Wow. This is the size. And see, what is this thing? This is actually your entire sentence embedding. And now let me just tell you very like such a fact, and you will be like surprised. Okay, so now what will happen? We know that whenever we create these tokens like 1 2 3 4, and we get embedding for each token, but at the end, when we just want to find the context, we want the context for the whole sentence, right? That's common sense, simple. So we need to create the context for the entire sentence. So this is called sentence level embedding. Cat sat on mat. Simple, 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 simple. Okay, I hope it makes sense. So this is a kind of sentence level embedding. Wow, yeah, for the entire sentence. Now you also saw like how to just create this particular thing. Where is that particular thing? Okay, here. So you already saw how to create the vector. So now you know this is the contextual embedding. This is not a static embedding. So that means this particular sentence, I am a test string. Now it has a meaning. LLM can understand it. Now what will happen? Let me just show you. Yeah, this is not the end. There are multiple steps. So now you have the contextual embedding. Very good. Now this contextual embedding will be used to create a token. Okay, like this. Let's say, let's say like this. Perfect. And here I can say prediction. Prediction or predicting tokens. Predicting tokens. Perfect. So this is predicting token step. What will happen now? Now you have, let's say, sent this code to this LLM. So do you know what it will do? It will simply take this particular thing and it will generate only one token at a time. What? Yes. But Ansh Lamba, we just get the whole sentence every time. Yes, I know. Just listen. It will only generate one token because your LLM, this GPT, can only predict one token at a time. Only and only one token. So it will take the entire input and based on the meaning, based on the contextual embedding, it will pass this information to something called as LM head. LM head. Okay, LM head. It will pass this information to LM head. Okay, and then it will predict that token. Remember probability, conditional probability here. Where is that? This one. See, probability of next word divided by context. Boom. Now all the dots are connected. Simple. So here we need to find the probability of next word, and this is our context. Wow. Ansh Lamba, you should be a mathematics teacher. Really? So, by the way, I love mathematics. I love mathematics. I love mathematics. Or I can say I used to love mathematics, or I can say I still love mathematics. I don't know. It's been a while I have not solved any mathematical equations. So yeah. So now it will simply predict only one token. And then now the token will be, let's say, chocolates. Boom. This is a predicted token. Simple. Now, we have seen that Ansh Lamba, we do not just get only one single word. So how do we get entire paragraph? How do we get the entire page summary? How? So now what will happen? This is round one. Simple. So now in the second round, this generated token will be shifted and will be combined with the input query. Oh, okay. And then it will take now this entire text and repeat all of the previous steps like tokenizing, contextual embedding, everything. And then it will predict the next word. Now this time it can say, I want to eat chocolates, and it will say and. Oh, okay. Then it will add this thing here, and then it will say, and maybe let's say toffees. Okay. Who is eating this thing? So then it will just keep on adding this thing. Then it will say, let's say dot. Okay. Yeah, this is also a token. This will add this thing. Then it can simply keep on writing, and that's how it generates your entire paragraph. But one token at a time, until it gets a special character called end. So that means you do not need to create much, and that's it. It can be written in the prompt, how much you want to do. Some built-in, you can say prompts are also there in the GPTs just to stop the LLM. Okay, some special characters are always there, but you can also guide it like how many characters you want, like the prompt that we will be just talking about very soon, the power of prompting. So it will see end token. That means it does not need to just create more content. Wow. Yes, that's why whenever you, let me show you, because I love showing you exactly what I'm talking about. So let's say, let me refresh this. Now I will say, how are you, bro? You will see that this will create token by token response. See? Ooh. So it didn't create everything in one go. It just said, I am doing well, bro. Just here and ready to help with whatever you have got. What's up with you? Blah, blah, blah. It creates token by token by token by token by token. It creates a token, appends a token in the input. Creates a token, appends the input in the token. Creates a token, append the token in the input. Simple. And repeats all of the steps, tokenizing and blah, blah, blah. Because with each token, the entire context can be changed. Oh, wow. 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 This is your short summary or high level conceptual overview that you need to know, or you can say non-negotiable concept that you should know when you are learning AI fundamentals. That is it. That is it. This is your transformers. Now I hope whenever you will be using any chatbot, any chat GPT, any Claude, blah, 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 whatever, you would know that what exactly you are doing, how you are doing, or how you are getting the response back. Simple. Now this is not a magic or black box anymore. Now you know what exactly is being done behind the scenes. Make sense? Make sense? Make sense? If it makes sense, simply write LLM make sense or LLM makes sense now. Simply write it in the comments. I want to see your comments, because this is the most crucial part, because everyone is just like trying to make an API calls. Hey, we do not need to learn anything. We do not need to understand transformers. We just need to make API calls. See, bro, understand the fundamental architecture at least. No one is asking you to create your own LLM, but at least understand it. Simple. So if it makes sense, simply write LLMs make sense now. Ansh, Lamba, write it right now. So this is all about your transformers, and I hope now you also understood this particular code, very simple code, but the science, not science, basically the, you can say, concept behind this was like really big, right? But now it is like easy thing for you. Perfect. Very well done. So now let's talk about a very important concept. And before talking about that concept, I want to ask you a very simple question, because only then you will be able to relate to that particular concept. Okay. So let's start. And by the way, in that concept, there are multiple concepts linked. Okay. So let's say you are this user, and this time you are asking some complex questions. For example, you will say, hey, how much sales we made? GPT will say, first of all, who are you? And I don't know about your sales. So invalid question. But that is not actually an invalid question. GPT doesn't have any access to your data. For example, let's say you are going to any LLM, any chat GPT. You can just try with it. You can simply say, but obviously now chat GPT saves your history, chat history. I would say just open an incognito mode, okay, where no history is there. Simply ask this question, what is my name? Or what do I like? Any person question. So obviously chat GPT will say, I am an LLM model and I do not know about your personal thing, so I cannot answer. And that is a very valid thing, because now you know how this black box is working. Everything is actually a kind of probability based on the context. So now if you want LLM to answer, what you can do? You will say, Ansh, actually I can just help LLM. Yeah. So now you have two options. Now with every question, you can provide some context. You can provide some, you can say, your personal information or any kind of context that you are asking in the form of question. Simple. Let's say you are asking something about your organization where you are working, how much sales we made. Maybe you are a technical person or anyone, okay? Or maybe let's say managers want to use this particular thing and you need to build this for them, okay? So let's say how much sales we made. So they are just talking about the organization. So now you have two options. The first option is you can upload the financial information about the organization, maybe in the form of PDF, maybe in the form of Google Sheets, whatever. Let's say PDF. That is a very common file format. So what you will do, along with this prompt, you will also pass this PDF so that chat GPT or any GPT model can understand the context. Number one is query. The second thing is PDF itself. Simple. Okay, makes sense. Now this is the solution number one, that you can just do this as well. So now just tell me one thing, this user, this person would need to attach this PDF every time? Yes, kind of, obviously, right? Now let's say there are multiple PDFs. There are so many PDFs because the question can be answered through multiple sources. There are multiple sources to support the answer, right? So let's say 1, 2, and 3. Whoa. Now with every question, you need to upload all of this data again and again. Okay. Still, it will do the work, but it's like so much to actually give to the LLM. Plus, now let's talk about the real thing, because see, organization is just worrying about the cost all the time. Now let's say each PDF is actually consisting 1,000 or let's say 10,000 pages. Common thing whenever you're just passing some financial information, detailed breakdown, 10,000 pages, I don't think so is a big deal for an organization. Or let's say just for your use case, let's say 1,000. Simple 1,000 pages. For this, simple 1,000 pages for this, and same with here as well. Perfect. So 1,000, 1,000, 1,000. Now just tell me one thing. Earlier, or not earlier. Now there are two problems. One is you need to upload this PDF every time. So problem of efforts, you need to just make efforts to upload this data again and again. If you miss any PDF, it will not generate the correct answer and it can hallucinate. Whoa. Second thing. Now just think about the input tokens. You are asking only this information. Okay, this question, simple, and you are giving 3,000 plus pages, and each page I would say will consist at least 500 words. 500 words means almost let's say 600 to 700 tokens. 700 into 1,000, 700k, 700,000 tokens per PDF. Whoa, that means almost 2 million tokens. Whoa. So with every query, you are actually passing 2 million plus tokens. And actually the token size is just like 1, 2, 3, 4, 5. 5 tokens versus 2 million plus tokens. Just look at the cost. Whoa. But Ansh, Lamba, obviously we need to just pass this information. Yeah, you need to. So we will solve the problem step by step. Okay. First of all, we will solve the problem of efforts. That means you do not need to upload these PDFs. On the second iteration, we will solve the problem of these tokens so that we do not need to pass 2 million plus tokens every time. And let me be honest, these 3 PDFs are nothing. In the actual RAG world, you would pass, let's say, I would say at least hundreds of PDFs. So your token size will become 20 million plus tokens at least. Or maybe even more than that. I would say 100 million if we have like, let's say 100 PDFs. 100 million tokens with just one query. Okay. And do you think like they will just adapt this AI solution? No. So that is the problem being happened right now in the industry. People need to know how to build the AI solutions. There are multiple, see, LLM will do your work for sure. For sure. LLM will do your work. But now just tell me one thing, will any organization adapt this solution? Just look at the cost. Obviously no. And then people say AI is actually a bubble. AI is this, AI is that. Bro, you need to learn how to build the solutions. AI is not a bad thing. AI is an amazing thing. You need to learn how to optimize the solutions, how to use it. See, now in this AI era, if anyone wants to succeed, there's one prerequisite that you need to be updated every single day. Currently, if anyone doesn't know how like RAG systems work, and RAG system is like a pretty much old stuff now, okay, but still let's say there's someone who doesn't know even much about RAG, then the organizations do not know how to build the solutions. They solely rely on the developers. Simple. They solely rely on the senior developers, and that's it. If senior developer doesn't know how to build RAG systems, then person will say, hey, we can just inject these PDFs and the cost will be like this. And then the company will say, we are not going to use AI. And then some employees from that organization will say, AI is a bubble, AI is a bubble. Bro, AI is not a bubble. AI is actually a revolution. The same revolution that we saw when computers came into the picture. The same revolution that we saw when internet came into the picture. Web 2.0 came into the picture. The third revolution is actually this AI and Web 3.0. Web 3.0 is like obviously in very beginner stages, but I'm just telling you these things. AI is not actually a bubble. AI is in the, you can say, beginning stages, and it is becoming mature day by day. You need to update your knowledge every single day, and you need to see what is going on in the industry to build the solutions. Make sense? Do not just rely on those headlines, AI is a bubble, because obviously negativity spreads faster. Everyone will stop you from learning AI. Why? Because it is like a cool thing. People will obviously get some, you can say, attention by saying these things because it is a negative thing. When someone is saying like learn AI, you will say, we will see. So just keep this thing in your mind. I just wanted to tell you this thing because I personally want you to grow in your career. That's it. And obviously choice is yours. Do whatever you want to do. Simple. So this is the solution that we want to build. Okay, simple. Very good. Now, as I just mentioned, we will solve this problem step by step. First PDF, second PDF, third PDF. Simple. So now I want to build a solution where I don't want to upload all the resources again and again. That is not a good thing. So here comes the concept of vector database. Yes. Vector database. So now what we need to do? We will create a database. And I would assume that being a data person, you would know what is a database. Simple. Database is basically, you can say, kind of repository where you put your data, where you store your data, where you simply use your data. Simple, query your data. Simple. So now in the vector database, now what you can do, you can store vectors. Remember, this is one vector that we created for this particular statement. Let's say I create an embedding for the entire text. Okay, let's say. So what will happen? So let's say I will convert this particular thing, let's say this PDF, into this vector. Simple. Very good. Now what will happen when I convert this PDF, this first PDF, let's say this is first PDF, this is second PDF, second, and let's say third. Simple. These three PDFs are converted into the form of vectors. Perfect. Now we know that LLM can understand the meaning, right? Simple. LLM can understand the meaning. So what it will do, whenever we store any information in the vector database, we store two things. First is vector, that is the intent or context. Second thing is the actual content. Two things, context and content. Remember these two C's. Okay, 2C or C square or C2, whatever you want to just use to remember it. Context plus content. So what will happen? Let me just show you. So this vector, let's change the color. Perfect. So this vector, okay, is for this PDF. This one. Okay. This vector is for this PDF. This vector is for this PDF. So what it will do, it will simply perform this particular semantic relation. So this PDF is for this PDF is for this PDF is for this. So basically the meaning, the context, the language that LLM can understand is this particular thing. Is basically this PDF, this vector. Okay, this understand this meaning. Okay, makes sense. So now what will happen? Now I do not need to upload any PDF. Why? Because I have a database. Okay, and you can literally store everything in the database, and you would be shocked, but yes, you can even use Postgres database, but not directly. Basically, Postgres database is a kind of open source database, and more recently, vector database has added a special extension. It's called PG vector. So PG vector is an extension that is added into the Postgres open source database. That means after installing that extension in your Postgres database, you can store the vectors as well. It is easy to install, plus it is open source, it is free, but we have some amazing open source other vector databases as well, and we will also use those as well, and we have some hosted versions as well. like Pinecone, and I think Chroma has free and hosted both. So there are like multiple options. Simple. So now let's take an example of Postgres. Simple. Because obviously data persons will love this thing, PostgreSDB, because everyone knows how to use PostgreSDB. The biggest advantage of using PostgreSDB is you can store your relational data and vector together, and I love this feature because we data people know the importance of data modeling. So perfect. So let's say you are storing all of this information in a Postgres database. Simple. Now what will happen, I have only talked about data storing. Okay, data storage. Simple. No retrieval. I have not talked about how we're gonna retrieve this data. Simple. Okay, perfect. So far you just need to know you can store this information. Okay, and now what you will do, you can just simply, instead of uploading these PDFs, you can just create some API call or anything to bring these PDF files all together. Simple. Okay, now you will say, Ansh, Lamba, do you know what, at the end of the day we are bringing these PDFs, right? So now why do we need to store this thing in a vector database? We can even store this thing in, let's say, S3 bucket. Obviously, in the S3 bucket, if you do not know about S3 bucket, basically AWS S3 is the data lake that we have in the AWS infrastructure, where we store any form of data, structured, semi-structured or unstructured, textual files like PDFs. So we can even store these PDFs here, right? And whenever I want to use it, I can use it. That's a very good question, by the way, because if you have this question, that means you are actually understanding the context and intent behind this particular topic. So now you are absolutely right. Okay, to store this information in S3, and you can simply make an API call to S3 to fetch the data. Simple. Very good. But now the beauty of this particular Postgres database, this vector database, now will be discussed, because yes, you can just store this PDF and you can just get this data. But now remember our second problem, 20 million plus tokens problem, right? We are going to solve that problem with this particular approach, vector database. Okay. So now let's remove this S3. Okay. Yes, you can store it. It's absolutely fine. But now we are, if you just want to solve the first problem, uploading the data again and again, it is absolutely fine. If you want to solve both the problems, then S3 will not work. But I can say now S3 will also work, because now S3 has also enabled something called as, I think, vector extension for S3, but that is totally a different stuff. That means you can even store now vector, or in simpler words, I can say now S3 supports vector databases as well. Simple. But obviously not everyone is aware of this AWS S3 vector database. So we will treat our AWS S3 as our standard S3. Simple data lake without vector database. Simple. Because whenever we create our S3 bucket, we get an option. Do you want to enable vector extension or not? So we will simply say we do not want to enable, because we are focusing on the traditional vector databases. Simple. But I just wanted to give you this update as well, so that you are also aware of the trends and all. Simple. So let's say this is our data lake. Okay, perfect. So now what will happen? Now we are going to solve the second problem, and that will be solved by the concept of RAG. And before discussing RAG, why I discussed vector database? Because RAG is actually dependent on vector database. Now I hope your understanding of vector database clear, that you store vectors and its content. So I can also write context, because if you understood this thing, you understood RAG already. I am so sure. Context and content. Simple, two C's. Okay, context and content. Simple. Meaning and actual content, static content, the textual content. Now what will happen? Let's say you are adding all of the data again and again, right? And you do not want to do this. Now do you know what you can do? Let me just tell you. Now you will literally, let's take first PDF, okay, just for the example. Now what you will do, you will literally take this PDF, okay, and instead of uploading the entire PDF, now you will create chunks out of it. Wow, yes, chunks out of it. So now you will simply say, this is my chunk number 1, okay, this is my chunk number 2. Chunk means like pieces, like you will divide your PDF part 1, part 2, part 3, part 4, part 5, like this. Okay, so chunk. Okay, perfect. Wow. So you will split your PDF like this. Okay, this is called chunking. This step is called chunking. Okay, so when you perform chunking, now what is the advantage of it? Now when you have chunks, so now what will happen? You will not create embedding for the entire PDF. Then we will only create embedding for each chunk. Wow, that means we will just store the meaning of just one chunk, like of each chunk. Yes, exactly. Okay, let's do it. We trust you, Ansh Lamba. Let's do it. So now you will create embedding. Okay, simple. So now let's say these chunks are actually the vectors. Simple. Let's decrease size and let's add some embeddings just for the example so that you can just understand. Let's add something like this. Perfect. I'm just doing this just for your notes so that you can just stay happy and you can just learn and grow. Simple. So these are now the embeddings. Okay, step number 2 is embeddings. Now what will happen, your each chunk is actually converted into a form of embedding. Wow. And now you know that embeddings means the context, the meaning. Simple. Meaning, like what this chunk means, right? Now what will happen, we will store these embeddings in the vector database. Wow. Yes, we will store these embeddings in the vector database. And what do we store in the vector database? 2 things, context and content. Very good, very good. So this will be my context of each chunk, and then I will store these actual content as well. Simple. Like sideways. Yeah, exactly, sideways, like this. Context and content. Wow. Now you will see the magic. Okay, so far it's good. Okay, Ansh Lamba. Okay, now what we gonna do? Now the data is stored in vector database in the form of chunks. Now what will happen? Now whenever I want to retrieve the data, because now it's the part where we're gonna discuss about retrieving this data. So now let's say I want to retrieve this data. Now you will say, Ansh Lamba, what's the big deal? Again, we just need to retrieve all of the data, and again the token size will be same. What are you doing? No. This time token size will not be the same. Why? Let me just tell you. So now I will not retrieve all of the context. I will only retrieve the context which is relevant for this question. Which question? This one. How much sales we made, let's say in 2020. Simple. Let's say this is the question, right? Okay, this is the question. Simple. So now what I will do, let's say I ask this question, how much sales we made, or let's take this entire example. Perfect. So now again I just make this a call, and now I will just behave like this. So simple. So now what I will do, now I want to ask this question. Simple. Now what I will do, I will simply provide the context to this GPT. Like it will simply go through my prompt, right? My query. So now what I will do, I will smartly fetch this data, like this data, and I will add it here. Wow. And do you know what? Not all the chunks will be added here. Only and only those chunks, let's say these 2 chunks are relevant for this question. Let's say this chunk and this chunk. Let's say. Simple. So these 2 chunks will be added and will be retrieved from the database automatically. And these 2 chunks will be added in my query, obviously, like these. So now my chat, or basically GPT model, will get this question plus will get these embeddings, or not exactly the embeddings, the actual content behind this, because we just need to pass the content. Simple. Like this. Wow. Because we have the content as well, right? That is the power of RAG. See? So we have these 2 things, and we just need to pass the actual content. We do not now need any kind of embedding. But what do we need to do with embedding? Nothing. We just need to pass the text. So now, Ansh, Lamba, this sounds magical, okay? And you need to explain us why we are getting only these two chunks. How? Let me just explain it. It's very simple. So what actually happens is, that is the power of vector database. Whenever you work with SQL, you write select asterisk from where id equals to something to just fetch some selective data. Same thing will be applied on the vector database level as well. Obviously, you will not write any select statement, but in Postgres you can write, but generally I'm talking about. So there is a concept of semantic search. Semantic, or basically similarity search. There are two meanings, semantic search or similarity search. Simple, but the overall intent is same. We just need to fetch the similar data. So here we apply something called as semantic search. Okay. So here what will happen in the semantic search or similarity search, okay? Semantic search or similarity search. So now here what will happen, your query, whatever your query is, will be converted into a vector. Oh really? Yes, will be converted into a vector. So let's say this will look like this. Let's say this is the vector for query. Okay. So this is converted into a vector like this. Simple. Let's use a different color. Let's say this one. So this is my query. This is called query vector. Okay. Makes sense. Simple. This is step number 1. Simple. Now what will happen after creating the query vector? This vector will go to this database. What database? Our Postgres database. Simple, like this. Okay, so this is my context. This is my vector database. Let's say this is stored here. Okay, perfect. So now what will happen? This query vector will go to this particular database, and it will say, bro, this is my vector. Do you have any similar vectors with me, like which actually highly relates with me? So it will say, let me rank all of the vectors, and you can just pick whatever you want to do. So it will literally rank the vector. So it can rank like this. Let's say this is like 9. If we have 1 2 3 4 1 2 3 4 5 6, so it will be like, let's say 6. Then it can rank like say 5, and then it will be like 2 or whatever. So let's say this is 6. Okay, and here you can say this is number 1, this is number 2. Simple, and so on, because there can be like so many vectors. So it will say, bro, I do not know who are you, but I can simply say these two vectors are more similar to yours, and this is a ranking. So I will say, okay, so give me top 2 matching elements. Let's say top 2, not matching, but more similar vector. And how they just find this thing? You already know this thing. Remember your vector space? It will simply draw your vector space like this. It will draw the vector space like this. Let's say this is the one. So this vector is here. This vector is here at this point. Okay. And other vectors are, let's say, here. Let's say this vector is here. Let me just change the color. This vector is here. Simple. Okay. Now what will happen? This will say, bro, the distance between these two are very, very close, because we can just find the distance like this, and between these 2 points, the distance is very small. Okay, so this way it will just try to find the distance between all of the vectors, and it will rank it. It will say this is the more similar one, and there is one vector, this is like far away, bro, this is not similar at all. So this will, let's say, draw it like this. Let's say like this. It will say, bro, this is very, very far, and the rank is like very, very small. So it will also create it like this. Let's say, what is this? Let me just draw a circle. Simple. Okay, I hope now you understand this. like this. So distance between this yellow and purple is so big, right? And this is called your similarity search. Oh, this is very simple. Yeah, because I have just drawn the diagram. That's why it looks simple now. Because now you can see what is happening. Now you're not working with like black box anymore. You know, the reason is similarity search. You are not magically getting just two vectors out of nowhere. No, the entire thing, what is going on here is this thing. So query vector is this one. This is the vector. This will go to this vector database like this. It will simply rank all of the vectors and then it will retrieve only top two on the basis of the distance, right? If you just want to know the formula as well, distance formula, it is like 1 minus cos theta. And how to just get the theta symbol from my keyboard, I don't know. So just let's say 1 minus cos, simple, cos theta. So this is the distance formula that we just use, but just simply ignore it because I know whenever you see something related to mathematics, you simply run away. So this is the concept, similarity search. Simple. Now you know how vector or basically RAG is working behind the scenes. So now RAG means, let's revise quickly what we have learned. In the RAG, first of all, we take our data, we create chunks. Then we create embeddings for those chunks. Then we store those chunks in the vector database along with the context. Obviously, context is very important. No, sorry, content is very important, obviously. Then we simply pass any query. Okay. And then that query will be converted into another vector. It's called query vector. And that query vector will be compared among all of the vectors that we have stored in the vector database. Then the more similar or more closer the vectors are, better the rank will be. It will be like 1, 2, 3, and it's your decision. You want top 2, top 3, top 5, top 10. How much content you want to add. It totally depends on the token size as well, because token size will also be more. But sometimes you want to add, let's say, top 10. So you can just add top 10 as well, right? This way, even you have, let's say, 1 million plus context, 1 million plus vectors, you do not need to worry at all because you will only get top 3 every time. That's how you optimize cost. That's how you just perform, you can say, retrieval on your data. And now I can just tell you the full form because now you understood everything. Retrieval augmented generation. What does it mean? Retrieval augmented generation. First step is retrieval. We are retrieving the similar vectors. Augmented means we are just enriching the answers produced by LLM. Generation means generation, answer generation. Simple. This is your RAG. This is your RAG. The backbone of RAG currently is vector database. Simple. This one. Simple. I hope now you understood the content, intent, concept, everything clearly. And now it's time to practically do this because only then you will be able to relate. Simple. Okay. And do you know what? The best thing about RAG databases that we have currently in the market, we do not need to even perform embeddings. Yes. We just need to provide which model we want to use for embeddings. And then we do not even need to store those in the vector database manually. Why? Because it will do it. I will just talk about it, and it's called Langchain. So now, yes, we are introducing you to Langchain because Langchain is a framework which is very, very, very well written and very mature in terms of building AI solutions. Okay, so Langchain handles all of these things behind the scenes. Why? Because see, let's say I am using Pinecone currently. Simple. And then I want to use, let's say, ChromaDB. And then let's say I want to use Azure AI search. Then let's say I want to switch to my open source self-hosted one called Postgres. So I am just changing RAG data, vector databases frequently, let's say. So now every time I need to write a different code because every vector database is handling the code in a different way. That is a common sense. Every database organization is writing the functions in a different way. I do not need to worry about that thing because I will use a wrapper. So Langchain builds a wrapper amongst all of those vector database services. So I just need to use the same code and it will do all of that thing behind the scenes for me. That doesn't mean that you do not need to write the code at all, but you just need to write the code which is familiar with Langchain only. And Langchain will automatically route all of these things back in you can say behind the scenes. Simple. I hope you got it. I hope. And personally, I love this diagram. This one was like very nice similarity search. Yeah, this is very nice. Okay. So now let's try to do this practically so that you can just understand it as well. And we'll be using open source database so that you do not need to pay or create any API key. Okay. But it is very simple. And you will now you will say, hey, what is the example that we are going to just use? Okay, so let me show you. So here, just to demonstrate this thing, I have created this PDF. This PDF is not a very big PDF because we are simply learning and exploring the things. You do not need to just pass a PDF of 1,000+ pages. This is simple 3 pages PDF, and the requirements are very simple. This PDF is like talking about an organization called Novasphere Technology. This is like fictional organization just created to test RAG. Here we have some information only available in our system. Basically in this PDF, this information is not available to LLM. So we will just try to ask some questions related to this organization, like when it was founded and when they just migrated to cloud and all of these things. And obviously LLM will not be able to answer this, but after building our RAG system, it should be able to answer this question, and not just answer, it should be able to simply reduce the token size as well and simply pass the relevant chunks. Simple. And this will be like fun. And now let's actually see how we can just do it. Are you ready? If you are ready to build this RAG, okay, then just write RAG, because I have literally explained you this thing very well, and I hope it makes a lot of sense. Okay, so let's do it. So let's do it, and I'm very excited to just perform this thing. Okay, so now here we have this notebook, and let's create a new chapter. Okay, and I will just call it as chapter 2 RAG. And do you know what? It's the responsibility of data people to build efficient RAG. And I have just given you a very foundational knowledge about RAG. Now it's your duty to explore, to build some RAGs, to break some things, obviously, in your development environment, and just see like how things are working and how you can do all of these things. Do not just listen to those headlines. AI is a bubble. AI is this, AI is that. Bro, okay, AI is this, AI is that, but still, let me just explore. Simple. See, I have just told you the formula. Negativity will spread faster. Obviously, just imagine someone will say, you need to study 10 hours to clear this examination. No one will just listen to it. Obviously, why? Because everyone knows that you need to study to clear the examination. What if someone will say, hey, you can clear this examination if you just read this paper for 10 minutes. Everyone will say, bro, give me that paper. I want to also read. This is called that hook, clickbait thing, or basically spreading the negativity. But it's my responsibility as well just to make you aware and just to bring you in the light so that you can also learn the things which are actually important. AI is bubble or not, it's not your responsibility to just think about it. You just need to explore. There's a technology, there's an advancement. You need to explore being a technical person. Simple. You just need to learn about it. Simple. AI is a bubble, AI is a bubble, AI is a bubble. Amazing, man. Amazing. Salute. That's why I say choose your mentors wisely, who are actually pushing you to learn some new things, more and more things. It is actually important, especially in this particular era. Things are changing like this. What you are learning this month will be like changing maybe next you can say year easily. Platforms are like evolving like crazy. Just look at those big like providers. They are actually adding so much of stuff. Are they crazy just to spend so much of money just to add AI features, AI capabilities? Just look at Fabric, just look at Databricks. Are they crazy? No. AI is a bubble, AI is a bubble. So, Ansh Lamba, now just tell us this RAG. Okay, we trust you. Love you. So now let's talk about RAG. Love you, my data fam. Okay. RAG IPYNB. Perfect. So now this is my notebook. Let me just attach my virtual environment. Simple. And now let me just do one thing. Save it. So first of all, I need to import my APIs because obviously I'll be using GPT models. Simple. But here actually you do not need API till the time we are building RAG. Simple. Okay. So here, but I need to just install or import some libraries. I will see what are important. So first of all, let me just import some packages, some community packages as well. And I think I have already written the packages and we can just save some time to import it. I think one is, first of all, let me just upload the PDF, bro. So I will simply go here in the RAG. Should I upload the RAG? Yeah, PDF here. I think so. Yeah, makes sense. Let me just upload PDF here. It's called Nova S. Perfect. NovaS.pdf, and you can just see here. Maybe you will not be able to see this PDF in your code editor. You need to install the extension for it, but you can simply install it by clicking here, extension, and click the extension for PDF. Simple. Okay. And you can just double click to read it. So we have this PDF. Let me just try to import this particular thing, and because I was just thinking just to create a separate folder, but it's fine. It's fine. So yeah, it's fine. So now what we can do, now we can literally say just to test the location, because otherwise I have to use some system variables to, or append variables to simply add this particular path, because in notebook path behaves differently, in Python files .py files it behaves differently. So I'll simply say if, let me say import OS. So OS dot path dot absolute path of file. Let's see what is the path file. Oh yeah, because see, I told you like this doesn't work with notebook. So if I say if os dot path dot exists, and then if I say this is a path, and then I can say maybe chapter 2 rag and chapter 2.txt, chapter 2, and then chapter 2 rag, then Nova S dot PDF, then simply say true. Print blah blah. Printer. Okay, so this doesn't exist. So that means this notebook is running directly from this folder. So now I think it should say blah blah. Yeah, I just wanted to confirm this thing. I just wanted to confirm this thing, because whenever you are running your notebooks, notebooks run directly from that particular folder, but when you run the Python files, you run directly from the working directly, like here from AI fundamentals. So this is like a kind of path pain that every developer faces, but that is fine. It's absolutely good. Let me just quickly bring the modules. So first of all, I want to bring one module which is called Langchain community dot document loaders import PyPDF loader. This is a kind of special, you can say, class for PDF documents that Langchain community has built. Simple. Then second one is text splitters. Now what is this text splitters? This is very, very good. Very, very good. This is used to split your PDF into text, because first of all, you will load the PDF into text, because you need to fetch the content of all of the PDF, because this is not a text file, this is a PDF file. This is like one step ahead of your normal textual data, because I want to show you the real world examples. So you will first of all convert your PDF file into text, then you will create the chunks, right? Very good. For that, we use a special class from Langchain. It's called recursive character text splitter. That means we can literally say that, hey, I want to create a chunk for 100 characters, then chunk for 100 characters, then chunk for 100 characters, and so on. Simple. Very good. Now, and what do you know what's the special thing about this recursive character text splitter? We can also use the overlap feature. So that means, let's say if I am just creating a chunk, let's say that sentence is not actually completed, that can break the meaning, right? So I can also say do an overlap between first chunk and second chunk, so that we can just complete the sentence. That is a good thing. By the way, there's like one more recursive character splitter nowadays. It's called semantic splitter. So it creates one chunk for each semantic meaning. We will just talk about it later on. That is like a new stuff. So we just need to focus on traditional RAG first of all. Okay. So now I can say, yeah, I think these two are enough just to, you can say, our splitting and chunking. That's it. Then I can import from Langchain OpenAI. Okay, import OpenAI, and not OpenAI, chat OpenAI. So these are some Langchain modules, and if you want to work with any Langchain module, you first need to import the Langchain. Okay, so I will simply say uv add Langchain, so it will add Langchain. Perfect. Now I will say uv add Langchain OpenAI. Simple. Perfect. Because from Langchain OpenAI, I use chat OpenAI. What is this chat OpenAI? Remember when we just use the connection client to make an API call, This is exactly the same thing. This just builds a kind of wrapper on top of it. Instead of writing all of this code like this, this code, you literally need to just specify your LLM model, simply make the chat OpenAI, and that's it. It's very amazing. Okay, and here I can import the model as well. So I will simply say let's also do import OS, and let's also do from .env load.env. Perfect. And let's run this. Langchain community. Okay, we need to add one more module. UV add Langchain community. Perfect. So this is also added. Now let's rerun this. And do you know what? You do not need to worry at all. Why? About all of these packages, because I will create a toml file. Obviously this toml file is with you. All of these dependencies are there. You can literally do a git clone. Okay, simple. Or I think I will just add this thing in the beginning of the video as well. But just I'm simply again telling you, if you just want to find any kind of dependency, I will literally create a requirements.txt file and you can install that requirements.txt file directly. Simple. Okay, so you can also create it. It's very simple. UV pip freeze. So now I will see all of the libraries, then I can write it here. Perfect. So here I will see all of the modules. Wow. Why there are so many modules? Because in requirements.txt it just puts the dependent packages as well, but in toml it just simply writes a parent package. Simple. Okay, so this is done. Some development knowledge. So this is done. Our Langchain OpenAI is done. So now we need to just create a RAG step by step. So I'll literally write markdown step 1. Step 1. What was the step 1? We just need to convert the PDF into text, or basically step 0. If you just look at it, step 0, load the PDF into text in the text format. Simple. This is step 0. So how we can just load this data? So I'll simply say text data equals PyPDF loader, and here I can literally define the path, and path will be rag.pdf because I am running notebook, not a Python file. And I think that's it. Let's see what do we have in text data. Simple. Simply run this thing. Okay. Oh, we got an error. File path rag.pdf is not a valid URL or file. Oh, really? What is the file name? Oh, it's not rag.pdf. It's Nova S. Nova is basically the company name that we have. Simple. Okay, very good. PyPDF package was not found. Pip install PyPDF. PyPDF loader. Oh, okay. So we just need to install one more package, PyPDF. UV add PyPDF. Simple. Because this PyPDF loader uses PyPDF under the hood. Simple. Okay. Let's now see what do we have. What do we have? I think we should see the data. Oh, see, now we have got this document. So now this is a document, and this has automatically converted my data into textual format. And you can see that I have this document. Simple. And I have this first document, second document, third document. Basically, by default, it simply broke down my PDF into independent pages. So first page, okay, then second page, then third page. Simple. And that is the expected behavior whenever you are just storing some textual data, you can literally just store it like page by page. Simple. So what it did, it just created a list, and it created basically one page for, or like one element for first page, second element for second page, third element for third page. This is the default behavior. Like every time it just fetches the data page by page. Simple. And it also adds two things: metadata. That means if you just want to add your company's metadata or some information about Nova S or Nova Sphere, whatever, you can also change it. It's not a big deal. Okay. And then it will have the content as well. So this is the metadata: source, modified date, all of these things. Total pages 3, page 0, page 1, page 2. See, page 0, page 1, page 2. So it divided my entire PDF into page by page system, and then it fetched the content, and it just put that content into this particular label. It's called page content. See, metadata and page content. Simple. This is the actual text, but it also gives you some flexibility to add metadata because it is very important. Because let's say I want to change the metadata, so I will literally run a loop. I will say for, let's say, changing metadata of the document. I will simply say for page in text data, and then I can say page dot metadata. I want to change the source and I want to just say nova s.pdf. It makes sense, and rest of the things it can be same. Simple. Now if I say text data, okay, yeah, it's lists are mutable. That means I don't need to save this list into a different list. Yes, simple. So metadata is producer and my new source should be, yes, perfect, nova s.pdf. Simple. Very good. So this is my list and I have made in place changes because lists are mutable, so I took the advantage of it. Simple. Very good. So this is all about that particular thing. And if you do not know about mutable, immutable, these are like some basic concepts that you learn in the beginning of DSA, pointers, whatever. So some data structure things. So now my textual data is ready. Now I want to perform the step 1. That means I want to split this data. Simple. Okay. Creating chunks. Now I will be using that particular class. Simple. Which class? Recursive text splitter. Simple. Now I literally need to define two things. First is chunk size. That means how many characters I want for each chunk. Second thing is chunk overlap. Simple. Like how many characters should be overlapping with each other so that it doesn't break any sentence in the middle. Simple, right? So now here I can simply say splitter equals to recursive character text splitter. Chunk size I want to say, let's say 100 would be good. Chunk size not 1000 because we have small PDF, and overlap will be 20. It's more than enough. Simple. So this is my splitter. Simple. Now this is just an object. Now within this object we have a special function called split documents, because see, this is just an object. This is the object that we have created for the splitter. Now we will use this object to split our text data. Simple. Very good. So I can literally say chunks equals splitter dot split document. There's a function called split documents and text data. Now if I write chunks, you will see I don't know how many chunks because it will create one chunk for 100 characters. Let's see. Oh, we got so many chunks. Wow, literally so many chunks. So let me just see the length of it. Okay, and I can say length of chunks. Okay, so it has created 101 chunks. So see, now our data is splitted into 101 chunks. Wow. So this is called chunking. Simple. Now the main step. Chunks are ready. Let me just go to the architecture. So chunks are ready. What do we do next? Simply store in the vector database. Simple. Now here comes the most important part, because here we just need to create the embeddings of these chunks. Okay. Here we can create these embeddings manually, and you already know how to do it. Let me just show you. So if you just want to create the embeddings, you know that I want to just use a model and I can do it. So let me just bring that. Perfect. And markdown. So creating embeddings. This will be like step 2. Simple. Creating embeddings. Simple. Of the chunks. Simple. This is like step 2. Simple. Now before doing it, this thing, I need to just create a model. So my model will be, embedding model will be, let's say, not embedding model, I can literally define it on the fly. So here I will say the embedding code. Where is that input? Yeah, this one. So I just literally need to define this thing. Simple. But here you can literally use the Langchain's wrapper as well if you want to create the you can say your embedding. This is the same code. but you just need to create this thing using a special wrapper called OpenAI Embeddings. So this is the power of this particular Langchain, because you do not need to manually create any client. So I'll simply say from Langchain OpenAI, I guess, not core, OpenAI import OpenAI Embeddings. Perfect. So this will import this particular function OpenAI Embeddings. This is the function OpenAI Embeddings. I can just use this model to create my embeddings. Simple. So first of all, let's create the embedding model. I will simply say embed model equals OpenAI models, and I just want to use this small model. And why? To reduce the dimension, because I just want to use 153 dimension. So this is my model. Now what I will do, I will take these chunks and I will convert this into vector. Obviously, simple. Are you getting a point? Simple. So I will literally perform the chunks, like embedding for each chunk. So I will simply say embedded chunks equals to embed model. That means this is the model name dot embed documents. Embed documents is a function where we simply pass the entire list of chunks. Wow. Yeah. Simple. Okay. Embed documents. Now, what exactly I need to use in the chunking? Basically, only the content. See, in our chunk, we get one more special thing, which is called metadata. But obviously, we do not need to create an embedding for metadata, because metadata is just like the extra information. The real content is in the page content here. See, it is here, like I showed you. See, page content. The real information is in the page content. So we will pass the list and we will simply run a loop. So I can say I.page content for I in chunks. Yeah, it will run a loop, and yeah, it's perfect. Now if you will see embed chunks, let's see the chunks of 0. That means the first chunk. You will see the vector. You will see the vector. And just wait, because it will take some time to create the embeddings. See, this is your embeddings just for the first chunk. Okay, but it has automatically created the chunk, basically embeddings for each chunk. Why? Because I have passed the entire list of chunks. Wow. But here I am simply showing you only the first embedding vector. Simple. If I just show you the length of embedding chunks, you will see length of embedding chunks. It should be 101. See? Wow. That means my all of the 101 vectors are stored, or basically not stored, are converted into vectors. Yes, this way you convert all of the chunks in the form of vector. But do you know what? You do not even need to do this thing. Yes, because I told you that vector databases, whatever vector database we use, they take care of creating the chunks. They, not chunks, basically vector chunks. Yes, they will take care of your converting your chunks into the vector. So here you just need to say step 2 and 3, creating embeddings and storing into a vector database. This is the beauty of this thing. Storing in, let's say, vector DB. Simple. Let's reduce the size, or let's keep it. Creating embeddings and storing them in vector database. Okay. So now here you do not need to even perform this embedding, because vector database provider will say, hey bro, I will take care of it, and you do not need to worry at all. Because do you know what? Some vector database providers let you to define which embedding model you want to pick for you can say your embeddings. But some vector database providers say, I will use my own embedding you can say your LLM. That is why they will say, I will take care of everything. So you do not need to worry at all. Okay. So here I will be using a very good vector database. It's called Chroma. DB is like very popular, and you can just use it for free because it is open source. So let me just quickly bring it from langchain.vector stores. This is the class. I don't think so it is in the core. It is in the community, I guess. Yeah. Files is also good. But I will use Chroma. Simple. Okay, this ran fine. Okay, that means we have this class. So I will use Chroma DB. Now Chroma DB has 2 to 3 options. First is in memory, that you will just create a database in memory, and that's it. It will be automatically truncated when your system is turned off. Second thing is you can persist it in the disk so that whenever you will come next time, you do not need to perform all of these chunking again and again. And that is a recommended approach, because obviously you need to perform, or basically you need to store that information. Simple. Okay, so for that I will just show you the recommended approach. I will just let you store your vector database locally so that you can just reuse it. Okay, so now let's do it. So we have just imported this particular chroma. Simple. So here the good thing is you do not even need to do anything. We just need to say chroma, that is our basically the object, and then what we actually need to just store. Simple. And that's it. Just one line of code and that's it. Wow. So here what I will do, I will literally show you here. Step 2 and 3, I will say chroma dot from documents. Now what do I need to store? Chunks, obviously chunks. And now it will say which model you want to pick. So chroma is actually very good because it lets me to define my embedding model, and this is a very good. Okay, so I can just define embedding model, and I will say embed model, and I can just define embed model here again, this one. So I want to use this model. This is a very good model. So this is my model. Now I also want to store it locally. So I will simply say persistent directory equals to, where should I store? Chroma DB. Yeah, let's store it here and inside chroma DB. So this is my vector database that it is going to store, and it will just keep it as well. Yes, it will just simply create a directory for me called chroma DB, and it will store the vectors inside it. Wow, let's run it finally. Okay, let's run it. And I can also say chroma DB equals to this. Simple. Okay, wow, very good. Errors, could not import chroma DB, obviously because we didn't import the package. Perfect. Now it is done. Almost. Very good. Now simply rerun it. Fingers crossed. We should see our database locally. Okay. Open source. Oh, boom. So we have this folder chroma DB. If I open this folder, we will see some SQLite, obviously, and some Parquet files, I guess, or bin files. Yeah. So we have got this database, and this is your database. Okay. Yes, this is your database. Wow. This is my vector database. My own. I can even host it. Okay. I can even store it. And do you know the fun part? You can even store this particular database in your cloud, in your S3. Okay. Because this is just a folder, right? You can literally store it anywhere. Simple. But usually in the production, okay, we just go with the hosted versions like Pinecone, your AWS, not AWS because it is very new, Azure AI Search. So these are very good. But Chroma also has some hosted version. So Chroma is free, obviously, but Chroma has its own website as well, where you can just get some vector databases, and I can just show you Chroma DB. So Chroma, the open source data infrastructure, and try Chroma. See, start free on cloud. So you can even use a hosted version. That means you can use it for production as well. But if you are simply building your local project, go with the open source one. Simple. So if you go to start free on cloud, I don't think so I have an account, or maybe I have an account, I don't know, because I personally like working with other other hosted ones, and Chroma I use just for the development purpose. That's it. So they also have these kind of things, Python, blah blah blah. See, now I want to show you this. See, if I want to directly use Chroma without Langchain, this is the code I just need to write. See, wow. And if I am using, let's say, something else, let's say Azure AI Search, there will be a different code. So that's why Langchain is an amazing wrapper, because it just provides you standard code. You do not need to change your code as per you change your service provider. You simply write the same code again and again, and that's it. That is the advantage of using Langchain, or basically similar frameworks here. Let's say Lamba index. Now we have, I think there are like so many now frameworks, but Langchain is like very, very good. Plus it is like one of the early movers, so it is very mature. So very good. So now we have this database. Now Ansh, Lamba, enough. Now we want to see the practical testing as well. So our database is ready, right? Yes. Now do you know what? Now I will simply connect this database Simple. So I can literally connect this database and I will say it is already connected because this Chroma DB is there. Okay. Because currently I have not restarted my system, but what if you just restart your computer next day? Obviously this Chroma DB variable will not work. So you should always create a connection. Okay. Personal recommendation. Otherwise it's not a hard and set rule. So step 3 or 4. Step 4, retrieval and only retrieval for now. Retrieval, or let's say connection and retrieval. Simple. Very good. So now I will simply create a connection. So I will say Chroma DB connection equals to Chroma, and I just need to provide the location where it is stored here, and embedding functions is embed model. Why I'm just again defining this embed model? Why? This is a question to you. Let's see who will answer this. Just tell me this thing. Bro, whatever questions we are asking, like in the form of query, we also need to create a vector on top of this, right? So that's why we just use an embed model. Oh, for the query vector, yes. And now one very important thing. You cannot change this model. That means you have to use this same embedding model that you have used to store your vector database, and you will tell me the reason why. I said that you need to use the same embedding model that you use to store your vectors or create your vectors. Why? The answer is very simple. The answer is this particular architecture that I have just used to explain you. If it needs to perform this similarity search, the vector that is created by a model, this model should be used by this vector as well, so that it can just compare. Otherwise, how can it compare? Same LLM should create this vector and same LLM should create this vector. Then only you can relate like which is closer and which is not closer. Otherwise, you will see some random results. Simple. So this is very important part. So now let's see. We have just defined this thing as well, and let's see if our connection is working. Yes, it is working fine. So now I will simply ask anything. Okay. So I can simply say similarity search and that's it. So I will simply say Chroma DB connection dot or con dot similarity search. There's a function called similarity search. I will say so here again, what is this K? What is this K? Yes, exactly, top 2 chunks. I can also say top 3. Let's say I want to get top 3 chunks which is relevant to this question, but I will ask some complex question. Let's see if it is able to answer this or just give me the relevant chunks. So I will say the organization was founded in 2016. Okay, so I will say when Novasphere Technologies was founded. Let's ask this question. Let's see what top 3 chunks we get. I know my answer is there in the first chunk, so I don't need to worry at all, but let's simply ask this question. Yeah, so I will say when Nova was founded. Simple. We should see 3 chunks and perfect. And this is the metadata, and this is the same metadata that we just defined with the chunks. So now what is happening? We are simply getting this thing. So I have simply converted this thing, like not I, Chroma automatically did this. So this is converted into vector database or like vector, and then this vector simply applied a kind of search among this all of the vectors, and it will just give me top 3 vectors. That's it. And what do I actually get in return? The content. Simple. See, because obviously it will fetch vector and content both, but we will see only content, and in the content file we have metadata and page content. Simple. So that is the exact thing that we are seeing here, metadata and page content. And let's see page content here. See, in 2018 Novasphere technology started getting more attention in local technology. So this is like 1. Today Novasphere technology is considered a reliable organization, provides data. Page content by 2024 Novasphere has become a well-known mid-size whatever blah 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 thing is. So these are the top 3 chunks that it has provided to me. Simple. So based on the similarity search, okay. And if I ask any other question, let's say if I ask let's say I want to know by beginning of 2019 how many employees were there in the organization? Simple. Let's try to ask this question. By 2019, how many employees were there? Simple. Let's see. So now I will see top 3 chunks based on this query. And by beginning of 2019, the organization had grown. So these are top 3 chunks. Now, if I ask any question from LLM, simple, I can literally provide these chunks along with the question. Wow. And let's try to do that as well. Simple. So now step 5, the final step, LLM. Step 5, LLM integration and answer generation. So here you will also learn how to create the object with Langchain integration for your LLM. So here you will simply say LLM equals to chat OpenAI, and then you can simply define the model. And which model we were using, let me just bring the model name, GPT-5 mini. Okay. So I will keep the temperature 0.0. What is this temperature? So this is what, whenever you create, let me just explain this as well. This is a very small topic, first of all. So I will just go to the LLM part here. Where is the LLM part? Perfect. See, so now here we will just talking about predicting tokens. So whenever any LLM predicts any token, right? So it works on the formula probability of next token, next word divided by context. So here you will see some numbers. By default, if you see temperature equals to 0, if you put temperature equals to 0, that means it will only predict the token with the highest probability, Okay. If you put temperature equals to 0.5, more closer to 1, let's say, it can also give you the output of lesser probabilities as well. So let's say chocolates. Maybe the highest probability was for banana, but chocolate was maybe, let's say, was on the 3rd place or 4th place, but still it can just give you that particular output because temperature is set to that particular thing. So this is called creativity, when LLM can be creative to generate answers. If you do not want your LLM to be creative, just simply say temperature equals to 0, simply return the token with the highest probability. Simple. So this is a small concept that you should know. Temperature equals to 0, we are good with that. Here I will simply say LLM.invoke. Here we use LLM.invoke. This is just this line. See, I will simply say what is the name of my company. Simple. And let's try to ask this question. Let's see what do we get. So AI message, I am sorry, could you please provide context? Because it doesn't have any information, but now I will provide the context. How? Let me just show you. So this is my query. Okay. So I will simply say user query. So this is my LLM. That's it. And this is the advantage of using integration with Langchain, because here you are not creating any client. You are simply using chat OpenAI, and chat OpenAI will create the client for you. Simple. So here let's say user query is equals to, let's say this one. Simple. By 2019, how many employees were there, and blah blah blah. Simple. And before just making this like LLM call with this particular user query, I will fetch my documents. So I will simply say ChromaDB connection, this thing, and here instead of just hard coding it, I can simply say user query. Simple. And now here I will simply get some relevant chunks, so I can just store it in a variable. Relevant chunks equals to this. Now here I will simply say context. Okay, context. So here, or I can simply use like join function, which simply converts, because see, relevant chunks is what? Relevant chunks is actually a list. Simple. If I just show you the very first chunk, you will see so many things, but I don't want to pass any metadata. So what I will do, I will simply create a loop for I in chunk. I is for enumerate, so I will carry the metadata and chunk will carry the content. Okay, makes sense, because there are 2 objects within the document. Makes sense. So I will use enumerate function. Enumerate function is like basically used with tuples. Simple. So I'll simply say, let's store these chunks, relevant chunks data or content. Simple. Equals to empty list, and here we can simply create, no, we do not need to create an in page particular thing. So I will simply say for I equals chunk. So here I will say relevant chunks content dot append. Yeah, this is good. We'll simply append this thing, and here I will simply say chunk dot page content. Simple. Yeah, makes sense. Chunk dot page content. Simple. So here if I now see relevant chunks content, here I will only see the list, and that's it. See, very good. And now I can even convert this list into a string using string function, or I can also use, let's say, some other thing, but string is also good. I will simply say string. Perfect. String of related, because LLMs are smart, they can just understand like, okay, this is a list of like string of list. Simple. Very good. So now this is my string of list, right? So I'll literally say now my LLM call will look like LLM.invoke. First of all, the query, user query, and here I will say user query. Should I use comma? Yes, comma, and then I can say use the following context to answer the question. Perfect. And then I can just pass that variable, and now let's see what do we get. Now let's see. Error. Wow, very good. String object has no attribute items. Let me just check. String of, oh, makes sense. So here I have to use string function. That is common sense. String of relevant chunks. Perfect. No, what string? I think error is something else. Wait. String of relevant chunks content. So if I just close this thing, if I just only run this thing, it was working fine. Okay, so this is working fine. Oh, I see. Maybe I think these double quotes are causing the issue. Okay, no worries. I can literally store this thing in the variable. Relevant chunks content like this. What's the big deal? What's the big deal? What's the big deal? We can just do it like this as well. Now let me just uncomment it, and let me just remove the string. And let me just double check before running this. Okay, user query. Okay, because sometimes it throws error if we just pass the list. I think so. String object has no attribute items. Error is something else. This is a pseudo error, I'm so sure. What is this thing? User query. Okay, use the following context to answer the questions. This is my list. I can just pass whatever I want. Let me just debug it. Let me just get back to you. Oh, wait. I got it. So I think we just need to do it like this. Yeah, perfect. Because this is also variable. Let's try this. I'm just simply testing it. Let's see. Because this is also variable. Perfect. Okay. This was the issue, because we were just passing multiple arguments to the invoke function. That was the issue, and we just simply wrapped it inside F. So by the way, we got the AI message content. By 2019, the organization had more than 15 employees. Okay, so now LLM is able to answer questions related to your organization. Simple. That's how you simply create this kind of system. But obviously, if you just want to test it in your terminal, you can also do it. It would look a little bit more professional. Okay. So let's clear it out, and here you can literally write it something like this. User query equals to input. Similar. And here I will say enter a question. Simple. Now let's try to run this, and this will, I think, open the terminal here. Yeah, so it has opened the terminal here. So now it is saying enter your question. So I'll simply say how many employees were there by 2019. Hit enter, and now it will simply return the answer. Perfect. Yes, 15 employees. Perfect. So yeah, this is now dynamic. You can just put any question. You can just ask any question related to your organization or not related to your organization. Simple. Very good. So this is a very simple example of a RAG that you have built. Very, very basic, very simple, but very powerful. Now, obviously, you can just learn some advanced things as well, because now your fundamentals are clear. Now you have just seen like how to build these things. Now, just a quick homework. Try to build more and more rags. Try to just use your more and more PDFs. And you can just perform similarity search and all of these particular filtering and all. Just try to do all of these stuff. Also, go through Langchain documentation. It is very good. You can just simply go here. Let's say Langchain. So this is this particular thing, and where's the documentation? Start building, not really. Okay, the platform for agent engineering. Observe, validate employer agents, build agents without code. Oh, this is the product of Langchain, not the documentation. So Langchain, perfect. Read the documentation. Okay, so this is a Langchain documentation. The good thing is now they have just combined Langchain, LangGraph, Deep Agents documentation together. So this is the get started option. And here you can just see how to just read all of these things. By the way, RAG is not directly put it in the documentation. It was there before, but now they have just put it in the integrations, and you have to just scroll through all of these integrations, all of the sandboxes, all of these things. So you can still explore, but nowadays it is like putting only and only the stuff that they are simply marketing, but you do not need to worry at all. Okay, join us. Oh, so they are simply creating. Oh, it's a conference. Okay, makes sense. When it is happening. Okay, May 13th and 14th. Okay, makes sense. By the way, now you are good to go with your rack. Simple. So now let's see what do we have next. So now let's quickly see where are we and what exactly we are doing. So here we have covered prerequisites, obviously, like it's already done. Beginner, LLM, API calls, LLM generates, RAG is already done, embeddings, vector databases, and chroma, these things done, static basic contextual done. So now let's quickly cover the prompt engineering part, and here we'll be just covering 1, 2, 3, 4 types of major types of basically prompt or prompting engineering or prompt engineering types, and then our beginner stage will be done. And then we will simply jump on to the practitioner stage, which is like AI agents. And here we will just learn about so much of things. We are already getting introduced with Langchain, so this is good thing. Then we'll just learn about tool binding, tool calling, tool creation, structured outputs, React agent, and a little bit about MCP. Because MCP is just like MCP, tool calling stuff. Okay, so now let's quickly learn about the prompt engineering types. Okay, let's see. So now let's talk about the prompting types. Prompt engineering. This is like a kind of topic right now. People are thinking like prompt engineering is everything. By the way, prompt engineering is actually everything. But if you think you just need to learn prompt engineering, then obviously it's like funny thing. But actually, when you're working with LLM, it becomes a necessity to learn prompt types. Plus the benefit is this will be completed in hardly 5 to 10 minutes. Second thing is you would know like how to just ask or how to fine tune the query, because see what will happen. Let me just tell you. You will say I know how to write prompts because I am a pro prompt typer. Prompt typer. So yeah, that's very good. Slow claps for you. But see, you are building the solution for whom? Users. Can you expect that your user will also be writing a very good prompt, a very efficient prompt? Tell me. Obviously no. User will come to your service. It will just write whatever the user wants. It's your responsibility to fine tune it. So if you know the types of prompts, then only you will be able to fine tune it. Make sense? Make sense? So if anyone says, hey, prompt engineering is like garbage, this, okay, bro. Okay. Just do this and go away. Bro, see, nothing is useless. Some things have like more priority over others, because obviously if you just weigh prompt engineering and RAG will cover 90% of your priority area. 10% will go to prompt engineering. This is a fact, but you cannot ignore that 10%. That 10% is actually, you can say, the final touch up. For example, let's say you are making a cake, bread, cream, whatever you add. Okay, I don't know the ingredients, but all of those things are the backbone. But let's imagine you forgot to add the cherry on top of it. right? So what will happen? Cherry will not be there, and cherry is also important. Yes, it is not that much important as cream, bread, whatever, but it is still important to just give you the final touch up. I hope it makes sense. So prompt, everyone like is trying to just make a fun of prompt engineering, but actually it is not a topic to make a fun, okay? Because it is actually very important. LLM is not expecting you to write a code. Simple. LLM is not expecting you to write any technical stuff. Simple. It is simply expecting you to write a good prompt so that LLM can just generate good answer. Garbage in, garbage out. Simple concept. So just try to learn this skill as well, and it's very easy. So if you just spend 30 minutes to learn this thing, what's wrong in that? What's wrong in that? It's fine. So now let's try to first of all look at the zero shot prompting, and 99% of the people today use this prompting technique, zero shot prompting. So zero shot prompting is when you ask a language model to perform a task without providing any examples. By the way, I have created this entire notebook for you, so do not worry at all to take notes. You can simply go through this notebook. All the comments, all the definitions will be there. Simple. So basically this relies on the model's pre-trained knowledge. That means you will ask something, you will not provide anything else, and LLM will generate the answer accordingly. Simple. LLM will say, okay, I am trained on this data. This is the input I have just received. I just need to respond back, and that's it. This is very fast and simple. No need for labeled example, useful for general task. And obviously it is very, very, very convenient for a user. Simply write the question and that's it. Simple. So let's see an example. So you will simply say zero shot prompt. So how does this prompt look like? So you will say, translate the following sentence to French. Let's say. So the sentence is, how are you? So you will get the response like this. Comment kawa, whatever. Okay. So now this is the response. This is the response. You didn't provide anything else. You simply said, translate the following English sentence to French, and that's it. Simple. Okay. You can also do it parallelly with your LLM that you have just created. And let's actually do it. It will be a fun activity. So let's try to create our prompt calls .ipynb. Simple. And let me just bring all of the dependencies for models. They are not much, but yeah. One is for LLM. I think only just one for LLM. Where is that LLM? Yeah, here. So I just need to create this LLM. So let's try to do it here. So this is my LLM. Select kernel, Python, chat OpenAI. Let me just import it. I think I remember the class name. I think it was from Langchain OpenAI, import chat OpenAI. Perfect. So this is my LLM. Simple. And here I would need to import my API key. Load.env. Perfect. So now I can literally ask anything. So let's try to ask the same question. Okay. So let's say zero shot prompting. Simple. So here I will say LLM.invoke and the same question that I have just put in the notebook. This one. Prompting types. So this will simply generate the answer to me. Let's see what do we get. Same. Oh, comment Vastu. And it is saying comment Sava. Who is saying the truth? Bro. Okay, but you got the intent right. So here you are simply getting this particular thing. I think the person who knows French can just tell us in the comments. Okay, which one is correct? Okay, and what is the difference between two? Which one we should just rely on? Okay, so this is the AI message. Okay, so this is just like zero shot prompt. I didn't provide anything else. I simply want to ask LLM and simply get the answer, and you will agree with me on this, because you will also say that you use this type of prompting throughout your day whenever you use LLM. Simple. Because this is very convenient, very fast. You do not need to write anything else. Okay, so Ansh Lamba, are there any other types of prompts as well? Yes. The very good example of other type is one shot prompt. What is one shot prompt? One shot, as the name suggests, you simply provide at least one example so that LLM can adapt accordingly. Oh, okay. This is also called very high level, you can say fine tuning, very high level fine tuning on the fly. When you're simply fine tuning the model in the form of prompt, you're simply guiding the LLM in the form of prompt, like how you want it to behave. Simple. Okay. So you will simply say one shot prompt is this one. Simple. Let's say one shot prompt is this one, and let me just add it here. One shot prompt. Simple. And let's try to invoke this. Let's see what do we get. Here, same. We'll say, Ansh Lamba, what is the difference? I got the same answer. See, same answer. See, the difference is here you simply relied on LLM to understand your question and generate the answer. But here you also provided some examples so that model can actually behave better. So you provided one example that good morning is equivalent to bonjour, or I think hello is also equivalent to bonjour. Okay. I have a very funny experience with this particular word, bonjour. I will just tell you some other day. Okay. So this is a very popular example. Good morning or hello is converted to bonjour. So now you are simply asking, now translate how are you? Because now you have this particular example. Simple. This is called one-shot prompting. Another one, by the way, one-shot prompting is also very good. If you do not have much time, always try to at least provide one example, one reference point. Simple, a kind of example. Okay. Then the third type is few shot prompting. This is something that a lot of users ignore, but this is very, very good. Here you provide multiple examples so that model can understand. See, this is a very simple example. Translate this thing. LLMs can translate the stuff very well, but when you want to perform a complex stuff, then if you just provide examples, it behaves amazingly good. Okay. Okay, so here I can write few shot prompting, code, llm.invoke, and done. See, hey, oh, now I got comment. Oh, bro, who is saying the truth? Comment Sava. So good morning is bonjour, thank you is mercy, and now translate how are you? Bro, see, now you just provided more examples, so now it is producing the answers better. Now let me just check on Google, because now I am really curious. What is the right answer? Let's use translator. Translate. Let's say good morning. Not good morning. How are you? Okay. Let's say, what is this? Oh yeah. See, the right answer is comment kawa. Okay. And earlier we were getting comment something. If I just simply put that thing, let's see what is the actual meaning of it. Comment vastu. Let's see how it's going. Oh, so it is similar. It is also how are you? Bro, we need a translator, a real person, just to see. I know what's going on, because obviously English is not a very rich language in terms of perspectives. Like if you just take example of French is actually much richer language as compared to English, because it has more sounds, it has more vocabularies, it has more, I think, syllables. You can just generate more and more sounds, but in English you cannot, just because they are just simply 24 or 26 alphabets. I think 26, yeah, 26 alphabets. But in French you have special characters, you have those like those icons that you just put on the top of icons, similar to Hindi, just the same thing that you just add in your alphabets. So I know like what is the intent is same, but yeah, in English we do not have like much stuff. But the same thing, like let's say in how are you, if I just want to say how are you in Hindi, I have so many ways to say. So I think this is the exact thing that is going on. But if you want to guide your LLM to perform in a way, then you should see this is a real example. You should provide more and more examples. Simple. Okay. So this way LLM can be trained on the fly in the form of prompts as well. Okay. Now the most important one for the data domain, it's called chain of thought prompting, basically COT. What is COT? See, whenever you want to work with LLM, most probably we'll be working related to some data stuff. Write this SQL query, write this, write that. In those particular things, model needs to perform some complex stuff. And in order to perform some complex stuff, we need to provide a step-by-step guide that, hey, do this first, fetch this table, then apply a filter, then join this thing, then do this, then do that. Whenever you want to perform this kind of query, this kind of, you can say, question, you cannot rely on LLM because LLM lacks in like thinking step by step. That's why in the chat GPT or any popular chat applications, we have a special button which enables, for, you can say, your thinking mode, because we need to ask LLM to think more. Oh, exactly. This is the stuff. Nothing is magic. Everything is like built on top of the fundamentals. Chain of thought. Even companies like ChatGPT, such a big company, they also have added a special button to enable the thinking mode, basically the step-by-step thinking. When you want your model to think more, basically in the step-by-step approach before answering, this is also called planning mode. Now laugh. Hey, prompt engineering is this, prompt engineering is that. Now laugh. ChatGPT uses prompt engineering under the hood in the form of buttons. They can auto-enable it, but they didn't. Why? Because you do not want to perform the same prompt type every time. It totally depends upon the requirement, and you developer need to understand this thing. Simple. So chain of thought prompting. So basically you are guiding the model how to perform this stuff. A very good example is here. So you want to solve a problem. So let's say if you have 3 apples and get 2 more, how many apples do you have? You will say, bro, this is a question. Obviously 3 plus 2, 5. You are a human. You have a human brain. LLM needs to understand this step by step. And by the way, come here. You said 5. Just ask this question from, let's say, maybe someone who is in the 1st standard or 2nd standard. How he will just calculate? Remember your, you can say your childhood days, you used to write these texts. Let's say, let me show you. Why are you laughing? Let me show you. So let's say you were just doing this thing, literally this thing. So let's say you will say 1, 2, 3, and let's say 2, and then you will simply add it, right? You were also doing this thing like 3 plus 2, 5, and then you just used to do this. Why? Because this is the actual step, but now your brain is evolved to do these calculations on the fly. You are trained. LLM is not trained much for mathematics stuff. It is trained for obviously vocabulary or English or generation. It is not much trained on the mathematical stuff. Are you getting my point? This is the same thing that you were doing back in the day. So this is the same stuff that you need to tell LLM. Prompting. This is called prompting. So now, I hope you understand. So now you need to treat LLM like a child. You are training the LLM. You are just guiding it. Like not training, because obviously you are not writing or changing any code behind the LLM, but you are guiding the LLM in the form of prompt. Simple. So you are saying start with 3 apples. Get 2 more apples. So first just keep 3 apples with you, and then you have like 2 more. So that means you need to add 3 plus 2 equals to 5. Answer equals to 5 apples. Wow. Yes. So now if you just do something like this, then you just call it as chain of thought. Simple. Okay, let's see what do we get. Now yes, the LLM models are becoming smarter and smarter, but if you were an early adapter of LLMs and OpenAI models and ChatGPT, I am so sure that you would have experienced this particular problem, that LLM was not able to perform even simple mathematics problem. It was not even able to add few numbers. I think addition was good, but multiplication was totally out of control. Why? Because it was not trained on mathematical data. But obviously now we have like bigger models, a lot of $1 billion investments made. Obviously, like it just exploded, literally exploded. So now we have 5 apples. We got the answer. Simple. Answer 5 apples. Wow. We have also got the 5 answer. 5 apples. So now you can just simply ask any other question as well. So let's say solve the following math problem step by step. And if you have 3 apples, okay, so now I can ask one more question. So I can say example question. Let me just run this. Question is, if you have, let's say, 10 apples and you get 20 more, how many apples do you have? And I will say example. So let's see, what do we get? So step 3, 30. You will have 30 apples. See, this is the same way that you just educate or you just teach a child. Simple. So these are the major prompting techniques, and at the end I have also built a beautiful diagram. So for that you would need to install pandas and matplotlib. You can simply install it. Okay, simply say uv add pandas and matplotlib, the same way that we added more modules. And obviously you have requirements.txt. So by the time you will be just beginning with this video, you will have all of the packages installed, so not a big deal at all. Okay, so let me just run this particular. So I just built a kind of this summary table. So type 0 shot, no example provided, benefit simple fast. So you can just keep it handy whenever you want to revise, and just a quick, you can say, your visualization. Simple, using pandas and simple matplotlib. So this is all about your prompting techniques, and I hope now you have a clear picture. Now you will say, Ansh, Lamba, you forgot to tell us React. I want to tell you React with agent, because you will feel better. You will understand better. You will know like how actually React is working, because this agent is actually what? A React agent. Really? Yeah. Most 99% of the agents are just React agents. So that is why React agents go hand in hand with React prompts. React prompts were very, very, very popular till 2025 Jan, or I would say till 2024. Till 2024. Okay, because after that, because by then everything, like all the agents were built purely on React prompts, purely. But after that they just changed the frameworks, they introduced orchestration frameworks, they introduced edges and nodes concepts slowly, and now React prompts are good, but now it is not very important. Now we directly build the agents. So that is why I will tell you React prompt, not prompt, basically the React architecture, because React is actually just not a prompt, it is an architecture. And we do not use React prompts nowadays, we directly build the React agents. Simple. So now we will just learn how we can just build the React agent. And before building it, let's try to understand what actually is a React agent. Now let's see. So now let's see what exactly is React architecture. Okay. Now let's see. We are not discussing React agent, but React architecture is actually the agent in itself. So you will understand it, don't worry. Okay, let me just make it aligned. Perfect. So now let's see what is React. It's not the front end React, it is something else. Okay, and it is called React. Yes, we just write it as Re and Act. It is basically kind of architecture. It's not just an agent, it's not just a prompt, it's a kind of system in itself, like how we want to build something. React is actually made up of 2 words. It's called reasoning plus acting, or basically reason and plus action. Simple. So now what is this thing, reasoning plus acting? Now let's say, and because this is very popular with the agent, so now let me just tell you what will happen. Let's say you want to build a solution using AI which will behave like this. For example, let's say you are this person. Okay, perfect. Let me just remove this. So this person has any question, let's say any query. Okay, now do you know what? This will go to any GPT model. We know that. Yes, we know that. Now do you know what? Now this GPT can only generate a kind of answer. We know that. Yeah, but this query is something special. Okay, this query is something like, let's say you want to ask something related to weather. What is the weather right now in my city? Whatever. LLM doesn't know. LLM cannot know this thing. Why? Because see, LLM was last trained I think few months back, and now you are just asking the temperature for today. How will it know this thing? Impossible. What is the current news about any topic? LLM doesn't know. Impossible. It would know news till the time it was last trained on. It was last trained on maybe I guess few months back, but not currently. Obviously, because training LLMs is not a very you can say easy thing. It requires a lot of resources. It requires a lot of obviously computation, and all of the big providers like OpenAI, Anthropic, they train their models maybe every month, every like once in twice, well, once in 2 months, once in 3 months. It depends. I do not know personally Sam Altman, so I cannot ask like how frequently they just train their models. But usually they just train their models at least once in few months, not before that, because it is very expensive process. So now we cannot wait. I cannot wait to get the answer for my question for few months. Obviously, I want my answer right now, and I want accurate answer. What is the, you can say, solution behind it? You already know the solution. Really, yeah. Let's say you are an agent. Okay, you are an agent, and there is a let me just create this particular scenario. Let's say you are working in an organization. Let's say you are this particular person. Okay, and your name is Rahul. Okay, this is Rahul. This person is working in an organization as a data person, data professional. Okay, now there's a user, or maybe his manager comes to this person. Okay, now this person says any question. Let's say how much data we got today. Okay, how much data we got today. Now this, like you do not know this answer because you haven't checked this data. Okay, now because you haven't checked this data, can you answer it right away? No. But this person is like jumping, hey, I just want the answer right now, just give me the answer, blah blah blah. Okay, now this person will do what? This person will use the resources. What resources? This person will go to maybe SQL database. Okay, or data can be related to files as well, so it can just go to files, can read some things, right? Any kind of data, because I don't know what type of data the person is asking. Some parquet, whatever. Let's say files. Simple. So this person can just use these resources, and this person will just use the resources, or basically refer to these resources. The person will get the answer back. Simple. This person will process the information obviously in the brain, and then the person will give the answer back to this particular jumping man. Okay, the manager. Now this manager will get the answer. Let's say we got 1 GB of data. Simple. Or this much of records, whatever. Now this person is very happy. Wow, and he's going now. Simple. Now so this communication took place, and this type of communication takes place every single day. So now, because you are using this architecture, why can't you implement the same architecture in the AI solution? You can. And this is the concept of React. Now what you will do, you know that you have the brain in the form of LLM. Okay. Now what you will do, you will make this brain. Okay. You will make this brain super brain. How? So you will create multiple tools. One tool, let's say for SQL. One tool, let's say for SQL database. It can just fetch something. Okay. One tool, let's say for Google search. It can just apply some search. Okay. One tool, let's say for maybe some files or whatever. Okay. And let me just remove this particular thing. Perfect. Okay. One is the SQL. Second is Google search. And it can also perform some, let's say, research work. Okay. Let's say some research work. So it can perform all of these things. So basically you have created the tools. Simple. So these are the tools. Now your LLM is equipped with these tools. Wow. Simple. Now what will happen? Because your LLM has power to run these tools now. because you created these tools and you made it available. So now what will happen whenever you are asking any query, let's say, what's the latest news? Simple. What's the latest news? Now what it will do, it will take this particular question and it will simply try to process it. It will say, oh, I don't know this answer. So now what it will do, it will make these tool calls. How? This is only possible because of the concept called tool binding. What did I say? Tool binding. I will bind these tools, tool 1, tool 2, tool 3. Let me just change the name. Let's say tool. This is also tool. This is also tool. Simple. I will bind these tools. Bind means I will just connect these tools with my LLM. Wow. Yes. So now this LLM will take this response, take this query. It will go to, let's say, to SQL or not SQL. For latest news, it will go to Google. It will simply search this thing on Google. It will get some data back, obviously, from Google. It can be, let's say, anything. Okay, blah, 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 blah. Okay, so it got the data back from Google. So let's say like this. Simple. Now it will just take this data here and then it will just use this information. Now because it has now the data information or basically the answer, it will use this information, this one, perfect, and it will simply return the answer back. How? Because now it has the information. Simple. This is the concept. This is the concept. Now the biggest advantage of this is, let's say, some news, blah 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 blah. Okay, latest news, or let's say latest news. Simple. Now this particular architecture is incomplete, by the way. We cannot call this thing as a React. No, this is just a tool calling architecture. We just made a tool call and we generated the answer. Now in order to create this thing or basically convert this architecture into React, you just need to do one small thing. You will literally take all the tools and you will create a toolkit. Okay, you will create a toolkit. Simple. Let's say this is your toolkit. Okay, tool 1, tool 2, tool 3. Simple. Okay, now what you will do, you will create a loop. Oh yes, you will create a loop, and let me just tell you why. Now let's say, for now, you just need to use Google. Okay, and this is a loop. Simple. Very good. Now what you will do, you will, let's say you get a question, what's the latest news, and this person also says also do a research, also find a research paper, also find a research paper for that news. So now in total there are two tasks. First is we need to fetch the latest news, and the second task is we also need to find the research paper for that particular news. Simple. Any similar research paper. Okay, perfect. Now what I can do, let's say let's latest news on AI. Simple. AI. So now it will do what? It will first of all make a tool call with Google. Okay, and it, let's say it got some response. Any response? Simple. Any response? So let's say this was a response, some response. So this some response is coming directly from what? Is coming directly from the Google. Simple. Okay. Now because this particular response is coming from Google, what it will do? It will just go to ChatGPT or basically LLM, GPT. Now this GPT will process the information. The latest news on AI is this. Okay, now I have another task. I want to simply find a research paper. So now it will not directly generate the answer, it will just continue the loop. Now this will make another tool call and it will go to this time again this particular tool. Why? Because now this information needs to go to this tool so that it can just find a research paper for that particular topic. Then it will generate something. Let's say this generates this answer. It will go back to this GPT. It will say, now I have this particular news. I have this research paper. Now I can generate the final answer. So now this will be the final answer back to this particular person. Wow. This loop will be keep on running until and unless GPT feels like that I have got all of the information. This is your React framework, or basically React architecture, because it will reason it and it will act accordingly. Why? Because see, first reasoning happened when we got the answer from Google. It reasoned it. It thought, this is the answer I have got. Is this the final answer that I need to deliver to my user? No. Why? Because I do not have any research paper now. It will act. It will take an action. It will make another tool call. Then it will reason again. It will say, okay, now I have this research paper as well. So is this everything that I need? Yes. So it will just deliver the answer back to the user. This is called your React framework, or basically React architecture. When we create this kind of architecture, or basically this kind of solution, it becomes your React agent. Now this particular thing, like this GPT and all, this becomes your React agent. This part is called React agent. Simple. This part, because you have LLM, you have tools, you have loop, you have built the agent. This is the backbone of agent. Simple. I hope it makes sense. And there are multiple things that we need to cover in React, obviously, and we will just cover it in detail. But this is a framework. When we'll be building React agent, we will cover more and more things, but this is just a kind of framework or architecture that you need to understand for now. Simple, because there are so many stuff that you need to just cover in order to build this solution, but your understanding should be crystal clear. I am not asking you to just build everything with code right now. No, I will teach you that as well currently, okay, in this video. But just for now, just tell me, is the architecture clear? Just do let me know in the comment section. Is the architecture clear? Concept clear? Now all the people, shy people are saying, why do I need to comment? Bro, this shows your attentiveness in the class. Okay, so let's say you are just sitting in the class, teacher is saying, hey, understood? Students are like sitting like this. Bro, just speak. Now the shift is already happened. Now you're learning online, but you just need to follow some basic manners. Simply just write, okay, I understood this thing, I understood this thing, I understood this thing. This will make other people feel good, because they will also ask you some questions if you understood something and maybe some other person is not able to understand something. This is called building a community. That's how everything works in the tech world. Now the new people are like totally unaware of something called Stack Overflow, because people built all of the existing solutions that we are using right now using Stack Overflow, because that was a community place to talk about the stuff. But now when you are learning, you are treating learning in a totally different way. Why? Still, it is a technology field. You need to just interact with each other in order to just debug errors if you just want to help someone. Simple. That's why YouTube is a great place to interact with everyone. Comment section is there for a reason. It is there for a reason. You can interact with each other. Multiple users can just comment to each other's, or let's say reply to each other's comments. Why? There's a reason behind it. Just talk to each other. Just try to be in YouTube so that you can also solve your queries. Make sense? Okay. So now let's try to cover all of these things that we have to cover. And we have this particular breakdown here. Perfect. So here, first of all, we need to understand tool binding. Simple. So now let me just talk about tool binding. And before talking about tool binding, we first need to understand how to build tools. Because Ansh, Lamba, you just said SQL tool, Google tool, research tool, but how to build these tools? It's very easy. Let me just tell you. It's easy because of Langchain. By the way, you can also build your own tool, because in, you can say, Langchain framework, you have the ability to build your own custom Python functions as well. Okay, simple. Let me just show you. So let's create our chapter number 4, and let's call it as agent. And here we'll be using pure Langchain because that is a kind of agentic framework. Okay, agent. And first of all, we need to learn here about tool binding. That is very important. Tool binding. So let me just also bring some boilerplate code for our dependencies. So here I do not need, and you know what, I will also tell you how you can just create RAG as your tool. That will be like very good thing. Okay, like how you can just simply create a tool for a RAG as well, so that your LLM will automatically fetch all of the relevant chunks and it will simply feed it automatically. That will be like a kind of autonomous agent. We will also try to build it, so do not worry at all. This section will be like very nice. Okay, so now I do not need these things for now, so I can just remove it, and I don't also need embeddings, so perfect. So I just need this thing, and I need, yeah, that's all. Yeah, chat OpenAI, perfect. So I can simply run this cell. So this is everything. Now I need to build tools. Simple. So let me just bring the documentation. Langchain tools. Where is Langchain? Langchain integrations. I think it should be somewhere. Tools and toolkits. Perfect. So tool integration. There are so many tools that are natively created inside Langchain. And on top of it, you also get a feature where you can just build your custom function. So let's say you are not happy or you're not satisfied with all of the tools that we have. By the way, we have a long list of tools, but still sometimes you need to build something else. You can build a tool from scratch inside your Python function, and that's it. So there are the tools, and they have actually organized this thing in a very good way. So if you just go to tools and toolkits, you will just go to tool integrations, and here you will see there are tools for search. If I want to search anything, so bench search. So this is paid. Okay. Brave, I think Bench is by Microsoft. This is paid, but there's a free one as well, Brave Search. And DuckDuckGo Search. DuckDuckGo Search is a very popular function, or you can say utility, that we use for search engine. So this is very good. Where we have Google Search as well, and all of these tools. So we will also use DuckDuckGo Search. One more, I think, provider is very good. It's called Tavily Search. It should be here. Tavily Search. It is paid, but you get 1,000 free searches per month, so it is very good. It is actually hosted version, but DuckDuckGo Search is like more than anything that you need. Then you have some code interpreters. Wow. Oh, I see. Okay, and then productivity. If you just want to create tools for GitHub. Web browsing. If you just want to do web browsing, means your agent will be able to use your browser. Wow. Yeah, you can also use it. Database, obviously you can just use database toolkits, and then finance, then integration, and there are so many other things. See, this is a long list. Ooh, see, such a long list of tools, such a long list. And these are not MCPs, these are native tools. Wow. So you can literally use any tool, and I will just try to create 2 to 3 tools just for the demo. And obviously you can just use your own exploration, you can use your own curiosity to just test so many other things. Simple. Good. So now let's try to create some tools, and let's try to create a tool, the first tool for DuckDuckGo Search. Simple. So I will simply go to DuckDuckGo Search, click here, and here obviously I would need to first of all import these tools, Langchain community. I hope it will be like automatically added because I have added this particular package, but let's see. Simple. So now what I will do, I will simply go to my VS Code here and tool binding here, and let's create a markdown. Let's say tools. So here we are creating tools. Let me just copy the code, just one line of code, and that's it. Yes, this is very simple. So now here, I think I just need to import one tools dot thing as well. Wait, to get more additional information, link source. That is fine, because this is not actually a tool. Like, this is also a tool, but if you just want to convert any custom function, you can also use tools like that. But yeah, I will just tell you that, don't worry. So here let's use the natively built tools by Langchain. So here I want to use tools for, let's say, one for DuckDuckGo Search. So I will literally write this code from Langchain community.tools, import DuckDuckGo Search, and this is the DuckDuckGo Search object. And now I can simply Ask any question. Okay, let's ask a good question. What is the capital of France? So yes, let's try to ask this question from DuckDuckGo search. Yeah. Okay, pip install u. Oh yeah, we just need to import this thing, DuckDuckGo search package. So you can also say uv. Let's wait for our virtual environment to turn on. uv add, and what was the package name? Or I can directly add it with pip as well, uv pip, because uv, the best advantage of uv is it can also run your native pip commands faster. So that is the best thing. So uv pip install -uddgs, perfect. Let's try to rerun this. So perfect. Wow. So now this is what? This is not the answer that is being generated by LLM. See, I have not used any LLM object. Where is LLM? Nothing. Nowhere. So where is LLM here? Nowhere. This is just a kind of response that I have got from the DuckDuckGo search run. Yes, this is just this response. If I just show you the React framework, so this is, let's say, this is just the response that we have got from the Google. We will create everything, don't worry, how it will go to LLM and how it will process it. But currently this is a raw message that we are getting from the Google, or basically DuckDuckGo search, because we are using DuckDuckGo search. Simple. So this is the answer that we are getting it. France, capital of France. So it is getting this answer. Pronunciation, official republic, pronunciation, this is a country in Western Europe and everything. Because obviously whenever you search something, DuckDuckGo search is very similar to, you can say, whenever you just search anything on Google. So whatever you will get, this is the thing, right? So this is the raw message. This is not generated by LLM. So do not expect, hey, where it is written, what is the capital of France? I think it is Paris. Yeah. So you will say, hey, where is Paris? It will be here in the entire content. LLM will process it. We do not need to process it. We are simply getting the answer back from the object. That's it. Okay, this is one tool. Wow. Is this so easy? Yeah, because of Langchain. Otherwise, you will be creating your custom tool, okay, using Python, and then you will convert it into tool. I will also show you that as well, so do not need to worry. So this is tool number 1. Let's create tool number 2. So here I will create one more tool, which is a very popular tool. It is called, I think, not similar, I think exactly Wikipedia search. So I want to create a tool for Wikipedia. Okay. If I want to just fetch any information, any post information regarding anyone, it is an amazing tool. Okay. So now I will do that as well. So now I can simply go to integrations, and here I will go to Wikipedia. If I can see that, Langchain integrations, not here. So tools and toolkits, and simply search Wikipedia. Perfect. We have a tool for Wikipedia, and this is the code for that. Perfect. Now let's try to use it. Okay, wikipedia.run. We will just run, let's say, Sam Altman. Simple. And yes, we need to import media wiki API. Okay. UV add. Okay, it is downloading it. Perfect. Now we can just run this thing. Could not import Wikibase REST API client Python package. Please install with Wikibase. Pip install Wikibase REST API client. Okay, let me just do this. So whenever you work with these open source clients, you have to install all of these packages. Otherwise, obviously, it will not work. Okay, perfect. Done. Could not find item. Wow. Wikidata, no Wikidata search result was found. Very good. Very good. Who is the, not this thing, let's say Facebook. Now it is Meta, but it was Facebook. Could not find item on Wikidata. Which API I am using? Wikidata query run. Okay. Maybe I'm just using a wrong wrapper. I'm so sure. Let's see. Tools and toolkits. And if I search Wikipedia. Oh, I'm searching Wikidata. I want Wikipedia, bro. Wikipedia. Okay. Now let's change our code. So this is the code. Now let's simply run this thing. Okay. And now I think that's it. Yeah. So now I can say Wikipedia dot run. By the way, it works with I think invoke as well because this is a tool. So I want to, let's say, talk about Sam Altman. And obviously we need to install the package uv add Wikipedia. Perfect. Let me just run this. And we should see the answer. Wow. So we have got the Wikipedia answer. Sam Altman summary. Blah, 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 blah. Okay. So this is everything about Sam Altman that we are getting from Wikipedia directly for free. Wow. Because Wikipedia is open source. Simple. Now, it is working absolutely fine. Yes. But we should never use tools like this. Why, Ansh Lamba? Because, just tell me one thing, because no one has asked me this question. How ChatGPT, or basically not ChatGPT, LLM, GPT, how this GPT model will know that if I want to search anything about latest news, I need to go to this Google tool or DuckDuckGo search tool. How LLM will know that if I want to find a research paper, I need to go to this tool, which is a kind of research paper tool, and it is also called RCIF. Let's create that tool as well. Okay. So we will just create it, don't worry, but just tell me this thing, how it will know this thing, how? Oh, that's a very good question. So for that particular thing, we always create our custom tool and we embed all of this code inside that, and we just guide the model from that function. Let me just show you, only then you will understand it. So here I will simply write from Langchain. I need to just fetch the tool library. So let me just find that first of all. I need tool, Langchain tool class. I need to fetch that class. Langchain.tools import tool. Yeah, this one. Let's see if it works, because they just keep on changing the modules. So yeah, it worked. Perfect. So now what I will do, I will create a Python function. I will say def and search DuckDuckGo, or let's say tool DuckDuckGo search. Simple. Very good. This is my tool name. Here I will simply ask for the input, obviously, because this is requiring one input, which is query. Perfect. And it will return the data in the form of string, obviously. Now I will guide my LLM. How? Let me just show you. Now I will add one doc string. So anytime you want to create a tool, you have to use a doc string, because your LLM, when you will bind these tools to your LLM will only read this particular doc string, and that's it. So I can simply say searches DuckDuckGo for the given query and returns the results. This is like very generic one, so let me just refine it. Searches, or let's say use this tool, because better doc string you will write, better decision your LLM can take while invoking the tools. Use this tool when you need to when you need to fetch, not fetch, when you need to answer questions about the current events, yeah, or general knowledge. Perfect. This is like very high level, by the way. You should just provide a very detailed doc string, but this is fine. Simple. And I want to run this code inside this function. Whenever LLM will invoke this function, it should just run everything, and then I can simply return this thing. I will say response, and I will say return response, and yeah, return response. So this has become my function. Simple. Now in order to convert this function to tool, I have to use a decorator tool. Simple. That's it, without any kind of description. So let me just run this. This has become tool now. Why? Because I have used the tool decorator from Langchain. Now what is a decorator? Again, Python fundamentals. Tool, or not tool, basically decorator is actually, you can say, a special object which takes your function, okay, it decorates it. It takes your function, it will execute it, and then it will just create something else out of it. So what else it has created? It has literally taken your function and it has created a tool which is natively understood inside Langchain. But you do not need to write any kind of that natively understood language. No, you just need to use decorator. That is the power of decorators. And nowadays, every other, you can say, framework provider is just using decorators because it is easy to work with. Simple. Now let's just test it. So I'll simply say tool DuckDuckGo search dot invoke, and I will simply say what is the capital of it, and it should work fine if it is built nicely. Yes, see. So I have got the response again from DuckDuckGo search, not from LLM. Okay, but this is a tool now, real tool. That is also a real tool, but LLM cannot understand it better because of no context. But now we have the context. Simple. Very good, very good, very good. So now let me just do the same thing here as well. So here I will say DEF and let's say tool calculator, and that's it. Perfect. Tool calculator. Who created it? I want to create Wikipedia. Wikipedia search. Use this tool when you need to answer about current events. Not really. When you need to answer questions about Wikipedia, about person or personalities. More specifically, we are simply testing it, so you can simply refine it as much as you can. But currently at this moment, I just simply think like we can simply say persons, places, or anything, or let's say etc. Let's LLM decide it. Simple. Okay, so I want to just run this code inside it, and here I want to simply return response, return response, Wikipedia. Hey, wait. So response is this one. Who will just dynamically put it? Query. Perfect. Here as well, query. Perfect. Makes sense? Very good. So now we can simply double test this as well, and we can test this as well. So tool Wikipedia search dot invoke, and here I want to just let's say search Sam Altman. Function object has no attribute. Wikipedia dot invoke. Are you serious? Wait. Wikipedia function object has no attribute invoke. What does it mean? Oh, makes sense. See, we didn't convert it into tool. I was like, what's wrong? Now it should work. Now it should work. Perfect. Perfect, perfect, perfect. So these are my two tools that we have created. Let's create one more tool. It is for Arxiv. Arxiv is like a kind of very popular solution for finding the research papers. So let's try to search it in our Langchain. Where is that? Okay, here. So I can search Arxiv, and I can just go to tools and toolkits. Okay, here's Arxiv, and let's see. Okay, Arxiv integration. Why they are creating the agent directly? Are they dumb or what? So where is the Arxiv tool? Load tools Arxiv. I think they have directly created the agent on top of it for the Arxiv example. So where is the client for Arxiv? Arxiv create Arxiv tool Langchain. Perfect, perfect, perfect. Because whenever they just update the documentation, they simply just do something messy. So load tools, I know what they are doing. Load tools, they have created the new function where they simply ask you to, hey, simply use our built-in functions through load tools. I don't think it is a like good way to do it, but you do not need to do it. So let me just see how we can just do it. I think I also had one code. Let me just see it. So let's try this code, which is given here. I was just searching for the Arxiv integration. I think they have just removed it. They are simply building the agent, but I don't want to do that because you will not learn the real stuff that way. So let me just copy this code and let me just paste it in my environment and paste it. Let me just remove the unnecessary stuff. Okay. So I think it should work, because when I was working with Arxiv, this was like kind of structure. We were just running one wrapper and one query run. So I hope it should work. If not, I can just fine tune it. Do not need to worry. So query, let's say I want to run something. What are the latest purpose on deep learning? Oh, let's try to source papers for this, and let's test it. And I think I also need to install the Arxiv. So uv add Arxiv. Perfect. So now let me just run it. Let's see if it works. Oh, it worked. Perfect. So now see, I have got top 3 research papers based on the configuration that I have provided. See, Arxiv wrapper, again, connection stuff. You don't need to worry about that stuff. Then top 3 results, and I'm also using the Langchain code. This was like given in the documentation. They have removed it. So now do not need to worry. So create the tool. So we have created this tool, and now query. So now you know how do we create this thing using function, right? So now let's wrap everything inside the function. df tool Arxiv search. Use this tool when you need to answer questions about scientific papers. Makes sense. Or research papers. Or research topics. So whenever someone will be asking anything about research topics, our LLM should make a call to this thing. Simple. So let me just put everything here. Query. I can simply use this thing, print result, and that's it. Let's convert this thing into a tool. Perfect. Let's test it if it is working fine. And I will say tool Arxiv search dot invoke, and perfect. Oh, it is working fine. So now we have created these tools. Very, very good. So now I want to show you something. What? Now our tools are ready. Now I will bind these tools to my LLM. Okay, so now let's quickly do that, and let me just quickly create my LLM. LLM equals to chat OpenAI, and the model that I want to pick is, I think, GPT-5 mini. Let me just bring that. Yeah, here. Turbo. Who is using turbo? Bro, who did that? Wait, let me just bring the model. Like, obviously turbo is valid model, but it is not a good model. Okay, API calls. Okay, GPT-5 mini. Okay, let me just do it here. GPT-5 mini. Simple. Our LLM is created. Now in order to bind the tools, we first need to create a toolkit. Okay, so I will say toolkit equals all of the tools that I want to just bind. Okay, Python Arxiv tool Arxiv search. So these are all of my tools. So this is my toolkit. Now I will simply bind this toolkit to my LLM. So I will say LLM bind equals LLM dot bind tools. Simple. So dot bind tools, basically bind tools is a function, is a utility inside Langchain, which allows us to automatically bind the tools with the LLM. Wow, that's it. Yeah, that's it. So this is the binding part. Now you will see something amazing. Let me just show you. So now I will do a very special thing. Okay, and I will let's create one more custom tool, so that we will also learn how to create purely custom tool, because that will be required for this example. So let me just create that tool. Let's say you want to create a tool for personal information. So whenever you want your LLM to access personal information, you have a tool for that. So you will say personal, simple, and that's it. You do not have any kind of query. Let's add the personal info, and here you can simply say personal info. You will say person name, or let's say query string. Makes sense. Return dot get query information not found. Okay, info equals to this. Makes sense. Return info dot get query. Okay, and let's then actually find the query. So query will have name, not like this. Let me just do a better stuff. So I will say infos Let's create a list at least of some information, right? So let's say name, like at least 2 people, obviously, right? So now I will simply say if, or let's say for info, and I can simply search with the lower. That is a good try and catch method, kind of. And if, wait, let me just check the code, because you should not directly rely on the code that is generated here. Lower in query dot lower, simple, return info name is years old and has a work as this thing. Okay, makes sense. I was just thinking just to return the dictionary itself, but that is fine. We are simply returning the independent object within that, so that is fine. So okay, so I hope you understood what we have done here. We have simply taken the query. Query will actually have a name. Basically, I can say name. So name will be compared amongst all of the, you can say, objects that we have. Simple. So name will be compared here. If it matches, it will simply return the name, age, and occupation of that particular person. Simple, very good. And I can say use this tool when you need to answer questions about personal information. Very good. So this is my tool. I can say @tool, and I can simply run it. And I can name it as, let's say, tool personal info. Perfect. Tool personal info. Perfect. Dot invoke, let's say John Doe. We should see. Perfect. So we have created our custom tool. So that's how you create your custom tool. You can literally write any code within this Python function that you want. Literally anything. Simple. Very good. So now what we are going to do, we will simply run a special thing. Let's say this is my toolkit. So I have binded this thing. Now I will ask my LLM a question that will be only answered with tool invocation. Okay, this is not a React agent. First of all, this is just the binding tool step. Okay, so now I will ask, let's say, and I know this is a kind of complex section, so I would encourage you to watch this section multiple times. If you just understand, let's say 50% in one go, it is more than enough. Then in the second go, in the second iteration, you would understand, let's say 60%, 70%. And then in the third iteration, you will understand 80, 85, 90%. So that's how you learn. Do not expect yourself to be a superhuman. You will just watch one time and you will understand everything. Okay. LLM.invoke, and this time I will use LLM bind. So I will say invoke, and I want to ask a special question. Let's say I want to ask, what's the age of John Doe? Simple. Now LLM doesn't know who is John Doe, obviously. So now what will happen? Let's see. Oh wow, error. The model GPT 5 mini does not exist. GTP. It's GPT, bro, not GTP. Okay. Now let's do it from time. Now let's see what do we get. And you'll be surprised to see the answer. Really, yeah. Just wait. Perfect. Now it is saying, do you mean the generic placeholder name John Doe used for unidentified or anonymous person, or a specific person who goes by that name? If you mean the placeholder, there is no single age. It refers to an unknown anonymous person. If you mean by a real person, because it doesn't have that particular information. Okay, you can just guide it, make tool calls if necessary. Simple. Now, perfect. I just wanted to see this. What did we get? AI message. Content equals to empty. Ansh, Lamba? We didn't get anything from LLM. Why? It made the tool call because tools are attached. Yes, because now your understanding, what you have understood in the React architecture, will be tested. Just tell me one thing. What is the step 1? The step 1 is I will pass the prompt. It will go to GPT. Then GPT will decide which tool to call. So this is just the step 1. Wow. This is just the step 1. Now GPT should be able to identify which tool to call. So ideally, it should invoke personal info tool. In our case, let's see which tool it has invoked. So that information will be available here. So just scroll towards right and you will see model name, tool calls. Okay, tool calls, where's that name? Yes, perfect. See which tool call it has suggested. Which one? Tool personal info. Wow, not just this, your LLM has also generated the argumentations as well. Because see, whenever you need to invoke this tool, which is this particular thing, tool person info, how do you invoke it? You simply invoke it like this. Let's say tool person info.invoke John Doe. So you pass this particular parameter, right? How LLM would know that which parameter I need to pass? It simply reads your function. Wow. By the way, if you just want to provide more context, you should always do it like this. Let's say arguments, and then you can simply say name string just to tell LLM. But now LLM is actually reading your entire function. So you do not need to pass this thing, but it is actually a good thing. So it knows what exactly it needs to pass to this particular function. Wow. So this is step one. This is called tool binding. Now we need to convert this particular framework, this tool binding, into a React agent so that agent can use this information. Which information? This thing. So now agent will come into the picture. Agent will say, okay, you want my help? LLM will say yes. LLM will say, just make this tool call. Agent will make the tool call to this particular tool with this particular arguments, and it will get the response back. Then agent will hand over that particular response to LLM, and then LLM will simply react. Reason plus act. Reasoning. It will say, is this information sufficient? If yes, return the response to the user. If not, again make another tool call. Like this. So this loop is the next thing that we are going to build. Make sense? So good thing is in Langchain, we already have an amazing class called create react agent. We will use that as well. But after building that create react agent, I will explain you what is going on behind the scenes, because once you understand what is going behind the scenes, you can actually work with it well. Okay. So first of all, let's see how we can just create an agent. Simple. Let's see. So this is like tool binding. Our tool binding is done. Now we want to create the agent. Okay, makes sense. Now let's create the agent. So now let's try to create our React agent. And do you know what? Now it will be so easy, because you already know how to create all of these things. Now you just need to combine all of these things together. That's it. So now let me show you. Let's create a new notebook. Here inside this thing. What do you want, man? Okay, perfect. So here let me just say React agent. Simple. And basically, I do not even need to create the notebook. I just can clone this. Why? Because this will be exactly same, and we just need to add only one more step, and that's it. React agent. Perfect. So let me select the kernel. Okay. So now everything will be exactly same. Simple. All of these tools. Okay. Now just after getting these tools, we need to create the React agent. Simple. So bind tools are also done. Let me just run all the cell just to make sure everything is running fine. Wow. Kernel failed to start. Why? Oh, just an internal error. What? Let me just reload this. What is this error? What is this? Let me just run it again. Let's wait. What is this error? Kernel failed to start as DLL could not be loaded. Please view log. Let me just restart this VS Code. I think something internal is happening. Okay, let me just do it. So bro, after doing a lot of debugging, and I was just going through so many things, and I got to know this is such an error which is not in our control. We are not in such a position that we can just fix it. It is like internal error. So I was just reading some article things. So I got to know that it is due to an internal incompatibility between Python 3.12, the version that we are using, and your IPy kernel, which is your Jupyter notebook. Obviously, this will be a bug. They will just simply fix it, but we cannot obviously wait. So what I have done, I will simply now change the Python environment let's say 3.11, because 3.11 is obviously stable one. That's why I just like using the older versions, because they are stable. But it is what it is. Plus, you know what, I also tested this particular same thing with pip. Like, I created my virtual environment with pip and it was working absolutely fine. So the problem is with just UV, because obviously UV is also new. UV is also becoming mature day by day. And do you know what? That's how any development takes place. You cannot build the perfect product in one go. You have to release something. Your users will tell you that, hey, this is the thing that you can just improve, and that's how they just develop it. So now what I will do, in front of you, earlier I was just thinking to remove this section, but then I thought like it will be very helpful for your learning journey, and you will also learn how to debug these kinds of issues at all. So now what I will do, first of all, I will delete my virtual environment, just .vnv file. Let's wait. Yeah, delete permanently. Perfect. So now I will install 3.11, because in my system I have Python 3.11 installed. In your case, if you do not have Python 3.11 installed, simply download Python 3.11 the same way you download 3.12. Simple. So I just need to change my Python version to 3. Oh, I have already changed it. Very good. So this is already done, 3.11, and in the toml file as well, I need to change it to 3.11. Perfect. So this is also changed. So now I will simply say uv sync. So now it will create a new virtual environment for me using Python 3.11, and I think it should work. Let's still test it. Otherwise I will use pip. No need to worry at all. We have all the solutions, nothing to worry. So let me just quickly reload my window just to make sure like everything is refreshed, and let's try to rerun it. Fingers crossed. Let's see what will happen. Okay, so install ipykernel. Yes, reinstall it. Fingers crossed. Let's see. Because it is still running, it is in the waiting, because it is now installing, I think, ipykernel in the background. So now let's wait. It is running. Let's wait. Okay, let's wait, because it has installed ipykernel. I hope so, like this will work fine. I am sure, not 100%, but yeah, I think it should work. Let's wait for a couple of seconds. So finally, whenever you see an error, and such a complex error, like the error that you have never seen, and when you resolve it, wow, such a feeling. The real feeling, developer feeling. I cannot tell you this feeling in my words. Okay, but see, I wanted to desperately add this section. I was thinking just to remove it, but then I thought like it will be a great learning part, quick part for you. So enjoy. Okay, so what is the you can say crux, or you can say what is the summary of the problem? The problem is Python 3.12 has recently got a bug with ipykernel recently, because it was working fine. See, we were just like working with it, but now it has got an error with your Python 3.12 recently, and because of that we are not able to run anything in the ipykernel. Anything. It's not just like these modules, anything. I was even running 1+1, it was not running at all. So now we have installed Python 3.11, which is more stable version with ipykernel, and it is running fine. Simple. So now what we're gonna do, we will simply run all of the cells, and now we will, what it is showing, ddgs. Okay, I can just add that particular package, because this is a new environment, so no need to worry. I can just add it. Okay, let me just use this command. So obviously whenever you are just creating a new environment, some package will be here and there, but it's fine. No need to worry. No need to worry at all. Okay. This is also done. Let's wait. Okay, so this section is done. Now we can just write our finally React section. React agent. Now in order to use React agent, I can literally import the special class that I have. It is called from Langchain dot agents. Not actually, because they just recently changed the name. Let me just confirm. Earlier it was like pre-built, but I don't know what is the recent name. So I'll simply say Langchain, and that's it. They also market it very well, so I can simply go to documentations. Bro, where is your documentation? Here. Langchain. Perfect. Get started. Overview. Okay, see, earlier this class name was pre-built, but now they have just created a new class, agents. They recently, like literally in the Langchain 1.0, they recently renamed it, and now again they renamed it. Why? Why? And you know what? The name was Create React Agent. The utility name was Create React Agent, but now they have just renamed it Create Agent. I just want to know why. What do you get whenever you just rename anything? What? Just keep it as it is so that the code base will not be broken every single month, right? Of the lovely developers. So from langchain.agents, I will say import create agent. Now in this import create agent, I will literally say, I want to create an agent. Simple. So my agent will be, let's say, my agent equals to create agent utility. And then I just need to define the LLM that I want to use. Here, I should not use a simple LLM. I should say LLM bind, because only then React agent will be able to make the tool calls. Simple. Here we have LLM bind. We just need to use this. Then I need to define the tools. So tools are the toolkit. Simple. This is exactly you need to do. Are you sure? Yes. Let me just run this. Create agent got an, oh man, again they just rename the parameters name, so simply remove it. Don't need to worry. Perfect. So this is my agent. This is literally built. Are you sure? Yes. You can literally test it. So I will simply say my agent dot invoke. Yeah, let's try to use this thing. This time, see, we asked the similar question here, but we didn't get any content. We simply got an indication that we need to make tool call. But now, because we have created an agent using our LLM and toolkit both, this time, this particular indication will go to LLM. LLM will make a tool call, and then it will get the response back, and then it will, you can say, process that response and generate an answer, like real answer. Let me show you. So, wow, error. Expected dictionary got, what's the age of dictionary? Oh, makes sense. So here I just need to pass a dictionary, because whenever we invoke any agent, we simply pass a dictionary like this. Let me show you. Let me just remove everything. So here we simply say input. Yeah. So you just need to make sure that we always use input. And what do you need, by the way, now? Invalid messages, empty array expected during task with the name, model, and ID. Got an empty array. Wait, I think, is this an error? Input. Let me check if they have again changed anything or not. See, I told you. They again just changed the keyword to messages. So I will simply pass the messages. Do not need to worry at all. Sometimes they just keep it like, I think they have just made this particular change last month, because till I think January it was not there. So here, and by the way, it is a very simple thing. Messages is a kind of standard that we just need to pick. Here you just need to define the role, because you are a user, and then the content that you need to pass. Here the content means your question. So I will simply say my question. What is the, not weather, what's the age of this, and this particular thing. Simple. Okay, so we just need to invoke the agent like this. Now let's wait. Okay, and by the way, it is like very simple. I will just explain this messages thing as well, but it is not something like which is like you have to do it. So here I have got the response, and let's see what are you sure you want to move? No, bro. So I was just making some space here. Perfect. So here it is very interesting, because you now need to understand the output. It's very important. First of all, messages. Messages is actually a list of all the messages. And now I know when did they make this change, because I have got the hint, because more recently, Langchain has redefined all of its utilities, and they have made it aligned with the LangGraph approach, where they simply create nodes and edges. So I was reading one article related to this thing, and I think this is the exact thing that they have done. So it is fine. Now it is expected. So now what we are getting in return, here we are getting a messages key. And messages key is nothing but basically a list of all of the messages. It contains Messages, that means all of the conversation that we are having with the LLM. First of all, human message. Human message means our message. So this was my content. This is the question that I asked. Perfect. What did AI message? What was the AI message? AI message was this thing. And we have already tested it that we get message like this. But what did I say? When we create React agent, this information goes to the tool. See, now you will see tool message. Wow, tool message. That means this content, empty content, but with the parameters and all of the tool calls information goes to tool message. Wow. And this tool message returned what? This particular thing. John Doe is 30 years old and works as a software engineer, because we are returning this thing in our tool. If you remember, see? Exactly. Then this information goes back to LLM. Here you will see AI message again. Wow. This is the loop. This is the loop. This is the React loop. This is the exact loop that we were just talking about. That first of all, it will pick the tool call. So at this step, it picked the tool call. Then it sent that information to that tool. Okay. Then that tool returned something back to the LLM. Okay. Then that AI LLM processed that information and presented the answer to us. Simple. Wow. Yes. And do you know what? Before Langchain 1.0 version, which is like recently released, before Langchain 1.0, this thing was not possible. No. Before, we were using React prompts, where it was actually running an infinite loop and it was causing a headache to the developers. But then they just modified each and every component of it, and now they are using the LangGraph approach, which is very good. Very, very good. And that is why we are able to see everything: human message, AI message, tool message, and AI message. Again, like loop. Now, if you get this answer, if now AI would have felt that I need to just create or basically make another tool call, then there would be another tool message, then there would be another AI message, and so on. It will be like keep on going until AI feels that I have all of the information. But because AI had all of the information, like John Doe's age and the profession, it was satisfied. Wow. This is your, you can say, React agent, React loop. Okay. I know that you have understood almost all of the stuff. Let me just explain a little bit behind the scenes how edges and nodes are created. Because obviously, you literally use the built-in class create agent, right? But sometimes you need to build the custom agents. So for that, I will just give you a 5 minutes behind the scenes, like how edges and nodes are being created for this thing. Simple, let's do it. So now let's try to understand how our create agent, or basically create React agent class, is working under the hood, because you need to understand how does it work, because only then you can just tweak it according to your use case if you just want to add something customized thing. Okay, so let me just explain that thing. Under the hood, whenever we use, let's say, create agent, whenever we just use this class, what actually happens under the hood? And Lamba also tell us, like, how do you know? I will tell you, don't worry. So let's say this is your class that you used, create agent. Simple. Okay, makes sense. Now what will happen is that it will simply create nodes and edges. Okay, what does it mean? So have you ever seen a kind of DAG? DAG means directed acyclic graph, or just for the simple, you can say, understanding, have you ever seen a pipeline? Yes, you see a pipeline that starts from something and it ends somewhere, right? So it is nothing but a kind of pipeline, basically an orchestration that it is performing under the hood. First of all, it will create a node, this type of node. Let's say this is like node number 1. Okay, this will be the start node. Okay, simple. This will be the start node. That means the DAG is started, basically the pipeline is started. Then it will simply create one LLM node. Okay, one LLM node. Simple. Okay, LLM node means the node that you have for your tool binded LLM. Simple. So it will go from start and it will go to LLM like this. Simple. And let me just move it like vertically so that you can also understand better, because it's a kind of workflow, or it's also fine like this. Simple. So it is like start and then LLM. Then after going to LLM, it has a special node, which is a conditional node. It is called tool node. Okay. It's called tool node, and it is not basically, you can say, connected. It is an conditional node. Okay, so I will just make it, it's dotted, because all the conditional edges are represented as like dotted or dashed lines. So this is a tool node. Simple. So this tool node is actually a conditional one. So that means LLM can use this node or it can skip it. It totally depends. And you know the answer as well, because we have already seen that it will only call the tool if it is required. Otherwise, it will not call it. Simple. And the speciality of this tool node is that it has access to all of the tools. All of the tools. Wow. Yes. We simply create a tool node and we just have access to all of the tools that we have. Basically, we can say toolkit. The entire toolkit is there. Simple. Very good. Then we have one more node, which is called end node. That means end of the graph, end of the loop. That means the final answer is here. So now what will happen? And this will be a fixed node. This will obviously go here every time. Simple. So now what will happen? So this is your graph that it runs under the hood. Yes, this is the same graph that it runs. Now what will happen? Your LLM will say that I want to use a tool. Let me just bring that VS Code, React agent. Perfect. So let me just see the output. So what is written here? Human message. That means start. We have started the node with the human message. Simple. Very good. Then it will say AI message. AI message is what? LLM message. LLM message is what? It will say, I want to use a tool. Okay. Which tool? XYZ. Any tool. Okay. What are the arguments I need to pass? These are the arguments. Then this tool node will take all of the information. Okay. And it will process the information produced by this LLM. Basically this output. This one. It will process this message, AI message, entire message, and it will see how many tools I need to use, what are the arguments I need to pass. Then this tool node will simply make a tool call. Simple. It will simply call the Python function, pass the arguments, and that's it. It will get the response back and it will save this message in the form of tool message. See, this is a tool message. Then this tool message again go back to this LLM and it will process that information. Then if LLM feels that, okay, I am happy with this particular, you can say, your answer generated by tool. Okay. Otherwise it will make another tool call and so on. Simple. This is the most latest and the modern approach by Langchain. It was not the case before. Earlier, it was totally relying on the React prompt. What was there in the React prompt? Let me just show you if it is still available by HW Chase. HW Chase basically is a founder of Langchain. So he wrote an amazing React prompt back in the days when we used to work with React structure, or you can say React prompt aligned approach instead of this create agent. So I can just find it for you. React prompt HW Chase. Let me find it. So I can just scroll down. I think this is the one. This is the GitHub repo. Yes, this is the prompt. So basically this is the prompt. Here you simply ask the LLM to run a loop. You do not have any kind of DAG. You do not have any kind of nodes and edges. You simply ask LLM to run the for loop, basically the endless loop, till the time you have any, you can say, final answer. And we also provide a kind of scratchpad at the end if it is here, because we used to have a lot of iterations as well. Langsmith, because they were like dedicated. Oh yeah, this is the one. So see, this is the prompt that we used to use, and we simply say the question, that means the input. Thought, you should always think about what to do. Action, the action to take. Action input, this. Observation, this. Thought, final answer, begin, question, and throughput, basically agent scratchpad. What is this thing? This is, you can say, the power of prompt. Earlier, when we didn't have this kind of nodes and edges architecture, we used to rely totally on the prompts to perform the React architecture. Wow. So that is why everything is written in the... Who is this man? That is why everything is written in the prompt itself. That is why you are seeing that, hey, this is the question, this is the thought, this is the action, this is the observation, this is the final answer, and this is the question, this is the agent scratchpad. Agent scratchpad is basically what? It is nothing but just, you can say, a kind of scratchpad for the agent where it can just note down the result. So we were totally relying on the prompt and that's it. Yes, and it was working fine. But after some complex, you can say, frameworks, basically not complex frameworks, complex, I would say, DAGs, when we used to work with such a complex DAG where we have to just rely on something structured instead of just depending on the prompt. Because see, this prompt will work well with high-end LLMs, but this prompt will not work well, or basically this approach will not work well when we do not have high-end LLMs. Because if we are using high-end LLMs, they can understand the prompt better. They can just generate the answer better. But when we use just open source models, it does not work. But when we work with this kind of approach, you can use literally any LLM. Obviously, like good LLM, not like garbage LLM, but you can still work with open source LLMs and it will work. Why? Because you are not passing a prompt to provide or basically create this React architecture. You are building your own React architecture. Okay, and Langchain has used LangGraph under the hood, because LangGraph is what? LangGraph is basically an orchestration framework where you build everything from scratch. So they basically created LangGraph, then they saw the power of it, and then they just recreated its Langchain libraries as well. Langchain, these modules and all. I personally know LangGraph, so that is why I know like how they have just created this thing. But you can also do it without need to worry at all like about LangGraph. It's good to know LangGraph, but it's the optional thing. Okay, if you know Langchain, if you understand this thing, you can build agents easily. LangGraph is basically more on the agentic AI side, who are more aligned towards AI engineering, pure AI engineering. Okay, but you being a data professional, you just need to know how to build the agents, and that's it. And again, it's personal choice. If you want to learn more, no one can stop you, because I am totally against this particular criteria where you simply learn the stuff according to your domain. It's not true. You should just learn whatever you want. Simple. So now if you just want to learn LangGraph, yes, you can just learn LangGraph. I have a dedicated course on LangGraph as well. But if you just want to if you just want to be aligned on the data domain, it's fine. Create agent is fine. It's more than enough, because we need to just cover a lot of stuff here as well. It's not the end. Okay, so this is basically behind the scenes for this create agent module that we used. Simple. So this is all about it. Now I want to talk about a very important concept. Simple. And what is that thing? It is basically called structured outputs. What is that thing? You are a data professional. Yes, you are a data professional. I assume this thing. Even if you are not, maybe you want to come, okay, in this lovely domain. Welcome. We are here to welcome you. No need to worry. So let's say you are a data professional and you want to create these structured outputs. And I think no one can understand the power of structured outputs better than data professionals, because we work with schemas. We work with like dedicated, well-defined structures. If anything is broken, then obviously the entire downstream will be broken. So structured output is very important. But someone who is not familiar with the data domain, they would think like, do we need to actually worry about structured output? So we data domain people need to tell, yes, you need to just be worry about structured output. Basically, let's say you are seeing this answer. Which answer? By this AI message, which says content equals to this. So there is no structure. You are simply getting the answer. John Doe is 30 years old and works as a software engineer. Let's say I want to define a schema for the answer, because see, whenever you are building a solution in the data domain, you need to know that schema is the most powerful thing. Otherwise, it will simply break the downstream solutions. Let's say instead of generating content like this, you want to generate something like this. Or maybe let's say you ask any LLM. Let's create a new chapter. Okay. Or let's create new notebook here, because you will have everything under one chapter. So let's say structured output. Simple. So if I simply create my LLM, select kernel, I still remember that particular error, bro. It was a nightmare, but we solved it, so it's good. So that is fine. And you know what? I even solved that particular error for IPy kernel for 3.12 as well. Okay. And if you also want to know what was the debugging solution, so sometimes when you use 3.12, there can be some bugs. Okay, so you just need to install a new Python runtime. So you can uninstall your 3.12 and you can again install a new 3.12, so it solves the problem. It happens with 3.12 because there are some bugs still. Okay, so it's fine. So I just fixed 3.12 as well, and obviously 3.11 as well. So yeah, so let me just quickly create LLM. Okay, LLM is here. So now if I simply ask my LLM to generate something, let's say I want to say LLM.invoke what is the capital of France, let's say. Okay, so it will say Paris. Everyone knows this. Content equals to capital of France is Paris. But I want my LLM to generate an output. What do I mean? So let's say I am using this LLM. Okay, and I want my answer towards the capital of France. Simple. So here, instead of generating a simple answer, I want my GPT to generate something aligned with my schema. So let's say my schema is this. Query the question that I have asked, simple, or something, let's say this, and then answer whatever LLM generates. Let's say capital of France is Paris, whatever. So I want to keep these two columns, query and answer, in my schema. Why? Because the downstream solution that I have built for my stakeholders, I am expecting these two keys because I have the downstream solution depending on these two keys. I am using these two keys. It can be any API, it can be any solution, it can be any dashboard, it can be anything. It can be anything. It can be, you can say you are even writing some data, let's say to the Delta files. It can be this scenario. So you want your LLM to perform this task. Makes sense. And this is very important in the real world. So Ansh, how can we just do that? Because see, LLM is obviously generating the answer, but how can we just guide it to generate the answer in such a format? There are two approaches. The one is lightweight approach. The second one is heavyweight approach, but heavyweight is a recommended one. But when you sometimes, let's say, want to perform some lightweight stuff, it works because nowadays LLMs are like very well organized and much optimized for these kinds of tasks. Earlier, when we used to work with GPT-4o, I still remember, we were telling that, hey, generate the output in such a format, but it was not generating it. Okay, but nowadays GPT-5, 5.4 is like very much advanced. They understand what exactly we want, but still, lightweight approach is good for prototypings. But if you want to build something in production, you have to rely on the heavyweight. I will just discuss both the ways. Simple, very good. Now I will say what is the capital of France, and I will say generate the output with this format. Which format? So I will say, first of all, let me just tell it here. Query the query, answer the answer. Okay, now let's ask the same question again. Let's see what do we get. Perfect. Now I got it. Let me just clean it first of all, because obviously we do not need to see AI message. So I will simply say response equals to this, and I can say response dot content. Simple. So now you will see the response generated by LLM. And now I should see my output in the format that I want. Basically query and answer. See? Oh, I forgot to mention response. Simple. Perfect. Query, what is the capital of France? Answer, Paris. Wow. This is the exact thing I mentioned here. Because nowadays LLMs are smart, we can rely on LLMs for these kinds of tasks. But sometimes our schema is such a well-defined schema and we cannot compromise with that. We cannot. Sometimes, yes, this is a scenario. So if we want to work with this kind of scenario, we have to rely on the heavy lifting work or heavy lifting approach. And this is the recommended approach as well. Okay. So in order to achieve this kind of stuff, we have to know how we can just define the schema for our responses. Okay. And for that, we use Pydantic. Earlier, we used to work with data class model or data model class, whatever you can say with Python. I can just show you. So let me just go to Python. Data class. Data class is very popular Python class for basically implementing or guiding any model or any kind of output that, hey, I want just my output in such a way. Basically, data class is basically the, you can say data or schema validation, basically, or data validation, because I don't want to call it as data validation. I know people still call it as data validation, but data means like schema. Okay. So here we used to work with data class like this, add the data class, and we used to create our schema like this. This is the old way to do it. Still people use it. I'm not denying this thing, but Pydantic is the recommended way and Pydantic is the modern way. Pydantic is actually an amazing class or basically package that we have within Python now. Pydantic is booming if we just want to validate our schema, validate our data, because it is not just a data validation class. It is also data, you can say, first of all, validation and then data parsing as well. It does both the things, data validation plus data parsing, which is amazing thing. So let me show you Pydantic documentation. And do you know what? I have been telling my data fam to learn about Pydantic since so long, but I don't know what is stopping them. So if you want me to just teach you Pydantic in one short video, just do let me know, because Pydantic is that particular thing in Python that you cannot skip. You cannot skip at all. These are some advanced things in Python, because see, Python fundamentals are for everyone. Data analyst, data engineers, data scientists, web developers, whoever is using Python for scraping, whatever. Those fundamentals of Python are for everyone, for every single person. But when you are in the data domain, you need to learn Python with that particular approach. People think that if you are in the data domain, we just need to learn pandas and that's it. Bro, no. You have to learn Pydantic and asynchronous. There are like some other topics as well. I will just talk about it. But please follow this guidance. This is very important for you. Python fundamentals are just like fundamentals. You need to just learn advanced things as well, right? This is 2026. So now I can just show you that this is your Pydantic documentation, first of all. So here, if I just read it, if I just go to, let's say, why use Pydantic. So here you will see, today Pydantic is downloaded many times a month and used by some of the largest and most recognizable organizations in the world. That is true. That is actually true. And it is hard to know why so many people have adopted Pydantic since its inception 6 years ago. But here are a few guesses. Type ends. If we just want to use schema validation, okay, then we use Pydantic. If we just want to use, let's say, schema parsing, we use Pydantic. And do you know what? After the AI, after the boom of AI, Pydantic has become the go-to framework to validate the schema, especially in Python. That is it. People use typedict as well, but typedict is not basically, you can say, is a parsing or data validation library at all. It is just for type ends, but Pydantic is that particular thing that you should know. So do not worry, I will just give you a basic demo of Pydantic as well, so that you can just understand the stuff. I really want you to learn about Pydantic. So now I will simply say Pydantic. How do we use Pydantic? Pydantic is basically a kind of library, obviously, first of all. Then after that library, they have created a special class called base model, where we simply inherit that base model and we define our schema. That's it. When we define our schema, we can just simply say that our data is validated. Let me show you. So let's say, first of all, let me just import Pydantic. And before that, let me just add Pydantic to my environment. So I will simply say uv add Pydantic. Oh, it was already there. Wow. Because Pydantic is, I think, automatically added with Langchain. So that is good. So Pydantic is there. I can simply say from Pydantic, import base model. This is the same class that I was just talking about. Base model is a class that actually performs everything for you. You just need to inherit it. Yes, simple. So I will create my class, let's say, LLM schema. Okay. My class, whatever name I just can say, schema, but you need to inherit base model. Base model, simple. Now you simply need to define the schema. Basically the column and data type, column and data type, column and data type. I will simply say query of string type, answer is of string type. This is my schema. Simple. This is my schema that I want to just pick. Okay. And you know what? Just for my logging purpose, you will find one more interesting thing. Let me show you. Let me just comment it out and let me show the raw response. Simple. Okay, so here you will see tokens. Okay, 279. Prompt tokens 33. Total tokens 312. Let's say with the response I also want to fetch the tokens with every response because I'm just using it for my logs. Simple. That's called downstream dependency. Maybe you have a pipeline running which is actually calculating the cost for the tokens and you are simply providing a monitoring on top of it. See, that's how you relate with the solution. Wow. So you will simply say, I also want to add one key, let's say total tokens. And here you can also provide some description because it is very important whenever you just want to provide the description. Basically, whenever you want to just work with Pydantic, it's not actually mandatory thing that you have to provide a description. But when you provide description, LLM would know that, okay, I want to populate this column and the purpose behind populating this column is this one. So it's basically helping my LLM. Simple. It's kind of docstring. Okay, kind of docstring that you create for tool. So I will import one thing. It's called field. Okay, and I can say equals to field because see, query is of string type. This is type hinting. This is all about type hinting that I have created this one variable and variable type is string and this is integer. Simple. So here what I will do, I will simply say field and then there's a special function called description. Simple. Description, and this is the description I want to provide. This is a description that I want to provide this thing, the total number of tokens used in the LLM. So perfect. This is the description that I have provided for my model. Simple. This is my class. Now let's say I want to use this class. Do you know what? Let me just show you the validation step. So this is validation, or basically this is the class definition. Let me just show you the validation. So if I want to use this model, I will simply say, like normal class object, I will simply say object equals to LLM schema. I will create my, you can say object, and in this object I need to pass 3 variables, right? Like whenever you create class, bro, this is like OOP fundamentals. Whenever you create a class, you simply define the variables that you need to pass, right? Simple. So I'll simply say query equals to this, answer equals to this, total tokens equals to 10. So what should I see now if I say object? I should see this thing. Wow. Now this is not just a response. This is actually the class object. See, LLM schema. What is LLM schema? My class name. What is this? These are the variables. Wow. Yes. Makes sense. So this is used for your validation. Now, do you know what? If I simply say 10 like this, or let's say if I write something else, let's say the total tokens are 10. Obviously, LLM can generate this thing like this because see, answer is right, but it can generate it like this, right? So now if LLM will generate this thing, it will not work. Why? Let me show you. It will say validation error. See, one validation error. Why? Because I have defined my total tokens column is of integer type. How dare you generate the answer using a normal language? Total number of tokens are 10. How dare you? I do not want you to use any natural language. I want you to just return the number. Wow, this is the power of LLM schema. This is the power of my Pydantic class. Now LLM has to. It is forced to generate the output in such a format that I want to use it for my downstream, you can say, solutions. It cannot generate anything randomly. I know answer is still correct. Total number of tokens are 10, but I am not reading this particular thing. I have built a downstream solution to use this. Make sense? See the difference? I hope it makes sense now. So I have to use 10 like this. I have to. Otherwise it will not work. This is called data validation. Wow. But Ansh Lamba, okay, it is fine. You just created one object, but how it will be integrated with LLM? Let me just show you. So there is basically a kind of special feature in LLM, basically within the OpenAI models that we have. I think now this is with all of the other models as well, but initially it was just with your OpenAI models. So I will simply say LLM structured equals to LLM dot structured output with structured output. So this is the class that I need to use. LLM dot with structured output, and that's it. Yes, just one line. Earlier it was not just one line, because earlier we didn't have this feature available where we can directly guide our LLMs to produce the output in such a format. And at that time we again used to inject this schema in the prompt. Understood? So we used to inject this schema in the prompt that, hey, we have the schema, you have to generate answer like this. So this was the older way. I will still show you because I have that particular notebook, the older notebook, but this is the recommended approach, okay, by the way. So here I will simply say LLM schema. Simple. Now let's try to invoke my model. Now let's see what do we get. LLM structured dot invoke. What is the capital of France? And I will not tell it just that generate the answer in such a format or blah blah blah. No, I just want to see how does it behave. And I can simply say response as well, just to see the output. Wait, let me just clean it. Response equals to response dot content. Simple. Now let's see. Let's see. Wow. LLM schema object has no attribute content. Oh yeah, that makes sense. That makes a lot of sense, because in the response we should only see the raw response, because that is a kind of Pydantic output now. Perfect. See, did I see anything like this? AI message, content, why? Because LLM knows that I just want to return this particular object, and that's it. Wow, this is actually very nice. Yeah. This is actually very nice. So you should always use LLM with structured output whenever you want to generate the final output, where you are using the final answer, not in between your workflow. Or you can do it, but you have to just rely on this particular schema. You can do it, but it depends. Simple. So this is the response that is generated by LLM. Wow. Simple. So now one more thing. If we want to use this particular thing, okay, how we can just do that? So because obviously this is a class object, Ansh, Lamba, how we can just fetch the query from this thing or answer from this thing or any tokens from this thing. So in order to do that, you just need to say response dot, or let me just write it here in the next line, response dot model dump JSON. So this will convert your output into the dictionary format. Simple. Or you can also say model dump. Simple. Then it will be a dictionary. If you say model dump JSON, then it will be a like string of dictionary format, basically JSON. Simple. So if you just want to fetch now the information, you can simply say response.model JSON, and then you can simply fetch query, answer, total tokens, whatever you want to do. Okay. So let's say I just want to do query. I can fetch it like this. Simple Python fundamentals. Okay. So this is the thing. So that's how you can just work with the structured output. Simple. It was simple, but it is like very powerful. And now you should know how you can also use Pydantic everywhere, not just in AI solutions. You should use Pydantic in your Python modules, classes, utilities that you create for your data engineering solution, data analytics solution, whatever, wherever. Okay. So you should use Pydantic. It is very powerful and it actually validates a lot of stuff. You can just use these things as Python arguments or basically function arguments, and you can just use it anywhere. It's totally up to you, but you should be aware of this thing. Simple. Very good. Now I want to talk about an important stuff. All the things are important, but this is also important. Now we will learn about, because we are talking about Langchain, okay, and we are building agents. So whenever we build agents, we should know that we can even work with something called as prompts, prompt template, basically, not prompts, and chains. Prompt templates and chains. These are very important whenever we build agents. Okay, what are these things? I will say templates and chains. Simple. These are very important. So what will happen is, whenever we create any kind of prompt, let's say we are writing something like this. So here we are writing directly. Here I'm simply writing the question and it is directly going to the GPT. And you know what? Whatever we ask from the LLM, it goes with the type of message. There are basically 4 to 5 types of messages: human message, AI message, tool message, system message, and there's like one more message. Let me just show you that as well, because it's a very simple thing, but simply important for you. Types of messages in AI agents. So I'm expecting a very good answer. Yes. No. Let me just write it. AI message versus human message versus system message, because these are the major types of messages. Then we have tool messages as well. But I'm hoping that the article will contain obviously all the things. Oh, let's open OpenAI. Good. Should I use, bro? We are not here to read your questions. Should I use system or let me just explain. Okay, there's one documentation. Oh, perfect. So we got one good documentation by Langchain, messages. So messages are the fundamental unit of context for models. Yes, we know that thing. This is very basic. So this thing is very important. Role. I'm just talking about the messages and the role, because I am saying something. Okay. So who is just asking the model? Me. Who is me? Human. So the message that I will send to LLM should know that human is sending me the message. That is called human message. Wow. Yes. Simple. So here they have also talked about 3 messages. Very good. So these are the 3 types of messages: system message, human message, and AI message. Ansh, Lamba, we know about AI message. AI message means the LLM is generating the response. Human message is what that we ask. What is the system message? System message is basically you are guiding LLM how to behave. We know that LLM can do literally anything nowadays. Simple, literally anything. But when you guide LLM that, hey, you are a poet, you are a someone, and then you need to just generate the responses, then LLM will be inclined towards a persona, and that LLM will behave like that persona and it will generate answers like that. Wow. System message is very powerful. Currently, the most popular tools such as Claude Code strongly relies on Claude.md file. If you know about Claude. Claude.md file is what? A kind of system message that we are passing to Claude. Whenever we start any kind of conversation, we simply provide a detailed message that, hey, you are this thing. Hey, you want to follow these rules. Hey, just make sure that you use this thing in your answers. Hey, you are in this domain and behave like this person. Hey. So many hey. So you simply guide. So here in this example, they are simply using one line prompt. You are a poetry expert. So now it will ask the question, write a haiku about spring. Now AI message, obviously, like without the system message as well, AI message can write the poetry. But when you guide LLM how to behave, it can actually generate better responses. It's a kind of, you can say, on the fly fine tuning. On the fly. You are simply guiding LLM how to behave, and that's it. And system message is actually very powerful if you know how to use it efficiently. Simple. Very good. So now whenever we just send any message to LLM, we do not pass anything, right? We do not pass anything. Actually we do, but this Langchain has built a kind of, you can say, wrapper on top of it. So that is why we do not send anything like this. But do you know what? Even Langchain allows you to pass the messages in the form of messages, you can say your list. Let me show you that particular thing. So in Langchain, basically without Langchain, obviously there are multiple ways because OpenAI will behave differently. And let me show you in the OpenAI thread as well. So let's say messages OpenAI. Responses overview, quick start, text input and output, client OpenAI. Yeah. So here you can see role assistant. No, this is the response from the AI. I want response from our end. Yeah, perfect. So here you will see, let me zoom in. So here, whenever we create a client, whenever we want to ask anything, so here we just simply pass the messages like this. Role is developer, talk like a pirate. Basically, this is the system message. Then role is the user, R semicolons optional in JavaScript. This is my question. So we pass the messages like this if we want to guide our LLM to generate the better responses. Simple. So obviously now OpenAI has its own way of writing it. Gemini will have its own way of writing it, and blah blah blah. So Langchain uses a wrapper on top of all of the things. So how do we define our roles, or basically how do we define our prompt templates, or basically messages in the Langchain? Let me just explain that particular step. So it is very simple. First of all, so what we need to do, let's create a new notebook. Let's say prompt templates, because within that we will just talk about the template as well. Prompt templates, IPYNB. Let me just create this thing. Perfect. Let me just run this. Perfect. So this is my LLM. Simple. So now if I want to use, let's say, Langchain, I do not need to worry about anything. Okay. I do not need to worry about any kind of messages. I do not need to worry about any kind of OpenAI, Gemini, or Claude's way of writing any kind of message. I simply want to send the message. Simple. Simply want to send the message. So how I can just send that message? It is very, very simple. So basically you will simply say LLM, let's say LLM response, or let's say response equals to LLM dot invoke, and you will pass the messages here, list, and I can prepare my messages. Messages will be a list. First of all, messages equals to this particular thing. So here I will simply say role. Role is what? System. System means the system message. Okay. So I will simply say you are a helpful assistant, or let's say you are a Gen Z poet. Simple. And the second role is mine, user. Write a poem about beauty of nature. Simple. These are my messages. Simple. So now if I just simply say response.content, I will see the response, but in a better way, because I am using the role and I'm simply guiding the system message as well with my LLM. Okay, and now let's see, it is writing the poem. Let's see what do we get. So we have got this amazing poem. I step outside. The air is older than my playlist. Spells warm like someone unmuted the world, blah blah blah. Read, whoever wants to read this poem. So okay, so this is the content that we have received. This is very, very good way to use it. But Ansh, Lamba, this is working absolutely fine. Why do we need to use the templates? So see, let's say you are building a solution where you know that this particular role, this content will be changing. User can ask anything. User can say that obviously I need to just write a poem, but not about the beauty of nature. Maybe something else, maybe on sea, on ocean, on anything, on mountains, right? So I want to create a variable here. Simple. I want to create a variable here. So I can simply say topic. Simple. Topic. Okay. Now I can simply pass this thing. It will still work, but there's a better way to do it. Now I can simply say I want to use a module called chat prompt template. Let me just first of all import it from Langchain. Now I don't remember the class name. Maybe Langchain.core dot, what was it? Let me just check the class name. Wait. Okay, so it's called prompts. Prompts import chat prompt template. So this is the template that we use. Now, do you know what can I do? Just simply look at how it parses your prompt. So I'll simply say my prompt, or basically my template, equals to chat prompt template dot from messages. Okay. Now I will create my messages. I can literally pass this particular key as well, like this messages, but I will simply define it here on the fly. So I'll simply say a list, and I can say system equals to you are a Gen Z poet and write a poem about the beauty of nature, and I can simply write it here topic. Simple like this. This is my template. Wow. Yeah, this is my template, and this has a variable as well, topic. Do you know what? Now if I show you what will be the my template output, my chat prompt is not defined because I didn't run this. Now let me just run this. So here this is a class object where I'm simply saying input variable equals to topic. So now it knows that I need to pass a topic. Wow. And the benefit of this template is I do not need to mention role, this role, content, this role. No, simply pass a tuple and that's it. Wow. Simple. Okay. Then the good thing is you can change the content on the fly. That means I can say my template.invoke. Basically, whenever I want to fill this particular prompt, I have to use invoke. Simple. And I will simply say what I need to fill the key with. So I will say beauty of nature, or let's say beauty of mountains. Simple. Let's see what do we get. This time I will get the exact thing that it needs to pass to the LLM. See, messages list, automatically it created this kind of messages list because my messages will be created for this particular list. Wow. So messages equals to system message content. You are a Gen Z poet, and additional cogs, human message, write a poem about the beauty of mountains, and that's it. Because this is the kind of messages that OpenAI models expect. You have to write system message, you have to write human message, you have to write AI message. Remember our output here in the React prompt, React agent. Here, see, human message, AI message, tool message, whatever. So here it will generate the messages like this. Make sense? So now I can use this template, my template, and I can generate any prompt out of it. So let's say this is my mountain prompt. Simple. And I can simply create nature prompt, ocean prompt, whatever prompt. So that is why we do not rely on this particular method where we simply hard code the stuff. Okay. We simply create a template and we reuse it. Okay. Good. Very good. And there's one more benefit of it as well. When we will just talk about chains, then we will just talk about it, because some people can say, hey, we can also use f strings. So why we need to just worry on this particular thing? So you will just get to know when we will just talk about the chains. Chains are very important. Simple. But now you know at least this particular thing, right? Good. Now to answer your questions, let's talk about the chains. Okay. So let me just remove it. So here I can say template. Simple. Okay. So now whenever you just talk about chains, so chains are what? Chains are basically nothing but the pipelines. Yes, pipelines in the AI. Especially in the Langchain, it's called basically the pipeline. So let's say you want to perform a kind of orchestration. There can be, first of all, parallel chains, series chains, conditional chains as well. But here we are simply learning the fundamentals. So we will just talk about the series chain. That means a simple chain like in one go. If you want to just learn about this particular thing in detail, then obviously you can dig deeper and deeper in the Langchain. I have a dedicated course on Langchain as well. Simply search Langchain full course, you will get it. But here we are simply getting the fundamentals of it. So we will simply build a simple chain, simple pipeline, because that's how you grow. You cannot just build the complex pipeline in just on just day one. So let's say you have a pipeline like this. So first of all, let's say you have a human. Okay. And let's say this is the human. Let's use this one. This is cute. Let's say this is the human. And this human wants to just perform so many tasks. Let's say first of all, this human will write a prompt. Then it will go to LLM. Then it will go to second LLM. Then it will go to some output parsing, and then it will generate the final output. So instead of running each step independently, let's say first of all this, then this, then this, then this, then this. No, we need to create a bundle, basically a pipeline like this, which can run all of the steps in one go. Simple, in just one go. So this person doesn't need to run independent steps again and again. This person just needs to press this button. Let's say there's a button here. Okay, there's a start button, and person can simply trigger this particular button, and that's it. The moment this person hits this button, this one, this will simply trigger the entire flow. This is called chains. Now, obviously, in our data domain, we just call it as pipelines. AI people are new to the world of pipeline, so they simply say they say chains. It makes sense, okay, because they have a product called Langchain, so they simply say chain, but you can just say anything. Simple. So now this is a kind of pipeline that we need to build, and it makes sense because see, you are writing or you are performing basically a kind of flow, and you do not need to perform it again, basically run it again and again. You simply need to create something which you can trigger once, and it will populate everything for you, which is dependent on the previous step. Simple. Very good. Let's try to achieve this thing. So here what we will do, we will simply create a chain, and here let me just create a chain. And how to create it? It's very simple. You just need to define the invoking objects, and that's it. Chains. So here I want to create a chain first of all, because see, the very beginning step is obviously the prompt that we need to pass to the LLM. Simple. So let's say I want to create a prompt and I want to pass it to my LLM. Okay. So for that, I will use this prompt template. Let's say we are building a solution for writing some poem. So we will simply write this particular prompt, my template. Simple. So this is my, you can say, first element of chain. Simple. Step 1. Simple. Step 1. Now in step 2, I need to pass this information, the output of this prompt, basically this value, to the LLM, not manually, automatically. So I'll simply say step 2, sending the prompt to the LLM. So here I will define my LLM structured output. LLM structured equals to let's create one LLM object. So this is our LLM. So LLM dot with structured. Yeah, let's create the structured output. Yeah, it will make sense. So in order to create the structured output, we can just use the existing library, which is this one. So I'll simply create it here. So this is my class. So I'll simply say LLM structured. Perfect. So this is my structured class. Simple. Now, then step 3. This is very interesting. This is called parsing. Because now you do not need to manually write anything, let's say dot content, dot this, dot that. You want your LLM, basically this chain, to do all of that stuff. It is called basically the chains with structured output. Simple. So in order to create a chain for this particular task, like how to just create a chain which will automatically do all of this stuff, then you have to use something called as, I think there's like special parser for Pydantic. Yes. You have to use this Pydantic parser. We'll just see like how to import it, but this is the class that we just use. Okay, Pydantic parser. The special thing about this Pydantic parser is nothing but it will simply parse that object. Remember, whenever you just want to parse it, like parse the class, we always start with that particular thing that, hey, this is my class object and I want to convert it into JSON. But here, I do not want to write that logic by myself. No, at all. No. So I will simply say I will use Pydantic output parser. I think there's a like special class called output parse or something. So they just keep on changing the name, but we will just find it. Don't worry. So here, let's try to say step 3, invoke, not invoke. So I'll simply say step 3, parsing the output. Simple. So here I would need to import that class. First of all, let's try to import it from Langchain code. Yeah, this is the one. Output parsers, import Pydantic output parser. So I'll simply say this is my parser, which is this thing. Pydantic object equals to LLM schema. Now this is my chain that I'm just going to create. Step 4, or let's say final step, putting it all together. So here the best part is you can literally put all of these steps together by the modern approach. It's called Langchain expression syntax or expression language, LCEL. LCEL. Let me just double check the name. LCEL. Yeah, Langchain expression language. So you do not need to write any logic now. You simply need to use expression. That means I will say my chain equals to, first of all, the step 1, my template, and then just use the pipe symbol. Okay. Then LLM structured, then pipe symbol, then parser. Now this has become the entire chain. Now, do you know what? I just need to run this chain and it will automatically do all of the stuff. Let me just show you. So I will simply run it first of all, and I will say my chain.invoke. Now I have to just pass one variable. If you remember, in our very first step, we have a dependency on the topic. So we have to pass the value of the topic. Okay, let's pass it. So I'll simply say topic is beauty of mountains. So do you know what it will do? It will fill the value of beauty of mountains in this particular thing, and it will perform invoke. Yes, it will perform invoke on this one, my template.invoke, and then it will generate the output. It will generate this particular message. Very good. This will go to LLM. Okay, and then it will say LLM structured dot invoke, and it will simply carry forward the output of the previous step. Wow, yes. And then it will simply go to the LLM structured. Okay, then it will generate what? This particular LLM will generate what? This will generate a kind of this particular object, this thing. Then this parser, do you know what it will do? It will simply parse our output. If all of the schema, you can say columns are correct, then only it will generate the final answer. Otherwise it will fail the flow, because we want to parse it. So let's try to run it and let's see what do we get. Let's wait. And this will basically run the entire chain in one go. I do not need to run it like multiple times and by going to individual element or individual activity, not at all. So now let's wait and let's see. Obviously it will take longer because it will perform multiple steps, but it will perform all of these steps, I think so. Now let's, wow, one validation error for generation. See, input should be a valid string, type equals to string type, input value equals to LLM schema, write a whatever, blah 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 blah. So now it is saying something is wrong with the parser, because we have got one validation error for generation text. Input should be a valid string and we are getting something else. Simple. And now, first of all, if I remove this parser, let's see what do we get without parser. Okay, because first we need to confirm like our prompt and LLM is working fine. Let's wait. My chain. So we have got this particular answer, LLM schema query, and I think, by the way, it is only I know the issue. By the way, there is no issue. So first of all, let's try to see what it is actually doing. LLM schema, write a poem about beauty of mountains. Answer, we stand on blah 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 blah. So this is the poem that we have got. So now this time LLM has automatically generated the output in such a format that we do not need any kind of parser, Pydantic output parser at all. Why? Because we used to work with Pydantic output parser when we were using the format instructions in the, you can say, prompt itself. So let's say this LLM is generating the answer something like this. Let's say query, like here, this thing. Let's say LLM was generating the answer like this. So then we need a parser that will basically convert your dictionary into an LLM object. But now, because our LLM is smart enough, 5 is like obvious, GPT-5 is obviously smart. So now it is automatically converting your output into LLM object, basically your LLM schema object, your Pydantic object. But earlier it was not the case. We were simply getting the response in the form of dictionary, and then we had to manually parse it into become a Pydantic object. But now we do not need to do it manually. Why? Because now LLM is seeing that, okay, we have a Pydantic class. So LLM is automatically doing this work for me. But still you need to use it if you are using, you can say, some lower models, GPT-3 something, or maybe some open source models. If your LLM is not smart enough to convert your structured output into a Pydantic object, that you have to write something like this parser. That's why I have to use it here, even if it throws error, because I don't know which model are you using. Okay, I'm using GPT-5. Maybe you are using open source or maybe any other model which is not manually doing it for you. Simple. So if your model does not generate this object automatically, then you have to use parser. If it is generating Pydantic object automatically, then it's good. Simple. So it depends. So this is your chains. So this way you can put so many things together, and you can even build the parallel chains and conditional chains, because same way, the way you build the pipelines, the same way you can even build chains. But again, it totally depends upon the requirements, like what exactly you want to achieve. Make sense? So this is your prompt templates and chains, and I hope it makes sense, like how you just need to work with templates and chains. Simple. Make sense? So now, do you know what? Now we are going to build a React agent again. Okay, and because I just told you that we will be using React agent with the RAG as well, because that is a kind of link that you need to learn how to connect your RAG with your React agent, so that you can literally call RAG as a tool. And this is the step that you need to learn, and now you are ready to learn that because you are well prepared so far. So now let's see how your React agent can use your RAG as a tool, and how it will do all of that work for you, because while creating that thing you would need this particular knowledge. Okay, so now let's do that particular thing. So now let's discuss what we are going to learn. So Here we will be building React RAG agent. Simple. Because in the data domain, you will actually build this kind of agent most of the time because RAG is the backbone for data agents. Now what exactly we're trying to learn? So we will simply build this particular agent, obviously, plus we will attach a special thing here in our toolkit. It will be called RAG. I can just keep it as it is, and here I can simply extend it, and here I can put RAG. So this is my personal favorite as well. You will learn a lot of things. So let's add here RAG. Let's say Postgres for now. Simple. So this will become our RAG. And now let's see that how we can perform this task. This will actually be very, very helpful. Okay. And here we have to customize the code on our own because obviously we own the RAG. So we have to write the logic. Simple. By the way, it is not very, very complex. It's very simple. Now, because now you know all of the stuff that you need. When you know all of the stuff and when you need to combine the things together, it becomes a smooth experience. Simple. So now let's create a React agent. I will clone this notebook because I first of all need to write the existing logic where I need to combine all of the existing tools. So let's say RAG agent. Simple. Let's select the kernel, Python, okay. And here I can define all the tools. So let's actually run, okay, all the tools one by one. So here I will simply run this. First tool, second tool, third tool, and yeah, here we need to just create another tool. Perfect. So if you would remember that we already have created one RAG, which is here. Simple, which is here, ChromaDB. So we need to create a connection with this RAG. This is step number 1. Then we need to pass the query to this RAG, step number 2. Then third thing is we need to retrieve the content, step number 3. Then we need to, let's say, refine the answer or response so that it can easily be understood by LLM. 3 to 4 steps, simple. Okay, let's try to do it one by one. And yes, the very first step that if you are a developer, okay, you would know this step. So we first need to see like if the system variable or system path variable is working, because I need to see that do I have OS? Yes, I have OS. Okay, I will say if OS dot path dot exists, and I will simply say I think I need to just use one level up, then chapter 2, and then within that chapter 2 RAG actually, okay, and then within that I would say ChromaDB. If it exists, simply say print yes. See, so you have to use these 2 dots. Basically these 2 dots are used whenever you just want to go one level up, basically one folder level up, because you are inside chapter 4, your notebook is here, and you just need to go one level up, which will be like chapter 2, and then you need to go inside the chapter 2 and ChromaDB. So this is the thing that we will just be using. Okay, this is the path for our ChromaDB where we will be just building the connection. Simple. Okay, now you know like how to build the connection. Okay, so do not behave like, oh, what is this thing? So let's create a tool for our TF tool RAG. Simple. So whenever we just want to invoke a RAG, we need a query, obviously. So let's see string and string. And do you know what? And yeah, makes sense. Okay, use this tool when you need to answer question based on a specific document, set of document. No, because our RAG is built on top of Novasphere. So I will simply say question based on Novasphere organization. Again, I'm simply showing you the demo. You can write any logic to how to integrate the answers coming from RAG, because I have seen some people directly injecting the RAG answers into the prompt First thing. Second thing is they build a tool out of it. So that means whenever LLM feels to call the RAG, then they only call the RAG. So there are infinite approaches. It totally depends. But when you are aware how to do the stuff, you can just follow that particular approach. You will have options in your mind. If you do not know about how to perform the thing, how will you have the options in your mind? Make sense? Simple. Now let's quickly create the connection, and let me just grab that particular code for RAG connection. Where's that connection? Perfect. And I think I also need to import this chroma from this thing. Okay, perfect. So I'll write this here, and I will say chroma db equals to chroma, and the connection name is, where is that? RAG agents. No RAG agent, RAG. Okay, this thing. Chroma and connection is this. Okay, let's use it. Perfect. So here I can literally say that, where is this particular thing? Toolkit, RAG agent. Perfect. So this is my connection. Simple. Now because I have the connection, and what is the embed model? Let me just define that as well. Embed model. Yes, perfect. Let me just import OpenAI embeddings. Perfect. So now everything is sorted. Our connection is ready. So once our connection is ready, I can literally pass that query to my model. Simple, to fetch, let's say, top 3 or top whatever. So I'll simply say retrieving the relevant documents. So relevant document equals to .similarity search, k equals to 3. Let's say k equals to 2. I just want to pass smaller context, so k equals to 2, it's fine. So this will generate what? This will generate the answers, not answers, basically the list of documents. Remember, with metadata. If I just go to RAG, you will see that document, metadata, and then content. I do not need to waste my tokens on these particular things. I will literally fetch the values. So this will be my relevant documents. So I will simply say relevant documents content equals to join, because this is a list. I can just do it as well. Okay, this will also work, or I can use this method that we just used here, just to append the chunks like this and just passing it as like string. I can do it like this. Okay, but this is also fine. So I can simply say return relevant documents. Simple. Perfect. So now this is my function. I want to test it. Let's say tool RAG dot invoke what is Novasphere organization, let's say, and well, let's see what do we get, because I just want to test this particular thing, because this will go to my LLM. Oh, error. Wow, very good. OpenAI embeddings for Langchain core.embeddings. Really? What was the class name for embedding? For embeddings, we have Langchain OpenAI. Makes sense. Now let's run it. So here we have got the connection. Very good. Oh, we have got just these two. Why? Oh, is there anything wrong? RAG is this thing. Or let me just return the relevant documents. First of all, just to see what we are getting. Simple. Okay, so this is not returning anything. Very good. What can be the reason? Similarity search, query k equals to 2. Okay, if I just ask anything else, the same question that we asked here. Yeah, let's say this thing. No, not really. I think it is not even able to generate anything here. Chroma db dot similarity search. Okay, let's see what is wrong here. Embed model is here. User query. Enter question. Chroma db connection. I think it should work. Why it is not working? Okay, so now what I will do, I will literally test these 2 lines of code. Oh, see, I got it. I think this is the issue. The path was not correct. Path is chapter 2 RAG. Perfect. Chapter 2 RAG and then Chroma DB. Perfect. Like this. I think now it should work. Yeah, now it is a total text, okay, and all the two relevant documents are converted into in the form of string, and this is good. Now I can also guide that okay, I have already done that, so this will be returning the string. So now this is one of the tools that I want to add in my existing React agent. Simple. So I don't need to do anything special because this is already here. So I'll simply say bind tools, and I will add this tool to like tool rag. So now I can literally do it like this. LLM bind. I will run this LLM bind tools, and now if I ask any question, LLM bind dot invoke. Okay, perfect. React agent. Let's run the React agent. Let's see what do we get. So here now I can just invoke my agent for the RAG query as well. But here I will not do that. Why? Because remember in our RAG chapter, I told you that there are multiple chunking techniques. The earlier chunking technique was just creating the chunks based on the text size, based on the characters, number of characters we define. The modern and the more, you can say, mature way of creating the chunks is on the basis of the semantic meanings. What do I mean? So this Chroma DB that we already have, like we already had created a connection, that is fine. But now here we will create a new RAG, which is exactly same as the existing RAG, but here we will create chunks on the basis of semantics. For example, let's say if I open my novice.pdf, I will create, let's say, create one chunk for 100 characters. So let's say 100 characters are these. Okay, then these, then this, and it will be like very static. But do you know what is semantic chunking? Semantic chunking means it will start creating chunks from the top, okay, and it will go line by line, okay, sentence by sentence. So let's say this is the first sentence, it will create the chunk for this sentence. Very good. Then it will read the next sentence, okay, so it will say the organization was founded in 2016. So if LLM, because we include LLM while creating semantic chunking, because LLM will understand the context. So LLM will say, does this sentence is actually similar to the previous sentence? Is it related or is it a new thing? If it is related to the previous, you can say, sentence, then it will be merged or combined into the previous chunk, and it will be keep on doing this thing until it will find a new point or new starting point for the chunk. This is called semantic chunking. This is like more newer approach. Let me just talk about this as well because this is very important. Oops. It is called semantic chunking. Semantic chunks, let's say. So I can also show you the semantic chunks Langchain. They have recently introduced this thing and it is very, very important. Text splitter integration docs by Langchain. Perfect. Langchain text splitter is text structure based. This is like your normal recursive character text splitter. The second was is length based, similar to that particular previous one. This is document structure based. This is also good if you have, let's say, some JSON files. It will just keep on creating the chunks based on the file, based on the syntax. And where is that particular thing? Wait, because that is like kind of new thing. Maybe they have just put it in the package, or you can say your community or trial version experimental stuff. So text splitters. So no worries, I can just explain you with my example as well, but I was hoping that we will have something within Langchain. Plus I think this browser is like very, very good. This Microsoft one. Let me just find it here. So I will simply say semantic chunking Langchain. Build a semantic search engine with Langchain. Not really, or maybe they will be just using it here. Chunks. No. So I think I have, yeah, it is in the experimental class. I was so sure that they will not public it because it is very new. So they will just make sure that it is mature enough to put it in the public class, but that is fine. So I can just show you with my example, not a big deal at all. So here now what we will do, we'll simply create a new RAG where we will build the semantic chunks. Simple. So here what exactly we need to change in our RAG if we want to create a semantic chunk? Nothing else. I'll simply create or basically duplicate this RAG notebook first of all, and I will say second, not second, basically 5.1, because I will just move it in the chapter 4, and I will say RAG semantic. Simple. And let's move it here. Move. Perfect. And it will be, let's say 5.2. Perfect, because we first need to prepare our semantic. So here we will just convert our ChromaDB. Simple. And why do we have ChromaDB here? Why? Let me just delete it. Perfect. So now I will simply create the RAG semantic. Simple. So in order to create a RAG semantic, everything will remain the same. But here I just need to just use the new class. Instead of using recursive text splitter, I have to use something called as recursive semantic splitter, something like that. Let me just search it in my directory if I have this thing. So I remember, like, I just used it recently. RAG. Oh yeah, I found it. So now let me just show you that as well. This thing. Okay, RAG DB. This is here, RAG persist. Perfect. Okay, here. So this is the class. Oh, let me just bring it. So this is the class. It's called Semantic Chunker. This is the class name, and it is in the experimental class under Langchain. That is why it is not available in the official documentation, but it will be available in the community forums and those things. So let me just show you that. So here is a text splitter. See this thing. So instead of importing this class, I can import this thing, Semantic Chunker. This thing. Simple. So let me just run this, and let me just select the kernel. Perfect. So now we will create chunks on the basis of Langchain experimental. Let me just add this module. UV add. Langchain experimental. Simple. So let's run this. Perfect. So this is our PDF. This will remain exactly the same, but there is a catch. Here, whenever we use experimental feature, basically the semantic chunker, we have to convert the entire text in the form of normal text instead of like that document something. So that is the thing that you need to take care of. Simple. So you need to convert the entire page, the full text, in the form of content. Why this is important? Because when you want to create semantic chunks, you need to make sure that you are simply providing the entire text. Make sense? So what you will do, we'll simply run a loop, and I will simply convert that particular documents into that text form. So I'll simply say this is my textual data. Where is this thing? So this is my text data dot load. So text data, I can load it like this as well. Okay. So let me just do it. So let me just run a loop, and I will simply say I don't need to change the metadata. I'm good with that. So this is my documents. Okay, and I can run the for doc in documents, and here I can literally run this particular code. Perfect. Full text join p.page content. Perfect. And now if I just show you the full text, it will be my is not a valid file URL, obviously, because we need to just make sure that we have this particular file here as well. Okay, let's move it here, or let's copy it because we need here as well. Let's move it, or let's use the relative URL. I'll simply say chapter 2 RAG Nova. Perfect. So now this is my full text. This will be like very big text. Basically, entire text is here written in the form of full text. Now, this will use the LLM to create chunks on top of these long sentences. Simple, sentence by sentence. Creating chunks of the text data. Here, you cannot just simply define, hey, I just want to create chunks on top of this particular character size and that's it. No, here you will be using OpenAI embeddings, basically the LLM model to understand the context. Simple. So here I will simply say semantic chunks equals semantic chunker. And here I need to use OpenAI embeddings. Model equals to, by default it will take 3, but it's fine. Then I need to define one more thing. It's called breakpoint. Now what is this breakpoint? This is very important. First of all, let me just write it. Breakpoint threshold, I guess, threshold type. Yeah, I think it's percent type. Percentile. So here what will happen? Type. So here what will happen? We need to decide that how we gonna create the chunk. So for example, obviously every sentence is relevant to the previous sentence. Makes sense because this is one document. But we need to define how much percentage it should match to the previous syntax, basically previous your sentence. So if you define that percentile, then it will just calculate the similarity between the two sentences, basically the first sentence and the second sentence, and then it will automatically create a chunk for the sentence which will surpass that particular percentage, basically percentile. And I can just see, let's say breakpoint, I will just keep it, let's say 70 or 60. I think 60 is good. Yeah, let's say breakpoint, threshold, amount, let's say 70, or let's say 60. 60 is good. Simple. So I will simply say these are semantic chunks. Simple. Then I will simply say, or let's say chunker object, because this is the object. So I will simply say semantic chunks equals to chunker.create documents. Now I just need to create the documents. Okay, and from where? Full text. Now you can literally ask me this thing, why I have passed a list, because whenever you want to just create chunks, we have to pass it in the form of list. Simple. So now let's simply see how many chunks have we got, and these will be chunks based on the semantics and not on the recursive character text splitter. Where is that? We are not even using it. Oh, I didn't remove this code. Simple. Okay, we have seen the breakpoint, thresh, oh, double H. Okay. One more error. Divide not supported for the input, and the inputs could not be safely coerced to any support type. What? Which function? Chunker.create documents. I think we have this particular function. Maybe I have not imported the class, but I imported it. I think so. Text splitter, semantic OpenAI embeddings. Maybe this is not defined. Let me just check. I think this is the issue. So I just changed it back to 60, like how I was just using the text. See, like, what is wrong? What is wrong? What is wrong? And after debugging, I finally got it. So now I have got this particular chunks. And if you will just look at the chunks now, let me just show you. You will see the difference. You will see the difference. If I just read, let's say the first chunk, let's try to read the first chunk. Okay. 0. Let's see what do we have inside it. You will see the content says Novasphere Technology is a fictional organization, blah, blah, blah. And technology company has grown actually. The organization was founded in 2016 and by a small group of software engineers and who strongly believe that the data. So this is not actually creating the chunk based on the size of the text. Now this will only create a chunk if the percentile will be less than 60. Basically the similarity between the first sentence and the second sentence is basically less than 60. That means they are not much similar. This is the power of semantic chunking. Make sense? So it will not simply create a chunk on the basis of your entire sentence. No, it will simply compare the sentence. If it is similar, merge it. Similar, merge it. Different, create a new chunk. And then repeat the stuff. Wow. Yes. That's how it works. Still, I still feel that it can be further improved because it still only compares the first sentence, basically the current sentence with the next one. It should compare the sentence with all of the previous ones. Why? Because let's say I am simply creating a chunk. The first chunk is created. Okay. Now the second sentence is, or basically the next chunk, the starting statement of the second chunk is different. So now the next chunk is also created. Now if we just go to the third chunk, now the third sentence, or basically the starting sentence of the third chunk, will only look for the similar sentences for the fourth chunk. It will not go back. So I think it can only also be further improved. But yeah, so we are just using the one that we currently have. So that is fine. So here, if we have this particular thing, chunker.create chunk. So now we have these chunks. Simple. Now we need to use these chunks because these are semantic chunks. Wow. And we will use these chunks to create the database. Simple. So now let's create the Chroma database quickly. And I want to use this embedding, and chunks are semantic chunks. Simple. And now I want to use the Chroma DB and then Semantic. And I would recommend you to use this particular one. Okay. Why? Because in the real world, we just use this thing. So I can just test it as well. And I am just getting empty because obviously the name is different. Name is Semantic. Perfect. And here we should see perfect. The number of employees in big technologies, this help, so this will just have this particular thing. So we know that how it works. So I can, okay, so this is like terminal. I don't need to run the terminal. So this is my semantic RAG. Simple. So now I need to connect this RAG in my tools. So let's see how we can just do this. So I will simply go to Python, and in the tools, I will create a connection with the Chroma DB semantic instead of the previous one. Okay. So let's do it. So here, where's our tool RAG? Okay, here's a tool RAG. So here I can say connection equals to not chapter 2. It is Chroma DB semantic. Simple. Very good. So let's say we want to just do this and everything else is fine. And let's also ask one question. Let me just copy and paste a new invocation. I will simply say, when was Novasphere organization founded? Simple. Let's run all. Let's see what do we get. And this way you also learned about semantic chunks, how to create semantic chunks, which is like a very new thing. And this is actually overcoming the existing solution, existing problems that we have with the RAG, basically the chunks. Simple. Good. Now let's wait for it. Now let's wait. Okay, so perfect. I have got the answer. Was founded in 2016 by small number of groups, blah, 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 blah. And that's it. Because it is a very good way to create a RAG because your chunks are not actually missing any kind of context. If let's say you are getting a chunk on the basis of static numbers, it will simply break the meaning in the middle. But this way, it does not break the meaning in the middle. It actually enriches it. This is the power of semantic RAG. Make sense? And do you know what? The page index, the new way of creating RAG, not new, basically one of the new ways of creating RAG is page index, where they do not create the vector database. They simply create a page index, basically a kind of hierarchical nodes, basically tree graph. But I think that if you can just improve how your vector database should create chunks, you can automatically solve the issue. Do not need to create the page index, but yeah, everyone has its own choice. So now this is all about your semantic chunks. Now you know, if you have, let's say, long text, let's say like this, and if you have sentences like this, and let's say, so it will simply create chunk sentence by sentence, and it will group together the similar sentences, and it will simply use the formula that we have provided, 60 percentile. That's it. So let's say these two are similar. Let's suppose, okay. So this will be created like this. So there'll be like chunk for this one. Let's say these three are similar. This will simply create a chunk for this one. So that's how it behaves. Simple. Instead of creating a chunk on the fixed number of size. Simple. So these two are similar. Both are similar, and the percentile is more than 60 or 70%, whatever we just put it there. So yeah, and then this one was different, and then it created a new chunk, and then it was just keep on just attaching and merging the chunks. Simple. So that's how your semantic chunks behave. Make sense? Very good. So now let's talk about a very important concept. It's called memory of agents. Because see, whenever you are creating the agents, you just do not want to create an agent which will run and it will forget you. Obviously not, right? So for that, we have a concept called memory. Now, the beauty of this component memory is like so good because it's totally up to you how you need to manage the memory. First of all, Ansh, Lamba, just tell us what is memory and how do we just talk to it, or let's say talk with it. So basically, let's say you are this user, okay, and you just went to this LLM agent. This is an agent now. Simple. So his name is Rahul, let's say, and Rahul simply asked one simple question that, hey, what is the latest news on AI? Find research paper for that news. Okay, it will simply give the answer back. Let's say this is the answer. Simple. Now let's say next day, or not even next day, let's say just right after the first message, it will say one more message and it will say, could you please summarize this thing? Could you please summarize blah blah blah? Okay. This agent will say, wait, who are you? Who are you? And what are you asking? I do not know you. And that makes sense, because see, if I just go here, okay, this was our previous execution, my agent.invoke. So I just simply said how many, like, when was Nomosphere organization was founded, and it said that it was founded in 2016. Now let's say I want to ask one more question from this agent. Okay, now I will say, okay, could you please summarize it? Now do you know what it will return? It will say, what are you asking? What are you asking? What I need to summarize? I don't have anything. See, sure I can. What would you like me summarized? I need two quick things from you. So it doesn't know what to summarize. Why? Because see, here the message is key, has all of these information, right? If I want to ask anything from this agent again, I need to pass this conversation again. Common sense. Oh yeah. So that is called memory. So now what we do, let's say we have this thing. Okay. So now what I will do, so I will store this information somewhere on my system. Okay. Let's say I just save it in memory, in disk, wherever I can just store it. It's not a big deal. Okay. So let's say I just store it on the folder. You can store it in RAM as well. So I will just show you how you can just store it in RAM. But I think the better way to store it is in the form of, you can say the best way to store this thing is in the form of database. You can just store it in the database, in your MySQL database, wherever, for your each user, whoever is using the agent. But just for the, you can say, quick prototyping, you can just store it in the RAM, so that quickly you can just test it if it is working or not. Simple. Okay. So now what I will do, I will simply store this information in the folder. Okay. And now when I store this information in the folder, I will literally attach this information every time I am invoking or basically talking to my agent automatically. Now it will say, could you please summarize? It will say, okay, this is the query. Oh, I'm also getting this response. Okay. Basically this is also there. That's how it works. That's how it works. Again, you can store this thing in RAM, in folder, in data lake, in database. It's totally up to the user. That is the best part of this memory. Simple. But for the prototyping, developers always store the memory in the RAM, so that you can quickly see it. How does it behave? Simple. So now what we will do, we will simply create a new file, and here I can clone it, and let's say we want to use the same agent. Okay. So now I will simply create agent memory. Let me just clone this. Wait. Perfect. Let's say 6 agent memory. Perfect. We have this particular agent, and now we know that this will work. Okay, let me just simply test it, because this is just a clone of this particular previous agent. Now this is my agents. So every time I'm invoking my agent, I need to build a system so that every time I invoke something, it will automatically save that information for me. Okay. Again, if you are building a production grade application, you have to just keep everything in mind, like what is the username for the user, how you will retrieve the specific information for that user only. But here we are simply building a prototype where we are assuming that we are, like, I am the only user and I just want to talk to it. But if you are a data professional, I would assume that it is the most simplest thing that you can do, just to store the records in the database or store some basic information in the database or anywhere. That is the common prerequisite that I would assume. So we are not going to cover that particular thing in detail, but yeah, you should know what exactly we are going to do. Simple. And it has not started running the code. Very good. Sometimes VS Code behaves so weird, I cannot even tell you. So let me just refresh it. And let me just say run all. So, okay, now it will work. Perfect. So now this is my invocation. Simple. Then I need to basically ask some more information to store that particular information in the memory. Okay, in the form of key value pair, because this is what? This is key value pair, messages and all of the values in the form of list. See, actually, so I can even store the information. This will be like response equals to this. Okay, and let me just run this and I will just show you like what will be the value of response, and I can even access the messages key. So this is the entire value of the messages. Now what I need to do, whenever I invoke this particular agent, I need to simply store the value of messages key in my messages or basically memory list. So I will create a memory list. I will simply say memory, and here just to store it in RAM, I can simply say agent memory like this. Simple. This is empty list. So if I invoke this agent here, after invoking this agent, I will also, or basically I can just simply wrap this particular thing in the function so that if anyone invokes my agent, I would automatically store everything in the memory as well. So what I can do, I can simply create a utility. I can say, let's say def invoke agent. Okay, and invoke agent with memory, and here I can say agent, not agent. I will simply say query and string, and then I will also say memory. Simple. Okay, or I can simply add memory inside the no, I will just manage it. Agent memory, yes. So here I will say agent memory, because I will I think user doesn't need to rely on agent memory, so I will just handle it internally. So this is the function that I want to create. Simple. And I want to store this information inside this. So what this will do, this will simply make the call to the agent, and this will be my question, obviously query. Now after this, I will append this information to my memory. Wow. So this will work fine if the size of agent memory is basically nothing. See, so what I can do here, I can simply say this is my agent dot-invoke, and this is the role, and this is the user, and this is the content, this is the query. Now if you have some fundamental knowledge that we have learned so far, you will see that I need to pass this memory as well with every you can say query. Yes, so we have to make sure that how we can just append that particular response within our prompt. Okay, so here what we will do, we can literally pass the content here in the query. So I can write a basic f string. So I'll simply say this is my query, or you can write it here as well. This is this list, this is this thing. Okay, so I will say answer this query, and query is this one, and I will say you can use or whatever. Let's say first of all we are inside this thing. Okay, so you can use or you can refer to the previous input text, previous interaction in the agent memory if needed, or you can use the previous interactions, and here I will simply pass the agent memory. So now everyone knows that for the first invocation, whenever I'll be invoking this model for the first time, the agent memory will be nothing, empty list. Will be like this, obviously, but it is fine, because if we do not have anything, it will simply take this list as it is. Okay, and I can even pass it like this. Let's say string of agent memory, so that it will convert it into a list, like string list. Simple. So now even if we have empty list, it will work, because if it doesn't have anything, it will simply append it. Simple. Wow. And then it will return the response. Then if next time I just invoke this function, invoke agent with memory, then it will have something, and then it will be able to answer accordingly. Let's test this thing, because we have just written the code, we have not tested anything. So let's actually test it, because there can be some errors. It's not a big deal. So let me just invoke my function, invoke agent with memory. Let's say founded. Yeah, I think this is fine. What was the original? Okay, so this is fine. So invoke agent. Let's see what do we get. Okay, so this is the message that we have got. It is working absolutely fine. Now I want to make another invocation. What? Invoke agent with memory, and I will say, could you please summarize the previous interactions? Let's see what do we get. Let's see. Now it should get this entire chat. So now exactly, boom, now we have got the message. See, summary of the previous interactions, when was NoSQL founded, and it has literally summarized everything for me. Wow, because this time it got the memory. And do you want to see this agent memory? Let me show you. So now the value of agent memory is this. See, wow. So we have query, this thing, the response, simple. And then within that we have messages, key, because we literally stored everything within that. Okay, and then the second query, the second response, and the entire conversation. Wow. Yes, you can even make it better if you want to save some tokens. Let me show you how you can just do that. So let's say agent memory is this one. So if you just want to append, you do not need to append everything like query response. It is a better way, by the way. Personally, I love this particular format, because this way you can actually debug faster. But sometimes people just want to pass the interactions and that's it, and they just want to save some tokens. So what you can do, and it also works fine. So you can simply append the list. So I'll simply say response of messages. So if you use this thing, let me just rerun this thing. Let's empty it, messages, and if you just run this thing, and here you will not see this thing, query, response, or whatever. No, nothing. So this is the answer. Let me just ask this agent again, could you please summarize the previous interactions? And let's wait. Okay, so now if I just show you the agent memory, this time it is like very clear. Human message, like the first list and the second list. Wow. And even if you just want to remove this list, let's say the first list, the second list, you just want to store everything in just single list, then you can even extend it. Instead of append, you can extend it. List dot extend. What it will do, it will simply open the list, and it will just simply feed every element of that list inside that particular list. Python fundamentals. Let me just run all, and this time you will see only one list. Wow. But everything is running in the RAM. Okay, you need to remember this. This is a kind of temporary memory. That means if you will restart your system, this memory will be lost, but you can save this memory maybe in a file, maybe in the database, anywhere. So see, this is the most cleanest and the most you can say cost effective method to pass the conversation, because it will not put any extra special characters, and it is like pure conversation, human AI, tool AI, human AI, and then so on. The entire conversation is like this. Wow. Yeah, so you can even write this memory anywhere, but for the prototyping we just simply create a memory in RAM. But once it is working fine, once you have tested everything, then you can simply create that stuff. And you know what, this works well when you just have like few users, but when you have like such a huge user base, then you have to append that particular chat like that the previous way, like where you will simply write one key and then its value, one key then its value, because you can say that, hey, just enter your username, the person will enter the username, and then it will just add the key into your system. So it all depends upon how you are creating the architecture for the system. Okay, so this is all about this particular thing. And now I will simply write a simple code for you where you can literally run this agent in the terminal, and it will like keep on running for you the same way that you interact with ChatGPT. So let's create a demo version for it. So it's not a very special thing. So it's very simple. First of all, you just need to run a while loop. Basically, you just want to say, hey, I want to create a while loop. Till the time this loop is running, you just need to keep on running the stuff again and again and again. And if I simply say exit, it will simply create, it will simply exit from the program. Simple. So let me just quickly write it for you. And it's like very simple code. So let's try to write that code. It is very simple. First of all, okay. Ideally, we just write this kind of code with Python files. Why? Because it runs in terminal, but in the Python notebook, it runs at the top, but same stuff. So first of all, what I will do, I will simply say input. So I want to say input, ask me anything, because ask me anything, not just about this organization. Okay. Then first of all, let me just run the while loop, infinite loop. Do not worry, we'll just break it intentionally. But let me just write my code. Query equals to input, and then once I have query, I will simply obviously invoke the function. So I will simply say response equals to invoke agent with memory query. Once I have this response, I can print it. Obviously, I can simply say print response dot content. Simple. And then once I have this thing, then I will ask again the user flag equals to input. Do you want to continue? Yes or no? If flag dot lower equals to yes, then break. Bro, if it oh, not equals to, okay, I thought like equals to, let's say equals to just for the readability. No, and then break, and that's it. This is my infinite chat agent. I can just chat with it as much as I can, and it will just keep on remembering my previous conversation. Really? Yeah. Lightweight chat GPT. So let's try to run all from starting. Okay, and we will have everything. So let's say run all. Let's see what do we get. So it will just simply run all of the cells, previous cells, and then it will just run my, and I will just simply do a quick test. I will first of all tell it my name, and then I will just ask, hey, what's my name? And let's see. That will be the perfect test, because it doesn't know my name, right? So let's see. Let's see. We want to run this. By the way, you can even convert this Python notebook into Python file, which is not a big thing. So see, it is working. Ask me anything. What is Nova Sphere? Let's try to ask it. Okay, so now it will simply process information, run tool calling, blah blah blah, whatever we have done. We will get the answer here in the output area, and then it should just ask us again, hey, do you want to continue? If not, say yes, otherwise no. Dict object has no attribute content. Very good, very good. Break the code. Response dot content. Oh, makes sense. We do not have content. We have messages. Let's not just generate messages dot content, because we just want to generate the last content. And you know what? I can even comment out these particular things. Why? Because I will start a fresh chat. Otherwise, it will just keep on appending these things as well, which is a very common thing. So I'll simply say restart, save, and run all. Let's run everything, and if it runs fine, then it will be the time to say lovely happy ending of this video, and obviously a very good starting as well, because once you learn the fundamentals, then the next step is learning independent component deeply. But do not worry, I will just tell you all of the resources that you can just refer to if you just want to dig deeper inside any specific tool or technology. Okay, do not worry, just be with me, ask me anything. So I will simply say, hey, my name is Ansh. ANSSH. It's ANSH, by the way. I just clicked S two times. Like, this key is very sensitive, so it just keeps on pressing. AI message object is not subscriptable. Very good. Pro, simply say response. Please, please do not keep it complex at the end. So I'll simply say restart and run all. Obviously. Let's wait. Let's wait. By the way, you can just play around it, like how to fetch the key, and we are not here to just fetch that particular key. It's fine. So now let's wait. Okay, so now ask me, hey bro, my name is Ansh. Now it will say nice to meet you. It should say this, and we should see the response here in the output area. So answer this query. Hey bro, my name is Ansh. You can refer to, so this is my human message obviously, and here I should also see that particular AI message. Hey Ansh, nice to meet you. I don't see any previous interaction. This list is empty because obviously this is empty, but that is fine. So do you want to continue? Yes. So it will say, what is the next question? I will say, what is Novasphere, bro? So now it will simply keep on running the chat. And here we should see another messages field. Okay, another messages field, and the messages field is obviously this one. So it will just tell us, so see, this was founded into 2016 and blah 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 blah. Do you wish to continue? Yes. Ask me anything. So how are you? Then it will simply generate this particular message, and after this message I will simply say yes. Oh, sorry, no. So I will simply say no. I will say no, and chat ended. Wow. Yes. So I did a quick chat with my own lightweight chat GPT, and I can even show you my entire chat. I'll simply say agent memory. Wow. So this is the entire chat that I have done with the AI. I can save it anywhere. Currently it is in the RAM. You can just save it in the disk anywhere. And if I just come back, let's say tomorrow, if I have just saved it in disk anywhere, I can literally use this just to retrieve it. Simply pass it with my conversation. I can just keep on continuing my conversation with that particular AI. That's how ChatGPT also works. It stores the memory in a kind of database, persistent layer. That's it. See, we have literally built a lightweight ChatGPT, like literally using the fundamentals, not even digging deeper. Just think about when we would be using like advanced concepts such as LangGraph. We can just build literally anything. So we have literally built our own lightweight ChatGPT, okay, which is only customized for our data, for our documents that we want to process. Simple. So that's how you build the agents. Simple. Now I hope that our entire fundamentals masterclass is completed. And now let me just tell you the resources as well. Now again, the major components of this particular entire video was the first of all, let me just open that particular mind map. Okay. So this is our mind map. So if I just talk about, first of all, the LLM. If you want to learn about LLM, in my previous video as well, I just talked about a very good book. It's called Hands-on LLM. It's an amazing book. If you just want to learn about LLMs, okay, in detail, like how LLM generates, the decoder only architecture and so on, simply go with that book, The Source of Truth, because I always recommend reading books for my data fam. Sometimes some people does not like reading books, okay, because it's their choice. See, and nothing is wrong with that. Some people like to study from the videos, from the tutorials. So now you'll say, Ansh, Lamba, can you please teach us? The good thing is I have already made a dedicated video on LLM. Simply search on YouTube and go and search LLM full course Ansh Lamba. You will get everything that you need to know in the world of LLM. If you want to dig deeper inside LLM, because maybe you are working in an organization and they want you to know the advanced LLM concepts as well, then it is for you. Simple. Then the second component, which is like very important, which is RAG. Yes, we have covered almost all of the components that you need to know with RAG. So you are good with this thing. There is a small homework. You should create RAG with multiple service providers. You should go with, let's say, OpenAI. You should go with, let's say, Pinecone, all of these things. Okay, just go and just create these particular RAG databases with that. Simple. Very good. Then now comes the point of Langchain. Yes, we used Langchain in this particular tutorial. So you are already ready, or basically you have already completed a kind of Langchain tutorial. Trust me. But now if you just want to create advanced AI agents, maybe in your organization, they want you to build the complex agents with complex pipelines, then you should go with the further step of Langchain, which is LangGraph, because LangGraph is built on top of Langchain and it allows you to build everything from scratch. So now if you want to learn LangGraph, I can recommend you one book, but the thing is, the book is very good, but that version would be outdated because LangGraph is recently upgraded. So I do not know if that book is upgraded or not. So I do not want you to spend amount and still if you do not get any kind of knowledge. So I would recommend just go with the official documentation, okay, which will be the best source to learn. Plus, I have also created one detailed LangGraph full course with the recent upgrade 1.0 plus. So if you want to watch the tutorial, it is also there for you. So everything is available on YouTube. So you can literally go on YouTube, search the topic name that you need to learn, and just add Ansh Lamba as your prefix or suffix. You will find the video. You will find the course, the end-to-end course, one shot video. Simple. Again, the choice is yours. You can just learn from anywhere, but this is my personal recommendation and this is the resources that I personally used. Simple. So if I have used something, then only I will just recommend something, right? Simple formula, bro. So this is all about today's masterclass, and I hope that, because see, the intent behind this masterclass is just to help you all of my data fam, because you are literally the backbone of this particular AI era or AI boom. And you do not need to feel like, hey, AI is taking the jobs. Not exactly. Just stay away from the negativity, just stay positive, just learn the technologies, learn the tech stacks, and just do let me know, just do let this guy know. This guy will literally help you like how to just succeed, and I will let you know how you need to learn the tools and technologies, and that's it, simple. Okay. So if you love the video, I know you love the video, simply write a lovely comment in the video, share this video with your friends, like the video, and obviously subscribe the channel. It's so important for me, and I will see you in the next video. Till then, happy learning.